Halo? Andari lebih baik pakai ini atau pakai normal? Oh, tapi saya dengar suaranya. Dengar. Kalau omongan saya nggak dengar, tapi Anda dengar saya punya. Ada suaranya? Oke, gitu. Udah masuk ya, oke. Mute. Oke. Ya, makasih.
Udah.
National Research and Innovation Agency, a synergy in an orchestra.
Kalau saya dengar,
Established through the Presidential Regulation Number 78 of 2021 about the National Research and
Halo,
Innovation
Budi?
Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology Indonesia. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Indonesia terdapat 14,3 juta hektar lahan perkebunan kelapa sawit. Selama ini lahan perkebunan tersebut hanya dimanfaatkan untuk pertanaman monokrop. Padahal, produktivitas dan efisiensi lahan dapat ditingkatkan dengan diversifikasi, salah satunya dengan mengintegrasikan perkebunan sawit dengan pembiakan sapi. Lahan perkebunan yang sangat luas berpotensi sebagai sumber pakan hijauan murah untuk penggembalaan sapi. Dari sisi demand, Indonesia sangat membutuhkan pasokan anak sapi atau sapi bakalan untuk digemukkan. Pemerintah tengah menggalakkan pembiakan sapi di dalam negeri untuk mengurangi beban impor. Beberapa perusahaan telah menerapkan integrasi perkebunan sawit dengan pembiakan sapi ini. Misalnya PT Buana Karya Bakti di Kalimantan Selatan dan PT Kalteng Andini Palma Lestari di Kalimantan Tengah. Usaha yang mereka lakukan dinamakan Sistem Integrasi Sapi Kelapa Sawit, disingkat SISKA.
Manajemen kebun ternyata bisa mengintegrasikan sawit dengan sapi, yang kemudian bisa menghasilkan beberapa hal yang kami anggap itu adalah sesuatu yang baik. Suatu saat ini akan bisa menjadi bisnis alternatif sebagai diversifikasi.
Di lahan kelapa sawit tumbuh berbagai macam rumput yang merupakan gulma untuk perkebunan sawit. Namun, sebagian merupakan rumput yang bisa dimanfaatkan sebagai pakan sapi. Sapi digembalakan di bawah sawit, dan mereka bisa merumput dengan bebas. Dalam model SISKA, kebun sawit dibagi dalam beberapa blok penggembalaan. Kelompok-kelompok sapi dibiarkan menggembala dan makan di sebuah blok dan pindah ke blok lainnya keesokan harinya. Perputaran ini disebut sebagai rotasi grazing dan akan berjalan selama 3 bulan. Bagi perkebunan, sapi berperan sebagai biological mower yang membersihkan gulma dan mengurangi biaya pembersihan. Perkebunan pun berkurang ketergantungannya terhadap penggunaan herbisida dan bahan kimia lainnya.
Kita dari kebun dituntut untuk bisa efisien mengenai biaya perawatan. Nah, setelah adanya sapi, sekarang kita sangat terbantu, Pak. Pertama, untuk perawatan kita hanya selektif nih. Jadi, untuk gulma-gulma yang terbilang daun lunak, ini tidak kita kendalikan karena nanti bakal jadi makanan sapi. Kita hanya mengendalikan yang sifatnya berbatang keras seperti anakan kayu.
Ini adalah satu bisnis yang sangat efisien. Karena apa? Karena biaya untuk usaha peternakan itu adalah biaya pakan. Nah, ketika pakan itu bisa didapat dari sumber pakan alami yang ada di kebun sawit, yang pasti biayanya akan lebih murah.
Membiarkan sapi di perkebunan sawit tentu bukan hal mudah. Pengelolaan ternak dan perkebunan harus selaras, mengakomodasikan kebutuhan ternak sapi maupun pekerjaan di kebun, dan agar keduanya harmonis. Selain itu, ternak membutuhkan perhatian 24 jam per hari.
Sustainable food production for our growing world population requires modern breeding strategies and effective quality control procedures for agriculture and aquaculture. This can be achieved through the production of high-quality seeds and improved yield in plant and seafood farming. An important tool for breeding is the determination of ploidy levels. The ploidy level of an organism is characterized by the number of chromosomes pairs. This is specific to each species. Deviations from regular ploidy levels can have positive or negative effects on the individual. An increased number of chromosome sets, called polyploidy, can produce faster growing and bigger plants or seafood, or create plants with an increased production of secondary metabolites like essential oils. To get plants with seedless fruits, plant breeders produce triploid, sterile individuals. Checking the ploidy levels of such plants guarantees that only seedless fruits are formed. Negative effects can be induced by aneuploidy, characterized by an abnormal number of chromosomes. Aneuploid plants are often stunted. This makes checking for aneuploidy important in quality control of seed production. In all these instances, checking ploidy levels helps to improve yield, quality, and productivity. So farmers gain more benefits with the same amount of investment. For more than 35 years, Sysmex Partech has been the leading supplier of complete solutions for ploidy analysis, offering a broad range of dedicated reagents, instruments, and analyzing software optimized for different sample material and organisms like rice, potatoes, sugarcane, corn, and oysters. Even challenging oxidized plant material becomes easy to handle with our solutions. Sysmex's unique complete solution for ploidy analysis with dedicated instruments, reagents, and analysis software like the automated ploidy detection tool support manual and automated high-throughput measures and analysis in accordance with ISO and REACH guidelines. Start now and benefit from reliable, high-quality and cost-efficient solutions based on the Sysmex experience.
ICFAS Science Indonesia merupakan salah satu divisi bisnis dari ITS Group yang berkantor utama di Singapura. ITS Science Indonesia menawarkan berbagai macam instrumen analitik dan medis, peralatan laboratorium umum, bahan kimia, dan bahan habis pakai lainnya. Selama lebih dari 40 tahun, ITS Group bergerak maju dengan visi memberikan pengaruh di dalam industri yang kami jalani. Kultur perusahaan kami untuk selalu mengedepankan profesionalisme, partnership, dan performance. ITS Group tersebar di berbagai negara Asia Tenggara, yaitu Malaysia, Singapura, Thailand, Vietnam, Indonesia, Filipina, dan Kamboja. ITS Science Indonesia memiliki 2 kantor yang berlokasi di Kelapa Gading, Jakarta Utara, dan Sukomanunggal, Surabaya. Berikut portfolio produk yang kami representasikan di Indonesia. Produk-produk yang kami representasikan merupakan produk-produk unggulan di bidangnya. Selain itu, kami juga bangga bekerja sama dengan berbagai pihak, mulai dari lembaga pemerintah, industri, hingga universitas. Bila Anda memerlukan bantuan untuk laboratorium Anda, hubungi kami. ITS Science Indonesia, Bridging Science, Inspiring Possibilities.
Sukabumi, Kabupaten Sukabumi. Bagi kelompok tani kita bermanfaat sekali menggunakan biaya operasional, baik dari peternak yang biasanya mengembala itu menghabiskan dalam 2 hari itu 3 liter bensin. Manfaatnya itu satu, keduanya dari tingkat keamanan, dari tingkat pemeliharaan kita bisa terkontrol. Mudah-mudahan dengan adanya komunikasi dengan perusahaan kita bisa maju Pak di bidang ternak sapi ini.
Kalau ini kan dijaga baik.
Nama saya Sarif, asisten Abdeling Monorejo. Dengan adanya sapi di kebun itu, salah satunya adalah mengurangi biaya-biaya operasional yang ada di Abdeling. Kita ada koordinasi mengenai rotasi-rotasi grazing, kemudian kita berhubungan dengan rotasi-rotasi panen. Jadi itu yang sebagai patokan kami di Abdeling. Kami pegang ada semacam peta yang dibentuk, yang diolah rotasi dari blok ke blok. Kalau di sini untuk sementara rencananya semua blok Pak. Jadi 1052 hektar.
Semua orang berhak mendapat kesempatan yang lebih baik, dan kami percaya itu. Karenanya, sudah 30 tahun kami dedikasikan diri untuk berjalan denganmu, sahabat kami, para petani dari seluruh pelosok negeri. Sebuah mimpi besar, memang, tetapi kami yakin bisa dimulai dari langkah terkecil. Yang juga paling penting, seperti mengembangkan benih berkualitas hasil penelitian yang menjadi ciri khas kami. Jarak dan medan yang harus ditempuh bukan halangan bagi kami untuk terjun langsung ke lapangan. Kadang penuh keringat, kadang ditemani terik yang menyengat. Tak masalah, karena disinilah perjalanan kami bersamamu dimulai. Percobaan demi percobaan kami lakukan bersama untuk mencari mana varietas terbaik nantinya, yang kami rawat sepenuh hati dalam pengawasan terbaik, agar tiap benihnya mampu menyerap nutrisi bumi sepenuhnya, hingga mereka terus tumbuh sehat sampai hasil panen terlihat. Prosesnya memang panjang dan tak mudah, tetapi dengan inilah benih-benih terpilih sampai ke genggamanmu. Untuk kemudian dikemas menjadi produk cap panah merah yang akan membantu petani-petani selanjutnya. Kami sadar ada banyak hal yang masih harus dilakukan untuk maju bersamamu. Karenanya, pelatihan tercipta untuk kami, supaya bisa selalu siaga membantumu. Dan untukmu, kembangkan kemampuan bertani dengan bantuan ilmu serta teknologi terkini. Kami juga selalu siap menjawab setiap pertanyaanmu di setiap pendampingan yang kamu perlukan. Kami ada untukmu. Dan ketika kami melihatmu berhasil, mendapat kesempatan, serta mencapai apa yang kami mimpikan, itulah pencapaian terbesar kami dalam menjadi sahabat yang paling baik bagimu. Terima kasih telah berjalan bersama kami selama 30 tahun ini. Mari terus menjadi sahabat dalam berpuluh tahun mendatang. ICFAS Indonesia, sahabat petani yang paling baik.
ITS Science Indonesia merupakan salah satu divisi bisnis dari ITS Group yang berkantor utama di Singapura. ITS Science Indonesia menawarkan berbagai macam instrumen analitik dan medis, peralatan laboratorium umum, bahan kimia, dan bahan habis pakai lainnya. Selama lebih dari 40 tahun, ITS Group bergerak maju dengan visi memberikan pengaruh di dalam industri yang kami jalani. Kultur perusahaan kami untuk selalu mengedepankan profesionalisme, partnership, dan performance. ITS Group tersebar di berbagai negara Asia Tenggara, yaitu Malaysia, Singapura, Thailand, Vietnam, Indonesia, Filipina, dan Kamboja. ITS Science Indonesia memiliki 2 kantor yang berlokasi di Kelapa Gading, Jakarta Utara, dan Suku Manunggal, Surabaya. Berikut portfolio produk yang kami representasikan di Indonesia. Produk-produk yang kami representasikan merupakan produk-produk unggulan di bidangnya. Selain itu, kami juga bangga bekerja sama dengan berbagai pihak, mulai dari lembaga pemerintah, industri, hingga universitas. Bila Anda memerlukan bantuan untuk laboratorium Anda, hubungi kami. ITS Science Indonesia, Bridging Science, Inspiring Possibilities.
adalah tulang punggung penyedia pangan dan lapangan kerja bagi ratusan juta penduduk Indonesia. Pertanian juga menjadi poros pemeliharaan lingkungan dan pemberdayaan masyarakat pedesaan, memberikan dukungan bagi industri-industri lain dalam meningkatkan perekonomian nasional. Namun, pertanian Indonesia menghadapi berbagai macam tantangan. Perubahan iklim, banjir, kekeringan, alih fungsi lahan pertanian, serangan organisme pengganggu tanaman, penggunaan teknologi 4.0 juga seiring dengan pertumbuhan penduduk dunia yang meningkat pesat, dunia termasuk Indonesia dihadapkan pada ancaman kekurangan pangan. Berbagai cara dilakukan untuk menghadapi tantangan tersebut. Salah satunya, adopsi teknologi pertanian berbasis produk rekayasa genetik.
Masuk,
Tanaman. Buah-buahan yang tidak mudah busuk, tahan infeksi tanaman virus, produk tanaman yang sehat dan bebas hama, penggunaan produk perlindungan tanaman yang memenuhi standar, serta penggunaan teknologi berkelanjutan pada pertanian. Bioteknologi tanaman dalam pertanian selalu memastikan para petani mendapatkan teknologi terbaik untuk kebutuhan pertanian berkelanjutan yang berkontribusi pada ketahanan pangan dengan mengedepankan kajian ilmiah untuk memastikan keamanan pangan, pakan, dan lingkungan.
Bismillah.
CropLife Indonesia merupakan bagian dari federasi global yang beranggotakan asosiasi regional dan nasional dari 91 negara. CropLife Indonesia merupakan asosiasi nirlaba yang mewakili kepentingan petani industri benih dan pestisida. CropLife Indonesia bertujuan mempromosikan pertanian berkelanjutan untuk kepentingan petani, konsumen, dan keberlanjutan lingkungan hidup. Sebagai organisasi yang mewakili kepentingan petani, konsumen, industri benih dan pestisida, CropLife Indonesia berkomitmen menjunjung tinggi kajian ilmiah dan mendukung pelaksanaan peraturan pemerintah demi terwujudnya penyediaan teknologi baru bagi pertanian. Berfokus pada penelitian, pengembangan, dan edukasi pertanian untuk menghasilkan manfaat maksimal pada penggunaan yang aman dan berkelanjutan pada produk pertanian. Memerangi dan memberantas produk pertanian palsu dan ilegal yang bersinergi dengan pemerintah dan aparat penegak hukum. Meningkatkan pengetahuan dan pemahaman publik pada industri, adopsi teknologi, dan mitigasi risiko pertanian untuk meningkatkan kualitas hasil pertanian.
Iya Pak. Salam.
Kualitas, serta penggunaan teknologi.
Enggak Pak, langsung di email Pak. Email yang
pada
pertama.
Berbagi peran demi kepentingan petani, industri benih dan pestisida.
Ya, ada linknya, ada passcode-nya, ada itunya, meeting ID-nya.
Kajian ilmiah yang bersifat objektif dan dapat
Suara jelas sekali Bu Buji, dengar nggak?
Sebagai upaya
Saya dengar.
Oke. Agar dapat menghasilkan
Ya,
manfaat
dengar nggak?
produk
Ya,
perlindungan tanaman. Sebagai peran dalam penegakan hukum dan kampanye anti pemalsuan yang bersinergi dengan pemerintah. Sebagai upaya peningkatan efektivitas dan efisiensi dalam pengendalian resistensi pestisida. Demi terwujudnya pengetahuan dan pemahaman publik mengenai industri pestisida, mitigasi risiko, dan manfaatnya dalam membantu meningkatkan kualitas hasil pertanian. Sebagai upaya membantu petani memenuhi kebutuhan pertanian dengan bioteknologi tanaman terbaik dan berkelanjutan. CropLife Indonesia akan bersinergi dan menjadi salah satu kekuatan sumber daya pembangunan nasional dalam memajukan industri dan penyaluran produk benih dan bioteknologi perlindungan tanaman. Juga berkontribusi untuk meningkatkan ketersediaan pangan dan standar hidup petani kita, serta konsumen dalam semua aspek, baik ekonomi, sosial, dan lingkungan.
kira kedepannya sangat baik prospeknya di kedua sisi ya, baik dalam peningkatan sawit itu sendiri maupun peningkatan produktivitas di Shopee ya, pengembangan daging nasional.
Dan kami harapkan bahwa SSP ini bisa mendampingi sampai dengan tahun 2026 atau bahkan seterusnya selama pengembangan Siska dilaksanakan di Provinsi Kalimantan Selatan.
Adalah tulang punggung penyedia pangan dan lapangan kerja bagi ratusan juta penduduk Indonesia. Pertanian juga menjadi poros pemeliharaan lingkungan dan pemberdayaan masyarakat pedesaan, memberikan dukungan bagi industri-industri lain dalam meningkatkan perekonomian nasional. Namun, pertanian Indonesia menghadapi berbagai macam tantangan. Perubahan iklim, banjir, kekeringan, alih fungsi lahan pertanian, serangan organisme pengganggu tanaman, penggunaan teknologi 4.0 juga seiring dengan pertumbuhan penduduk dunia yang meningkat pesat, dunia termasuk Indonesia dihadapkan pada ancaman kekurangan pangan. Berbagai cara dilakukan untuk menghadapi tantangan tersebut. Salah satunya, adopsi teknologi pertanian berbasis produk rekayasa genetik dan inovasi pemulihan tanaman. Buah-buahan yang tidak mudah busuk, tahan infeksi tanaman virus, produk tanaman yang sehat dan bebas hama, penggunaan produk perlindungan tanaman yang memenuhi standar, serta penggunaan teknologi berkelanjutan pada pertanian. Bioteknologi tanaman dalam pertanian selalu memastikan para petani mendapatkan teknologi terbaik untuk kebutuhan pertanian berkelanjutan yang berkontribusi pada ketahanan pangan dengan mengedepankan kajian ilmiah untuk memastikan keamanan pangan, pakan, dan lingkungan. Indonesia merupakan bagian dari federasi global yang beranggotakan asosiasi regional dan nasional dari 91 negara. CropLife Indonesia merupakan asosiasi nirlaba yang mewakili kepentingan petani industri benih dan pestisida. CropLife Indonesia bertujuan mempromosikan pertanian berkelanjutan untuk kepentingan petani, konsumen, dan keberlanjutan lingkungan hidup. Sebagai organisasi yang mewakili kepentingan petani, konsumen, industri benih dan pestisida, CropLife Indonesia berkomitmen menjunjung tinggi kajian ilmiah dan mendukung pelaksanaan peraturan pemerintah demi terwujudnya penyediaan teknologi baru bagi pertanian. Berfokus pada penelitian, pengembangan, dan edukasi pertanian untuk menghasilkan manfaat maksimal pada penggunaan yang aman dan berkelanjutan pada produk pertanian. Memerangi dan memberantas produk pertanian palsu dan ilegal yang bersinergi dengan pemerintah dan aparat penegak hukum. Meningkatkan pengetahuan dan pemahaman publik pada industri, adopsi teknologi, dan mitigasi risiko pertanian untuk meningkatkan kualitas hasil pertanian. Produksi produk perlindungan tanaman yang aman dan berkualitas, serta penggunaan teknologi berkelanjutan pada pertanian. Divisi pada CropLife Indonesia berbagi peran demi kepentingan petani, industri benih, dan pestisida. Sebagai mitra bagi pemerintah dalam mendukung pelaksanaan peraturan dengan menjunjung tinggi kajian ilmiah yang bersifat objektif dan dapat dipertanggungjawabkan. Sebagai upaya untuk membimbing petani agar dapat menghasilkan manfaat maksimal dari produk perlindungan tanaman. sebagai peran dalam penegakan hukum dan kampanye anti pemalsuan yang bersinergi dengan pemerintah. Sebagai upaya peningkatan efektivitas dan efisiensi dalam pengendalian resistensi pestisida. Demi terwujudnya pengetahuan dan pemahaman publik mengenai industri pestisida, mitigasi risiko, dan manfaatnya dalam membantu meningkatkan kualitas hasil pertanian. Sebagai upaya membantu petani memenuhi kebutuhan pertanian dengan bioteknologi tanaman terbaik dan berkelanjutan. CropLife Indonesia akan bersinergi dan menjadi salah satu kekuatan sumber daya pembangunan nasional dalam memajukan industri dan penyaluran produk benih dan bioteknologi perlindungan tanaman. Juga berkontribusi untuk meningkatkan ketersediaan pangan dan standar hidup petani kita, serta konsumen dalam semua aspek, baik ekonomi, sosial, dan lingkungan.
Masuk enggak? Suaranya enggak? Masuk. Tetap. Enggak ada mengerti. Oke, masuk. Enggak. Nah, ini mati. Enggak, ini mati soalnya. Enggak. Saya ngomong. Terus nama ininya speaker di sini. Speaker ini ini nggak full, ini executive ininya off speakernya. Pasangannya berarti off semua baterai.
Gitu.
Biar nggak saling gema. Gitu. Itu aja sih. Aku berarti Pak Tri ngomong.
Halo?
Ngomong aku sih Pak Tri siapa? Jadi gini maksudnya speakernya itu Pak. Masuk. Jadi nanti pas baca kayak mendengar salatan. Juga
Tes. Ya, oke.
Ya. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Benar-benar berharga bagi saya.
Excellency Chairman of the tapi ada jeda ya,
Tidak secara teori,
Tapi juga praktis secara langsung di lapang, terutama mengenai integrasi sawit sapi dan juga manajemen perkebunan.
harapan saya bisa belajar lebih lanjut di
Australia. MBKM PT Siska, always be the best. Yes, yes, yes.
sekarang. Mulai tadi saya kalau pakai yang hybrid,
Coba kunci. Tes. Kunci setengah tes masuk. Oke. Ya udah, pakai yang ini aja Bu Andari. Bu Andari. Tes. Tes. Oke, ya. Bagus, Pak.
Ladies and gentlemen, the opening ceremony will be commenced soon. All participants are kindly requested to mute the microphone. Please make sure you have a good internet connection and kindly attend the conference session. Thank you for your kind attention and cooperation. Assalamualaikum warahmatullahi wabarakatuh. Shalom. Om Swastiastu, Namo Buddhaya, Salam Kebajikan. A very good morning to Excellencies, distinguished guests, speaker, participants, ladies and gentlemen. Thank you very much for being with us in our big event, the first International Conference on Food and Agricultural Sciences, or ICFAS, organized by Research Organization for Agriculture and Food, National Research and Innovation Agency, Republic of Indonesia. I am Rismayani as Master of Ceremony for this event, and it is a great honor for me to host this conference. Ladies and gentlemen, welcome to the opening ceremony of the first International Conference on Food and Agricultural Sciences, ICFAS, Thursday, 24th of November 2022, with the theme, Advanced Agricultural Technology to Deal with Climate Change Issue for Achieving Food Security. The organizing committee has included interesting programs, including keynote addresses from distinguished and eminent speakers, as well as presentations from participants, both local and international. We are confident that this conference will be an event to create the opportunity to share and learn on the latest innovation and knowledge of food and agricultural sciences, and hopefully an occasion to remember for us all. Before we proceed, to the program today, we would like to express our sincere gratitude to our keynote speakers, the Excellency, Chairman of National Research and Innovation Agency, Bapak Laksana Trihandoko, PhD, or the representative, Bapak Mego Pinandito, PhD, the Deputy Chairman of Policy Development National Research and Innovation Agency, the Honorable Chairman of Research Organization for Agriculture and Food, Ibu Puji Lestari, PhD. And we also want to express our gratitude to our invited speakers. Ibu Sastia Pramaputri, PhD from Osaka University, Japan. Professor Dr. Roger Higerty from AG Research, New Zealand. Professor Dr. Yandra Arkeman from IPB University, Indonesia. Bert Panis, PhD from the Bioversity International Leuven, Belgium. Ibu Dr. Ratih Pangestuti from National Research and Innovation Agency. The President of Indonesian Biotechnology Consortium, Bapak Mastur, PhD. Professor Dr. Cepi Sujana from Indonesian Association of Integrated Cattle Oil Palm Entrepreneurs and Observers, or GAPENSISCA. The Director of Biotechnology Affairs, CropLife Asia, Ibu Soni Tababa, MSc. Professor Dr. Hiroshi Ehara from Nagoya University, Japan. Dr. Sunil Archak from the National Bureau of Plant Genetic Resources, India. Dr. Charles Masembe from College of Natural Science, Makerere University, Uganda, and all the participants. We also like to thank to our sponsor who support this event, Indonesian Association of Integrated Cattle Oil Palm Entrepreneurs and Observers, or GAPENSISCA, Indonesian Biotechnology Consortium, CropLife Indonesia, ITS Sciences Indonesia, East West Seed Indonesia, Elokarsa Indonesia, Cultiva Life Science, Peripi, and Peragi. Excellencies, distinguished guests, delegates, ladies and gentlemen, now please let us sing Indonesian National Anthem, Indonesia Raya. Please, all the participants are kindly requested to follow wisely. Thank you very much. Excellencies, distinguished guests, ladies and gentlemen, to begin our event, we would like to have a moment for a prayer recitation, which will be delivered in Islam. Participants, please adjust accordingly. To Bapak Irfan Badrul Jamal, please, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, let us bow our head for a moment. Pray to God, Allah Subhanahu wa Ta'ala, so that our international conference can be precious to all of us. I will lead this prayer based on the teaching of Islam, and those who are not Muslims, you are placed to pray according to each of your beliefs. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين حمدا شاكرين حمدا ناعمين حمدا يوافي نعمه ويكافي مزيده يا ربنا لك الحمد ولك الشكر كما ينبغي لجلال وجه الكريم وعظيم سلطانك اللهم صل على سيدنا محمد وعلى آل محمد اللهم اغننا بالعلم وزينا بالحلم واكرمنا بالتقوى وجاملنا بالعافية اللهم اجعلنا الشكور واجعلنا الصبور اللهم إنا نسألك سلامة في الدين وعافية في الجسد وزيادة في العلم وبركة في الرزق وتوبة قبل الموت ورحمة عند الموت ومغفرة بعد الموت اللهم اغفر لنا ولوالدينا وللمسلمين والمسلمات والمؤمنين والمؤمنات الأحياء منهم والأموات إنك سميع قريب مجيب الدعوات ويا قاضي الحاجات يا الله يا رحيم. Praise be to God, the Lord of the world. Peace and blessing be upon our Prophet Muhammad sallallahu alaihi wasallam and his companions, and for those who followed his example till Judgment Day. Oh Allah, today we gather here to participate in the first international conference on agriculture and food science. Make this international conference a useful science assembly, a medium for sharing beneficial ideas, knowledge, and experience of scholars, researchers, and students of various disciplines. May the conference benefit our lives, broaden our knowledge, shine our ideas, and lead us to be successful, productive persons, which will boost our nation dignity. Oh Allah, guide and bless our heart and our mind with the light of your guidance. Impart your supreme wisdom upon our activities. Help us to speak our mind clearly. Help us to listen to each other, respect to each other, love each other, so that we are included to the blessed persons. Oh Allah, protect us from unintended temptation. Show us the right path and give us knowledge and strength to perform good things. Equally, show us and make the bad things clear and give us a knowledge and strength to avoid them. Special doa for people in Cianjur. Allahumma gfir lahum warhamhum wa'afihim wa'afu anhum. Allahumma ratahrimna ajrahum wa taftinna ba'dahum waghfir lana wa lahum. Allahumma rabban nas adhhib bil ba'sa ishfihi wa anta syafi la shifa illa shifa'u shifa la yughadiru mustaqama. Rabbana afriq alaina sabr Rabbana afriq alaina sabr wa sabit aqdamana wa ansurna 'alal qawmil kafirin. Oh Allah, we offer prayers for the victim of the earthquake disaster in Cianjur. Give your vision to people of Cianjur. May the deceased husnul khatimah and the wounded be given healing and patience. Oh Allah, you are the one who can fulfill our dua. Rabbana la tuzigh qulubana ba'da idh hadaytana wa hab lana min ladunka rahmah innaka antal wahhab. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzaban nar. Wa adkhilna al-jannata ma'abrar ya aziz ya ghafar ya rabbal alamin. Subhana rabbika rabbil izzati amma yasifun. Wassalamun alal mursalin walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Excellencies, our distinguished guests, ladies and gentlemen, we would like to invite the chairman of ICFAS 2022 committee, Bapak Tri Puji Priyatno, PhD, to deliver the program report. To Bapak Tri Puji Priyatno, PhD, please, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Give me great pleasure to welcome you to the first international conference on food and agricultural sciences ICFAS 2022. And I would like to acknowledge government representative and keynote speakers here with us today. The Honorable Dr. Laksana Tri Handoko, Chairman of National Research and Innovation Agency, represented by the Deputy Chairman of Policy Development, the Honorable Puji Lestari PhD, Chairman of Research Organization for Agriculture and Food, the Honorable Dr. Sastia Pramaputri, Associate Professor, Graduate School of Engineering, Osaka University, Japan, the Honorable invited speakers, distinguished guests, presenter, sponsor, and all participants ICFAS 2022. Ladies and gentlemen, the theme of ICFAS 2022 is Advanced Agricultural Technology to Deal with Climate Change Issue for Achieving Food Security. The conference is an annual event organized by the Research Organization for Agriculture and Food, National Research and Innovation Agency, that aim to bring together researchers, scientists, lecturers, engineers, scholars, students, and practitioners interested in the advanced technologies of agriculture and food, including climate change, smart farming, pre- and post-harvest technologies, food and nutrition securities, agriculture and food supply chain system, and related topics. The first ICFAS 2022 provide a forum for exchange of information on state-of-the-art research within all of the related topic, as well as aim to build and strengthen scientific cooperation among the research institution. Ladies and gentlemen, the conference is held virtually on 24 to 25 November 2022. On the first day, after the opening ceremony, we will have two plenary sessions with invited speaker and followed by paper presentation at parallel session. At plenary session, there will be a Professor Hiroshi Ehara, Director and Lecturer in International Center for Research and Education in Agriculture, Nagoya University, Japan. Professor Yandra Arkeman, Lecturer of Department of Agro-Industrial Technology, IPB University, Indonesia. Professor Roger Hegarty from AG Research, New Zealand. Professor Cepi Sujana from Kapensiska, Indonesia. And Dr. Charles Masembe from College of Natural Science, Makerere University, Uganda. Ladies and gentlemen, on day 2, Dr. Sastia Pramaputri will be our honorable keynote speaker. She will deliver a presentation in metabolomic application for food quality improvement and reducing of food loss. We will have another 2 plenary sessions before the parallel session. At plenary session, there are 5 invited speakers will share their knowledge. The first, Dr. Rati Pangestuti, researcher of National Research and Innovation Agency. The second, Ms. Soni Tababa, Director of Biotechnology Affairs, CropLife Asia. Mastur PhD, President of Indonesian Biotechnology Consortium. Dr. Sunil Archak, researcher of National Bureau of Plant Genetic Resources, India. And then Dr. Bart Panis, senior researcher of Biodiversity International, Leuven, Belgium. Ladies and gentlemen, in this moment, I also would like to express my appreciation to the author who already submitted their manuscript to ICFAS 2022. In total, 700 manuscripts were submitted to the organizer for review process. From those number, the reviewer granted 354 manuscripts to be accepted for presentation and publication at AIP publisher. Last but not least, my warm appreciation and thanks to the sponsor that's supporting the implementation of ICFAS 2022, including Indonesian Biotechnology Consortium, Gabungan Pelaku dan Pemerhati Sistem Integrasi Sapi Sawit, Kapensiska Indonesia, CropLife Indonesia, ITS Science Indonesia, ICFAS Indonesia, Elokarsa Utama, Cultiva Life Sciences, Perhimpunan Ilmu Pemuliaan Indonesia, and Perhimpunan Agronomi Indonesia. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Big applause to Bapak Tripuji Priyatno, and thank you for the speech. Excellencies, our distinguished guests, ladies and gentlemen, it's a great honor to invite Ibu Puji Lestari PhD, the chairman of Research Organization for Agriculture and Food, to officiate our conference. To Ibu Puji Lestari PhD, please, time is yours.
Thank you, Master of Ceremony. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. A very good morning, everyone. First, I would like to thank and deliver my sincere gratitude to Excellency Chairman of the National Research and Innovation Agency of the Republic of Indonesia, Dr. Laksana Handoko, represented by the Deputy Chairman of Policy Development, Mego Pinandito, PhD, Honorable Associate Professor, Graduate School of Engineering, Osaka University, Japan, Dr. Sastia Pramaputri, Honorable Invited Speakers, Professor Hiroshi Ihara from International Center for Research and Education in Agriculture, Nagoya University, Japan, Professor Yandra Arkeman from Department of Agro-Industrial Technology, IBB University, Indonesia, Professor Roger Higarty, Senior Scientist, Agricultural Research, New Zealand, Professor Cepi D. Sujana from Gapensiska, Indonesia, Charles Masembe, PhD, Associate Professor from College of Natural Science, Makerere University, Uganda, Dr. Ratih Pangestuti, Researcher at the National Research and Innovation Agency, Indonesia, Mrs. Sonita Baba, MSc, from Biotechnology Affairs, Manager, CropLife Asia, Master PhD, President of Indonesian Biotechnology Consortium, Dr. Sunil Arcak, Teacher of Agricultural Knowledge Management, Unit National Bureau of Plant Genetic Resources, India, and Bart Panis, PhD, Senior Researchers from Biodiversity International Leuven, Belgium. Honorable invited guests from National Research and Innovation Agency and other research organizations, distinguished participants, ladies and gentlemen, our audience joining us online. Let us say grace to the Almighty God, our Subhanahu wa Ta'ala, as His will that we are gathered today in good health to take part in the first International Conference on Food and Agricultural Science 2022, ICFAS. Excellencies, distinguished guests, ladies and gentlemen, I would like to extend a warm welcome to all of you at this conference. The first ICFAS with theme, Advanced Agricultural Technology to Deal with Climate Change Issue for Achieving Food Security, is organized by Research Organization for Agriculture and Food under National Research and Innovation Agency, BRIN, in collaboration with Indonesian Biotechnology Consortium and supported by Gabungan Pelaku dan Pemerhati Sistem Integrasi Sapi Sawit Gapensiska Indonesia, CropLife Indonesia, ITS Science Indonesia, ICFAS Indonesia, Elokarsa Utama, Cultiva Life Science, Peripi, and Peragi. Over the next 2 days, we will discuss the advanced technologies for agriculture and food, including climate change, smart farming, pre- and post-harvest technologies, food and nutrition securities, agriculture and food supply chain system, and related topics on agriculture and food. Distinguished guests, ladies and gentlemen, allow me to introduce our institution. The National Research and Innovation Agency, or in short, NRIA, or BRIN in Bahasa, Badan Riset dan Inovasi Nasional, established in 2021, is a non-ministerial government institution in Indonesia mandated to conduct research, development, assessment, application, and integrated invention and innovation. BRIN has 12 research organizations as executing counterparts for the research activity. One of them is the Research Organization for Agriculture and Food, or in short, ROAF, which was established in March 2022, which houses researchers from several research institutions with relevant expertise. ROAF BRIN has tasked to carry out the agricultural sector's research and development activity by implementing advanced scientific approaches such as breeding, biotechnology, digital technology, robotics, and appropriate management that have a high scientific recognition and impact values. ROA BRIN has 6 research centers divided based on commodities or research areas related to agriculture and food, namely Research Center for Food Crops, Research Center for Horticulture and State Crops, Research Center for Animal Husbandry, Research Center for Food Technology and Processing, Research Center for Agro-Industry, and Research Center for Appropriate Technology. In this 2-day event, we'll find the scopes of the research centers in spirit parallel sessions. Distinguished guests, ladies and gentlemen, the agricultural sector is a very important source of food and for humankind. It has a strategic function to support the resolution of environmental and social problems. The sector has been more resilient to the prolonged monetary crisis and pandemic. Global food security is a top priority. The increase in food prices these past recent years unveiled the weakness of the global food system. The growing population and situation of supply and demand are clear grounds as to why we must expand our focus and effort on the agriculture sector to combat the threat of rising hunger. This concern has been emphasized at several international forums, including the recent G20 meetings, and the development has been seen in certain emerging nations. At the highest level, it has been agreed that transforming our food system to be sustainable, equitable, and resilient will lead to economic, social, and environmental benefits. Ladies and gentlemen, the agricultural development strategy must revert to the paradigm of agriculture for development due to the vital role of the agricultural sector as a driver of balanced and comprehensive development transformation. The agricultural development framework must be implemented at the macro and micro levels. At the micro level, national economic development is designed and implemented in line with the stages of agricultural development and makes the agricultural sector the driving force for national development. While at the micro level, agricultural development needs to focus on developing sustainable agriculture-based industry system. Distinguished guests, ladies and gentlemen, 2 main issues that have been the focus of ROAF BRIN recently are climate change and food security and the green economy as well. Innovative smart farming and digital and precision agriculture technologies are important mediums for transforming agri-food system. Hundreds of research papers produced by BRIN, ICFAS, and reputable scientists from more than 5 participating countries will be presented in this conference. We hope the knowledge and experience sharing in these next 2 days will be highly beneficial and encourage new ideas and collaboration among us. Excellencies, distinguished guests, ladies and gentlemen, on behalf of the organizing committee, I would like to thank all of you for your participation and support. Without which this conference would be impossible. Last but not the least, I would like to express my heartfelt gratitude to our committees whose endless dedication has been invaluable in implementing this event. Finally, I wish you all a most fruitful and enjoyable conference. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Big applause to Ibu Puji Lestari, PhD, and thank you for officiating the conference today. The National Research and Innovation Agency, or called BRIN, is a government institution with mandate to carry out centrally the research, development, assessment, and application of invention and innovation in Indonesia. 12 research organizations are built to execute this mandate. As one of the research organizations under National Research and Innovation Agency, or BRIN, Research Organization for Agriculture and Food focuses on agriculture and food research. This research organization, chaired by Puji Lestari and coordinating 6 research centers from on-farm to off-farm areas, which are Research Center for Food Crops, Research Center for Horticultural and Estate Crops, Research Center for Animal Husbandry, Research Center for Food Technology and Processing, Research Center for Agro-Industry, and Research Center for Appropriate Technology. Research Center for Food Crops are dealt with crop improvement and integrated crop management on rice, cereals, legumes, and tuber crops to provide innovative technology that increasing productivity with higher quality, efficiency, and sustainability. Various fruits, vegetables, ornamental, aromatic, palms, fiber, and sweetener crops are the core of the Research Center for Horticultural and Estate Crops. The strategic goals of this center include increasing productivity, added value, and competitiveness, developing precision and digital technology innovations, environmentally friendly and sustainable technological innovations, and supporting the development of bio-industrial and bioeconomic areas. Research Center for Animal Husbandry dealt with large and small ruminants, poultry, and forage crops to create innovative animal husbandry and animal health technologies in an integrated manner by increasing livestock production and productivity, food quality and safety, efficient use of resources, environmentally friendly, and sustainability in the livestock business. Research Center for Food Technology and Processing focuses on research on food production that is safe, quality, complete with nutrition and quality standards globally. The research scores include food ingredients, basic and advanced processes, preservation, and food programs such as the World Center for Halal Research and National Stunting Program. Research Center for Agro-Industry focuses on increasing the quantity, quality, and economic value of agro products by utilizing natural resources in sustainable agriculture and development agricultural industry that reducing agricultural losses, maintain quality, and increasing added value.
Research Center for Appropriate Technology focuses on mastering appropriate technology of pre- and post-harvest agriculture that supports small and medium enterprises' innovation in processing regional commodities and increasing the competitiveness of innovative of their product in the new normal era and Industrial 4.0. In order to share the research results and ideas on agriculture and food sector, today, Research Organization for Agriculture and Food, National Research and Innovation Agency, proudly present the first International Conference on Food and Agricultural Sciences, or ICFAS, with theme Advanced Agricultural Technology to deal with climate change issue for achieving food security. There will be 9 research scopes presented. Two special keynote speakers from National Research and Innovation Agency and Osaka University. In total, 10 worldwide invited speakers will talk in this conference. In total, 10 worldwide invited speakers will talk in this conference. And more than 300 participants will gather in parallel sessions in this 2 days conference. We would like to offer highest gratitude to Gapen Siska, Crop Life, ITS Indonesia, East West Indonesia, Elo Karsa, Cultiva Life Science, Peripi, and Peragi for supporting this conference. Finally, thank you for your participation and enjoy the fruitful event in these 2 days. The nation. Excellencies, distinguished guests, ladies and gentlemen, before we continue our program, on behalf of the committee, we would like to say thank you very much and welcome to Bapak Mego Pinandito, PhD, the Deputy Chairman of Policy Development, National Research and Innovation Agency. Next, we have a special keynote address delivered by the Honorable Bapak Laksana Trihandoko, PhD, the Chairman of National Research and Innovation Agency, and will be presented by Bapak Mego Pinandito, PhD, the Deputy Chairman of Policy Development, National Research and Innovation Agency. To Bapak Mego Pinandito, PhD, please, time is yours.
Okay, thank you. Thank you very much to Ibu Risma as the moderators committee. Assalamualaikum warahmatullahi wabarakatuh. Very good morning for all of the guests. Honorable Associate Professor from the Graduate School of Engineering, the Osaka University of Japan, Ibu Dr. Sastia Pramaputri, honorable invited speakers that I could not mention one by one. It is my great pleasure to meet all of you. It's around 10 invited speakers today and also tomorrow. Honorable invited guests for the National Research Innovation Agency of Indonesia and other research organization. distinguished participants, ladies and gentlemen, our audience that joining with us online. Of course, our Honorable Ibu Dr. Puji Lestari, the chair of the Research Organization for Agriculture and Food, the National Research and Innovation Agency of Indonesia. Very good morning, and in this special occasion, I would like to deliver my thanks to all of the organizing committee that give the opportunity, and I will deliver a speech of the chairman of the National Research and Innovation Agency. And ladies and gentlemen, I'm not sure that I'll try to share some slides. Is it okay to?
Yes.
Okay.
Okay.
Thank you. And yes, I think if we look at the situation today, the world situation in agriculture and food, we know that the demand for the food is multiplying along the increasing of the human populations and the choice of the preference and needs. And we know that to catch the food demand in the sustainable conditions, like the appropriate sciences, technology, and innovation will give the significant contribution. It means that farmers and the food producers need to be supported by the research and innovation, especially in Indonesia, is from BRIN. And of course, with several university and the private research organization. And if you look at the key comparison or the principle, we know that the nutritious and accessible food for everyone, and with the natural resources, if we manage, we can also get some support and good condition to the future. The principle of the sustainable for the food and agriculture, it is, for example, to increase the productivity, the employment and value added in the food system, that is should be combined with the farmers, with almost all of their stakeholders. The second one is to protect and enhance the natural resources. The third one is improve the livelihood and also to foster the inclusive economic growth. And the fourth one is to enhance the resilience of the people, community, and ecosystem itself, and adapt the governance to the new challenges. I think if we look at what we can see here, the challenges of the sustainable agriculture and food itself, there is many issues, 1, 2, 3, 4, 5, 6, 7, 8. But of course, we can also focus on, for example, the population increase. So the sustainable nurses of the global population around 9.7 billion in 2015. It will require the food system that inclusively sustainable, efficient, nutrition, and healthy. The other thing that we have to do in Indonesia and in several countries, like the food security, the access to the quality, the nutritious food fundamental to the human, and of course the secure the access to food can produce the wide ranging of the positive impact, including the economic growth and also the poverty reduction. The other thing, and it is faced by almost all of the countries, is about the climate change. The lower rainfall will lead to the longer period of drought, meaning that the amount of the land which was previously adequate supplied with water is reduced. We can see, for example, from the announcement by the global climate change information, that the time is now changes from the La Nina to El Nino. That means that it is very need or very important to be monitored, as well as how we can solve the problem in the future. The other things is lost the usage land. I mean, how the lands from the agriculture and changes into the industrial or the residential development, and of course the energy, why the agriculture is playing increase. For example, from food to the bioenergy for electricity and so on, are very interesting to be monitored. And the other things is the political and the legal requirement. Ladies and gentlemen, regarding to the in the 1996 from the World Food Summit, we know that the research, innovation, and policy needs are important and essential to support the strategy of the sustainable agriculture for food security and for the food sovereignty, so that we can see that the R&D policy and also the policy support can play the important roles in the area, for example, in the efficiency of the resources, the improving of the community welfare, especially for the rural area, and equity, conservation, protection, wise use of the natural resources, and increasing the resilience of the community and the ecosystem, and also the population and the activities of the government policies, so that we can see in the future how we can set the main research questions. For example, how to improve the agricultural productivity and efficiency of the use of the resource. That means how to use the in efficient ways the land, water, and the nutrition. And the second one is how to optimize the management of the ecosystem services in field of the land and the landscape to improve the productivities. And the other thing is how to optimize the food chains to improve the resource use efficiency, including we know that somehow how to reduce the food waste, food losses, and using the co-production and byproducts, and to promote the access of the smallholders of the market and consumers to the diverse and nutritious food. The fourth one is how to improve the agriculture, food, nutrition, and of course with the human health, and next and the rural-urban linkage through the social and economic studies and intervention. So it means this problem is not only what we call responsible to the people who do research and innovation in the agriculture, but of course we have to get a collaboration with the social and economic studies, people who are know very well about the situation in the social aspect, and also how to make it into the economic growth. Ladies and gentlemen, and this it is just to show that the agricultural innovation cannot be accomplished, cannot be solved only by the agriculture community, but we have to get engagement with all stakeholders that should be a part of this creating the agricultural innovation system. Means we have to get more in engagement with the political system, the science and technology policy, and of course with the scientists, the researchers, the science actors, and also the technology from other sector. It means we have to look at for example, the food producer, the manufacturers, and also the industries. It is very important to know how they can also get some solution. Next is this is the roadmap of the sustainable agriculture research at the research organization. I think later, and also just in the before, the Ibu Puji has also shown the roadmap. But again, how to the global national issue for the agriculture and food security. There is 6: increase in the productivity, the capacity, we have to have the national problem that is including the linkage with the global problem regarding to the stunting prevention, to increase the efficiency and competitiveness. And we now facing a little bit regarding to the food price stabilizations, and also the increasing the value added and export and the future food commodities. Now we face some of the what we call the 2022 to 2020 to 2023, 2024, that again, it is also linked with the agricultures and also other field. For example, with the IoT utilization, we can also look at the local potential, the genetic-based agriculture research, precision agriculture, intensive agriculture, and also the adaptive agricultural research itself. So linkage with the, for example, the industrial revolution of the 4.0, it is very useful and very important to get engagement with other field. And Excellencies, distinguished guests, ladies and gentlemen, if we look at the several R&D activities, again, the integrated crops management recommendation, strengthening the agricultural innovation and improving the competitiveness of the product process, the agriculture product itself, and reducing the import is several aspect that Indonesia especially try to get more and more in contribution coming from the research and innovation. This is just a little bit what we call the management, the crops management integrated, especially to support the precision technology for the production or from the agriculture. For example, the research focus on the agronomy, crops psychology, nutrition management, biohormone, crops modeling, and so on. But again, for example, if we look at the green economy orientation and also doing research in agricultural practices without giving the harmful for the environment, I think it is very useful. And if you look at the target, the output 2022 and this year until 2 years in future, 2024, that is including the integrated crop managements until the biofertilizer in increasing the crop's immune system and more nutrient yields, crops of phenotyping and crops models from for the identification of the best cultural practices and modeling on the crops interaction, land, water, and microbes. I think this is also what we'd like to get and achieve within 2 years. So hopefully the doing research and collaboration with other institution, not only in Indonesia, but of course our neighbor countries is very important. Excellencies, distinguished guests, ladies and gentlemen, if you like the Agriculture and State Crops Research Center focus on the green economy, we look at the green economy oriented agriculture and also how and that it will create the sustainable culture by doing agriculture practices. And if you look at the green economy is equal the low carbon growth, the resource efficiency, and the social inclusivity are very important. And again, some opportunity in Indonesia using the fertilized eco-friendly, the composting, the carry out of the fertilizer to soils, distribution and transportation with the environmentally friendly system, and the traditional market and farmers in the agriculture are very full. And we can look at the situation so that, for example, how to develop the spatial or linked to the what the price of the commodity in that area are very good. Some information regarding to the what we have been achieved and done, and of course it need to be extend more, is about the research and innovation in chili pepper, for example, so that we can get more and more the superior variety in the chili. We can see this is Lingga and Kencana, then expected to increase more in production from 10 to twice, yeah, with the technology of Proliga Cabe or chili peppers. And also there is some activities are doing together in research and innovation action plan to increase the cattle population, since you know that the cattle integration with the palm oil system are very well known as SISCA, and it is potential to increase the Indonesian cattle population significantly. So if we can do comparison in Indonesia and Australia, we can see that very different in the system, since in Indonesia, smallholder farmers and side business or saving a small scale, as compared with the cow population of millions had in Australia. And sometimes it's not so economical, and intensively breeding culture system, it's not so extensively. So there is many challenges in this research and innovation regarding to the cattle population itself. So how to make it get together in integration with the palm oils. And the other thing is regarding to the setting of in the future regarding the agriculture of the cattle oil palm integration. I think it is very neat to be done. And the other thing is about the traditional canned food technology. So we can see that the benefit of the canned package as the food package are very simple, so that we can also get some protection food from the microbial, physically and chemical, from the photochemical reaction, and also from the gas permeability spoils, so that we can get more and more long-term or that package with the tin, aluminum, and so on. I think one more thing that regarding to the food preservation using the cold plasma or the irradiation, is ongoing research for the processing food, especially potential from the fresh food. You look at the fruit and agriculture product and so on. So I think that is all, and we are in BRIN will deliver more and more in the science and technology and innovation, establish the sustainable agriculture in Indonesia, and we are also ready to have collaboration with all of stakeholders. Thank you very much for the attention, and Assalamualaikum warahmatullahi wabarakatuh. Thank you. Give the time back to the Ibu Risma.
Thank you very much, Bapak Mego Pinandito, PhD, the Deputy Chairman of Policy Development, for representing the Chairman of National Research and Innovation Agency with very inspiring and informative speech for all of us. And big applause. We would like to give the certificate of appreciation to the Chairman of National Research and Innovation Agency, Bapak Laksana Trihandoko, PhD, and Bapak Mego Pinandito, PhD, the Deputy Chairman of Policy Development for the National Research and Innovation Agency, which will be given by the Chairman of Research Organization for Agriculture and Food, Ibu Puji Lestari, PhD.
Yep. Thank you, Risma. So, Pak Handoko. Yeah, thank you, Pak Mego. Just really, I highly appreciate and thank for your time today to be with us and deliver a fruitful presentation and to support ICFAS today.
Thank you. Terima kasih, Ibu.
Sama-sama, Pak. Kami yang terima kasih.
Okay, thank you very much to Ibu Puji Lestari, PhD. Ladies and gentlemen, before we start the conference, to commemorate today's session, we would like to invite you for a photo session. So please switch on your camera for taking photos. And to the host, please to take picture on the screen. We start from slide 1. Next. Okay. Okay, thank you very much for your kind attention and cooperation. Excellencies, distinguished guests, ladies and gentlemen. On behalf of our organizing committee, we would like to extend our deepest appreciation to all distinguished guest speakers, partners, sponsors, and participants for attending the opening ceremony. We will now proceed our program to the plenary session. In the first plenary session, we would like to invite Bapak Yusuf Andriana, PhD, from Research Center for Food Technology and Processing, BRIN, to facilitate this session. But before we start, I will inform to the participants that in this conference, the committee will select the best participant during the plenary session. So please follow the conference until we finish. Okay, and then now before we start, I will read the curriculum vitae of our moderator in this first session. Yusuf Andriana, PhD, is a senior researcher at Research Center for Food Technology and Processing, National Research and Innovation Agency, and also as focal point COSTI ASEAN. Yusuf Andriana graduated from ITB University for undergraduate and master program, and he continued his PhD at Hiroshima University. His research focuses on functional food, food biochemistry, nutraceutical, and others, as you can see on the screen. And he has a lot of publications related to his research. To Bapak Yusuf Andriana, PhD, please, time is yours.
Okay, thank you very much, Ibu Risma. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. His Excellency, the Chairman of National Research and Innovation Agency, Republic of Indonesia, Dr. Laksana Trihandoko, and now his representative, and then the respectable chair of research organization for agriculture and food of BRIN Indonesia, Dr. Puji Lestari, the honorable chairman of ICFAS 2022, Dr. Tri Puji Priyatno, and then the honorable keynote speaker, Professor Hiroshi Ehara from Nagoya University, and also Professor Yandra Ackerman from IPB University, and all of participants of this virtual conference. Good morning. I hope all of you are doing well. So good morning, ladies and gentlemen. So welcome to the plenary session of the first International Conference on Food and Agricultural Sciences 2022. My name is Yusuf Andriana. I'm going to be moderator in this plenary session. So in this session, we have two invited speakers. The first one is Professor Dr. Hiroshi Ehara, and then the second is Professor Dr. Yandra Arkman. So Professor Ehara will talk about recent advanced sagu palm technology to respond to global climate change. And then Professor Yandra Arkman will talk about application of advanced digital technology for green and circular agro-industrial supply chain management. So I will greet Professor Ehara first. Hello, good morning, Professor Ehara. Are you with us? Professor Ehara? Or maybe he will join later. And then we move to the second speakers, Professor Yandra Arkerman. Are you with us? Hello?
Yes, I am here.
Okay. So for your information now, Professor Yandra is on travel duty in Kuala Lumpur. So he has recorded a presentation and still join us with using a mobile phone. So Professor Ehara and Professor Yandra, we will start the presentation until the next 1 hour and 10 minutes. We will start from Professor Ehara and then continued by Professor Yandra. So each speaker will talk around 20 minutes. So 20 minutes for Professor Ehara and then 20 minutes for Professor Yandra. And then after two speakers have present their topic, we will have a discussion session. Is around 30 minutes. So for Professor Ehara and Professor Yandra information, for your information, our audience are researcher and then faculties and student also. So very quite background. And for all audience, you can ask a question. If you have any question, you can ask your question during the session by using raise your hand feature, or you can type your question in discussion box feature in Zoom application, and I will read them for you. Okay, is Professor Ehara is already with us? Hello, good morning, Professor Ehara.
Hello.
Okay. Your voice is sounds good.
Good morning. So I'm very sorry that.
Okay. So before we start our plenary session, I will read the profile of Professor Ehara and Professor Yandra first. So Professor Hiroshi Ehara is director in International Center for Research and Education in Agriculture in Nagoya University. He earned a Bachelor of Agriculture and Master of Agriculture in from Bachelor Agriculture from Nihon University, and then Master of Agriculture and PhD degree from Okayama University. His research area is both environmental science and then agriculture science, crop production science, and tropical agriculture. So his current interests are both ecological and physiological characteristics of sagu palm, metroxylon sagu, and related species. So and then he also interested about plant stress, abiotic or biotic stress on rice, also in Vigna plant species. So next we move to Professor Yandra Arkman profile. So Professor Yandra Arkman is a lecturer of Department of Agro-Industrial Technology, IPB University. Also, he is a head of master program in agro-maritime logistics IPB University. He earned a bachelor degree in agro-industrial technology, and then continue his master and PhD in University of South Australia, and then also conducted a postdoctoral in Kansai University and George Mason University. His expertise is in computational intelligence and advanced computing technology. Okay, no need to wait more longer. We invite Professor Ehara to present the topic or your work. Professor Ehara, you have 20 minutes to present your topic. So please, time is yours.
Thank you very much, Mr. Chairman, to introduce me. So, very good morning, ladies and gentlemen. First, we'd like to send our sympathy to people in West Java. As the former resident in West Java. So, I really appreciate your kind consideration to invite me for giving today's talk. So, can you look at my slide? PowerPoint slide? Is it okay?
Yes, Sensei, it's okay.
Oh, okay, thank you. So we really appreciate to give this title to me, the recent advances in the Sego palm technology to respond to the global climate change. So today I'd like to talk about the background of the Sego studies and why not now interest in Sego, and so the resilience to the environmental change, flooding, high soil humidity, something, and the abiotic stresses. So probably this kind of the basic information we can skip, but so the higher starch the productivity of the Sego palm is the most unique advantage. And so when we talk about the Sego palm, so if we back to the 5,000 years ago, Sego palm, Sego type, the starch, so the most important food prior to the rice cultivation was expanding. So even in South subtropical China as well. So this is the achievement is from the China and the UK. However, of course, the current the Sego palm growing area is so limited if compared with the 5,000 years ago. And then, so at the current the situation, only 10% of the Sego resource can be utilized in this area. However, if we can utilize the half of the Sego resource, we can produce the large amount of the starch, 16.5 million tons that we estimate together with the Mitsubishi company. And so this amount will correspond to the almost 2 times of the national Japanese rice consumption. And if we can convert this starch into the ethanol or ethylene, so the 4.2 million ton ethylene can be produced. It will correspond to the almost same amount of the domestic demand of the petrochemicals in Japan. So from such a situation, we can say the very high potentiality you will have. Of course, based on the land area base, the ethanol production, if we utilize our tropical starch crop, the Sego will be the most preferable one. But of course, we will have some difficulties. So how to find the better solution, we should talk together. So the reason why the Japanese scientists will have the interest in the Sego, or Japan is the biggest Sego importing country, And formerly, we just utilized the sago starch as a dusting flour for making the Japanese noodle or Japanese sweet. However, recently, some cosmetic company in Japan started to utilize the sago powder for the cosmetic use, and the other company is producing the sago starch as the food flour for preventing the allergy. Then, so Ajinomoto company is producing the sajiku, a material for the fried chicken for preparing the gluten-free chicken with the very high crispy. So considering such the movement, the Japan Airlines started to utilize the sago starch as the material for preparing the food for the person who would have the allergy. And not only Japan Airlines, recently the ANA or Nippon Airways, also the started to employ the sago starch for their meal in the airplane. So our society, the Society of the Sago Palm Studies, is making further efforts to prepare the the Japanese food utilizing the sago starch. Of course, back of such the movement, so the importance of the cell characteristics to prevent the allergy exists. So about the climate change. So if we talk about the climate change, of course, the natural disaster should be thought about. So this slide shows the record from this summer season this year. Summer mean the July, August, September in the our temperate zone. We call it the summer. And so the 16 records are distributed from the media, but I'd like to add one more in Japan, so that we have the very serious typhoon influence in Shizuoka Prefecture beside of the Nagoya in September. So if we look at these records, mostly from the heavy rain or flooding, and so the case of the states, so the big flooding was occurred, but this area is the originally dry area. Such the dry area, if they have the heavy rain, so they will have the very serious difficulty. So when we talk about the sago, of course, the audience will expect the sago will stand against the flooding or the water logging. But formally, there was no exact data. That's why recently we published this kind of the data, sago performance under the water logging. Black circle indicated the plot of the flooding, and white circle is the control. First one showed the net photosynthetic rate along the days from the beginning of the water logging. So within about the 2 months, so flooding plot show us the better performance. However, if the flooding period is prolonged, so of course the performance will be depressed. From this result, we can say for 2 months logging will be no problem for sago palm. But if the water logging condition is prolonged, so we should think about the land improvement something. However, sago palm will have the very well developed parenchyma in the roots under the submerged condition. That's why we don't have to prepare so much the drainage. So from the former studies, we know nearly the half of the sago roots will distribute close to the soil surface, within the 30 centimeter from soil surface. That's why there's not so much drainage. We will be able to prepare for attaining the sustainable sago growth. So in case of the submerged, the waterlogging condition, so we should think about the influence of the peat soil profile. Under the peat soil condition, there are many reports, but so we should be in the confusion. Sometimes the researcher will report the sago will grow well in peatland, but the other scientists will talk the negative influence with the peat soil. Here, we just listed the many results. If we have the interest, please visit our former publication, Sago Palm or the Tropical Peatland Eco Management from Springer, or the other Ecophysiology SAG from IPB University. And the other one is the Sago or the Sago Palm from the Kyoto University Press. So Springer, from the Springer, you can download some of the articles without any charge, especially this one. Please try to visit the Springer website with the title of the Sago Palm. You will be able to find this kind of information. So next, we know the sago can grow in the brackish water area, but the reason why the sago can stand, so this is one of the most important of our research theme. For making clear the reason why, we set the different level of the NaCl treatment from 0 or 0.5, NaCl 1.0 and 2.0. If we measure the NaCl concentration in each plant body, leaf, petiole, root, in case of the leaf, even under the 2.0 NaCl treatment, sago can maintain the low level of the sodium. Then, under such the higher NaCl treatment, so sago palm can maintain the potassium concentration in leaf, petiole, root as well. I skip this. The reason why we try to find such the cause in the roots. We divided the root part into the cortex, outer layer, and central cylinder, two parts, and we compare the NaCl concentration in each organ. In case of the cortex, outer layer, of course, in the treated plot, sodium chloride will be sodium ion will be very high. However, in case of the central cylinder, less than half. So from this result, we conclude sago can deposit the sodium in the outer layer of the root much. And this result indicates the sodium distribution in the root along the distillate line from the outer layer to the inner layer. So a high deposit was recorded here, so around this area. This area will be the endodermal cells. Hypothetically, we know in the endodermal cell, Casparian stripe will exist. From our microscopic analysis, we could detect the Casparian stripe, well-developed Casparian stripe. Sago can deposit the spharin or lignin along the endodermal cells. This will be the one of the reasons why sago can stand. Oh, this is more beautiful one. These the blue dots are the Casparian stripe. and so the under the low pH condition also the sago will show the preferable growth. This also will be from this kind of the very nice root structure. Let me skip some. So anyway, a Casparian stripe will be will take the very important role for giving the toughness for the sago. But so the case of the under the low pH, of course, the sago can stand against aluminum, but so the sago is the not accumulator. They will have the avoidance mechanism. So, probably we should talk about some technology or new findings, and that's why I put some different kind of the research result. Our research team is making the new effort to prepare the gluten-free pasta utilizing the sago as well, sago starch as well. This is also the one of the new effort. So, but for making the pasta, we need the protein. We need protein, but so the sago will include the very small amount of the protein, and that's why the sago will be recognized as the gluten-free or the allergen-free food flour. Then, so for making the gluten-free pasta utilizing the sago, or we employed the corn flour. When we mix the corn flour together with the sago, we will be able to prepare actually the nice gluten-free pasta. So if we compare the usual pasta, sago pasta, potato pasta, corn pasta, or tropical starch pasta. Of course, depend on the method of the evaluation, the tendency will be different. But in case of the 5% repute strength, so the corn will be the very nice. But so the final repute point, the sago and potato will show us the better result. We'd like to utilize this kind of the information for making the new product together with the Indonesian partners. So let me back to the other the environmental the topics. So this is our estimation in the future. So the area for sago cultivation, suitable sago cultivation, will be increased or decreased or no change. So this was the result. So depend on the topographic wetness index and so geographical information, we try to estimate the preferable land for sago or growth in the 70 years after this. From this, actually, so this was my result in the 1984, when I was the undergraduate student. Then we put our recent analysis into the our former the findings, considering the all the analysis, so that we can say the land for the sago or cultivation, preferable sago cultivation will be increased because of the climate change after this. So considering such a situation, since August this year, we have been contributing for the FAO Technical Cooperation Program of the Sago palm in Papua New Guinea. So Papua New Guinea also has the big potentiality of the sago resource, but they would like to expand their sago cultivation area. For such the passion, we respond to utilize the new method of the planting. Sago is propagated utilizing the sector, vegetable organ. However, now we are promoting utilizing the seed germination, seed propagation. Sago palm will grow around 3,000 fruits in one palm canopy. If we can utilize such the fruit seed, so we will be able to produce the very uniform seedlings at once. So now we are doing this kind of efforts your neighbor countries. So then, not only from our efforts, from Indonesia also we hear many interesting newborn sago cup noodle, pancake, protein pancake. Of course, they should add the other protein source for the sago starch, but this kind of pancake mix also is prepared, and so the sago instant noodle and sago pasta. So these results, the information from my daughter, who is the business consultant in Jakarta. So she is sent
excuse me.
Yeah.
You still have 1 minute more.
Okay. This is final slide.
Okay.
So after we received this kind of the project from Indonesia, we started to do the sensory test with the scientists from the food science, and so with some other private company to analyze the contents. For example, the allergen something. We didn't find any allergen from the sago product. That's why we can say sago product will be very safe. And so the taste is improving rapidly according to our soil science, food scientists. So we'd like to combine our result and so the new movement from Indonesia for providing the new sago food to the world. Okay, this thank you very much indeed for your kind attention. We'd like to so make the further collaboration together with our partners in Indonesia. Thank you very much indeed.
Okay, thank you very much, Professor Ehara. Very interesting presentation. So for audience, if you have any question, please hold first, and you can you can ask question after Professor Yandra deliver his presentation. So thank you for Professor Ehara, and then we will move to the second speaker. Professor Yandra Arkemang. Good morning, Professor Yandra.
Good morning. Good morning. Yeah, I'm here.
Okay. So yeah, you are in airport now, right?
Yes, I'm in airport. I'm going to Hanoi, on the way to Hanoi.
Okay, so Professor Yandra is already prepared a recorded video. So later, okay.
I will say hello first for the audience. Hello.
Okay.
Assalamualaikum warahmatullahi wabarakatuh. I will be presenting about the application of advanced digital technology for green and circular agro-industrial supply chain. I have prepared for recorded, but before that, I want to say hello to you all. Hopefully, you can understand, you can share the base of my knowledge to you all. Why I prepared the pre-recorded, because I'm now in the public area, so maybe some noise, and also maybe the internet connection is not stable. So committee, yeah, you can start my pre-recorded video now.
Good morning, ladies and gentlemen. I would like to give a presentation about the application of advanced digital technology for green and circular agro-industrial supply chain management. This talk is presented in the first International Conference on Food and Agricultural Science. My background, I got a PhD in Intelligent Manufacturing System from Australia, and then postdoctoral in Artificial Intelligence, Japan and USA. And I'm a professor in Agro-Industrial Technology, IPB University. I also the head of Master Program in Agro-Maritime Logistic, IPB University. So this is the presentation agenda for today's presentation. The first is Agro-Industry 4.0 or 5.0. The second one is Intelligent Supply Chain Management. The third topic will be Artificial Intelligence and Blockchains in Agriculture. Then we move to Circular Economy and Green Supply Chain, and then the closing. Okay, so we start with the first presentation about Agro-Industry 4.0 or 5.0. The concept of the Industrial Revolution 4.0 or 5.0 bridges physical industrial resource with advanced digital technology and the role of humans in their utilization. The Industrial Revolution is an automation technology with cyber technology with the term of cyber physical system and various innovation such as connected to the internet, IoT, artificial intelligence, cloud computing, microchips, machine learning, deep learning, cloud analytics, blockchains, nanotechnology, quantum computers, biotechnology, 3D printing, and autonomous vehicles. Data from the Central Statistic Agency in 2020, the GDP of the agricultural sector grew positively 1.75% when the national economy contracted by -2% due to the COVID-19 pandemic. So the agricultural sector, supported by advanced digital technology such as AI and blockchains, grew more optimally by using the development of Agro-Industry 4.0. So there are three strategic areas in the future. The first one, development of industries that use agricultural raw materials or agri-industry to have added value revolution, environmental friendly and sustainable. The second one, the food security, availability of clean water, bioenergy, and natural medicines for people's survival. And the third one, the strategic area is massive use of advanced digital technology such as artificial intelligence, IoT, and blockchains in all areas of life. This will spur the development of agro-industry 4.0 and 5.0. There are challenges for upstream and downstream technology of agro-industry. So as we know that agriculture is not only increasing agricultural production that will be sent to the market, both domestic and export, regardless of whether the market requires the commodity or not, but must be developed with a pull strategy. Many agro-industry must be established to stimulate the agricultural sector. With this approach, the agricultural products will be accommodated by the industry to be used as materials with higher added value required by the market. So the pull strategy is that the problem over production of agricultural commodities and price fall will never occur because regardless the amount, because the agricultural commodities will be absorbed by the industry at a reasonable price, and farmers will be more prosperous. In pull strategy, we build agri-industry to maximally increase added value of agricultural products. Numerous agri-industries will increase the demand of raw materials, leading to fair selling price for farmers. Farmers become motivated to improve their products both in the volume and in the quality, thus meeting the demand and standards of the industry. Now we will talk about intelligent supply chain management. This is the conventional supply chain business model. So the weaknesses are: the first, the length of the value chains in marketing, either in wholesale, distributor, or retail. And then value chains information from the procurement to consumers is not well documented because the system is still centralized. And centralized system in this way will be vulnerable to falsification or information on every activity in the value chains. So the mixing between halal and non-halal materials, equipment is very large and cannot difficult to trace. Then halal traceability will be difficult because of the falsification, which results in delay in the halal audit process. In recent years, global food logistics has greatly improved due to the arising opportunities such as the increased food and demand, improved post-harvest handling technology, and accelerated intelligent transportation technology, and also information and communication technology growth. So agro-industry supply chain management is important to ensure that the products can reach consumers with the desired quantity, quality, and certainty. The supply chain scope sometimes called from the land to consumers, from farm to fork, and so on, but all face some problems in the management, such as lack of information, lack of transparency, lack of traceability for products, the quality, and also document. These problems reduce by to the certainty to reach consumers. Now, the integrated and intelligent supply chain management, meaning that to monitoring product flow from upstream to downstream, which will intelligently generate product condition information for each process in the supply chains. So the integrated supply chains management means from land to consumers. Products include production systems of farming, fisheries, logistic include collection, transportation, and distribution, marketing and e-commerce, and also demand production. While the intelligent aspect of the supply chains management is developed by using artificial intelligence, smart sensors, Internet of Things, smart blockchains, big data analytics, BRIN computer interface, and quantum computer. Now we move to the artificial intelligence and blockchains in agriculture. The benefits of artificial intelligence when we compare traditional tools and modern tools are as follows. The first one, that the traditional tools involve intuitions, judgment, and rules of thumbs, while the modern tools are developed by quantitative, scientific, knowledge-based, and intelligent. So for the traditional tools, it is manual and inconsistent, while for the modern tools, it's a computer-based and consistent. Traditional tools, as we know, there is no explanation and imprecise, while the modern tools, it has explanation capability and it is precise. And for traditional tools, the small scales and simple problem only can be utilized, as well as limited learning capability. But for the modern tools, as we know, it can handle large scale and complex problem, and it can use unlimited learning capability. These are challenges in achieving food security. Supply is not adequate because of pandemic, war, worker strike, restriction, and also demand is always increasing because of the population growth and increasing of number of consumer stock, and as well as that the supply not up to the demand, both quantity and the quality, because of the management error, of lack of knowledge, also because of crime, falsification, and hoarding by the speculators. So this is an example about loss of harvest due to natural factors. So the inadequate supply may be caused by loss of harvest due to pests, disease, weeds, and bad weather, which was reported up to 41%. The loss of supply chains may also caused by poor management, where production is so much higher than demand, leading to extreme price fall, and loss of harvest due to the lack of agricultural workers or a limited human resource. And also, these are another issue in food supply chains. Halal issue is not only Muslim countries concerned anymore, because falsification and contamination is a serious problem for the supply chain. These are some example of the global halal issue that has been reported. So the problem of supply chains, that supply not reaching consumers adequately, can be addressed using the combination of blockchains and artificial intelligence. So blockchain can be used as a backbone, and the artificial intelligence as intelligent front or back end. We have heard in the last decade about precision agriculture. It involves digital transformation and necessary in overcoming agricultural upstream and downstream problems. So digital transformation is a necessity in overcoming upstream and downstream challenge, where precision agriculture is nowadays become a very interesting research topic and development. For example, these are how we use AI and blockchains for the on-farm and off-farm problem mentioned earlier. For natural challenge, we have weather prediction system, intelligent planting calendar, intelligent system for pest and disease detection. For the farm management, we develop intelligent agribusiness management information system, agricultural extension system platform, supply chain system, and e-commerce for agricultural products. For the human resource, we develop smart robots and drones for harvesting, fertilizing, and watering, as well as cultivating land and also pesticides application. And many more studies had been conducted to solve all the problem in the challenge. These are some of the examples of the research we have conducted at IBB University. This is the clustering types of rice disease based on leaf image. Results of the clustering types of rice disease was optimized using fuzzy means of FCM and genetic algorithm. This is a random forest prediction for sugarcane drought using satellite imagery data. So mapping of crop drought with hyperspectral index through machine learning classification method for persistent cloud area with high temporal dynamics of land cover type. This is another example of multi-drone for precision farming using K-mean clustering algorithm and colony optimization and genetic algorithm and tree-opt. This one is the identification of health condition distribution of salads in Malang Regency, Indonesia using template machine algorithm, random forest classification method, and NDVI based on drone image. This is a smart supply chain system of oil palm fresh fruit bunch from independent smallholder farmers. And this one is the fresh milk smart grading system based on Internet of Things. This is the real-time quality prediction system of fresh mango for long-distance transportation that has been also developed at IBB University. And this one is the Preciflock Precision Food Logistics. It is an application of high precision food logistics system. This was developed as the response to COVID-19 pandemic. This one is the designing a transparent distributed system for halal supply chains using blockchain technology. So after those examples, now we talk about to give an illustration about the supply chains using AI, blockchains, and IoT. So this is the general illustration on implementing IE, blockchain, and IoT in a supply chain. So from the supply chains data, production data, and customer data, it is managed through the blockchain system. So why blockchain is 3T? The first one is transparent, the second one trusted, and the third one is traceable. Because all transactions are recorded, and then the current record is linked to the previous record and subsequent record as a chain, and it is locked with a highly secure cryptographic system. And because it is well structured, block and chain, so transaction records are easy to be traced. So integrating blockchain with AI, that the ability of blockchain can be synergized with AI to present more reliable system called smart blockchain. So for example, in halal supply chains, AI is used to help blockchains detect the substance content of food and medicinal product without damaging them. So consumers can track the product transaction history in just a few seconds. So we talk now about circular economy and green supply chain. So the concept of circular economy is to reduce the extraction of raw material and enables the circulation of resource by implementing these 9 dimensions. So circular economy keeps material availability to decrease waste and energy use, and therefore creates better environments for everyone. So challenge to implement circular economy, there are some barriers like cultural, business and finance, regulatory and governmental, technological, managerial, supply chains management, as well as knowledge and skills. So the solution is using the Industry 4.0 technologies such as Internet of Things, cloud technologies, machine learning, and blockchains. So circular economy must be promoted via adequate laws, policies, and innovative technologies. Digital technologies to deal with barriers related to the circular economy dimension. So this is the example how circular economy dimension can be managed by digital technologies. So green supply chains management in circular economy concept that the GSGM can be regarded as an organizational element to support circular economy practices, include some performance of assessment frameworks such as environmental performance, economic, financial performance, operational performance, logistic performance, organizational performance, and marketing performance. So the GSGM provides the resource to optimization in circular economy. So this is a framework of material flows in a GSGM that utilize circular economy concept. So it can be divided into the closed loop flows within the supply chains and open loop flows across the supply chain. So ideally, a supply chain should be like this, where circular flow is applied, minimizing any waste and leakage of material and resource. So for the closing, the development of agro-industry 4.0 or 5.0 and improving the performance of supply chain system requires an improved mindset and knowledge of all stakeholders, improved infrastructures, as well as encouragement of government policies. The agro-industry 4.0 or 5.0 by using artificial intelligence and blockchains with pool strategy is the best strategy to achieve food security. And the advanced digital technology solves agricultural supply chains problem from on-farm to off-farm, from farm to table. So finally, the strategy to sustainability is implementation of circular economy concept in green supply chain management. That is all my presentation today. Thank you for your attention.
Okay, thank you, Pak Moderator. I just want to let you know that I will be moving for 10 minutes to the other stage, the immigration process, but I will keep, monitoring using my earphone. So I will go back to you maybe later after immigration process. Thank you, Pak.
Okay, thank you very much, Professor Yandra. Very nice presentation. So, ladies and gentlemen, we will move to the discussion session. If you have any question, you can ask by using the raise hand feature or type your question on the chat box feature, and I will read them for you. Okay. Okay, we have a question from Ibu Wiwi. So please, you can ask a question to Professor Ehara or Professor Yandra.
Thank you, Moderator Bapak Yusuf. I would like to give my greeting to Ehara Sensei. Konnichiwa, Sensei. Hajimemashite, watashi wa Wiwi desu. Yoroshiku onegaishimasu. So, I'm doing a postdoctoral researcher in Utsunomiya Daigaku, Sensei. So, I'm really interested with your presentation. Thank you for sharing the information. I have two questions, if it's okay. So based on your presentation, the sago palm have high adaptability for the challenging environment conditions, such as the waterlogged and then a low soil pH and aluminum toxicity. So I would like to know, is there any research in your laboratory or in your research team regarding the sago plant in interaction with the microbes, for example, the endophyte or the microbial community, which enhancing or increasing this plant adaptability? And then my second question is about the seed coating to improve the seed germination. Would you like to give more information what type of the coating materials you use? Thank you, Sensei.
The first question, microbes. Yes, our PhD students is doing the research about the nitrogen fixation bacteria. So about nitrogen fixation bacteria, already Professor Koki Toyota from the Tokyo University of Agriculture and Technology, TU80, together with Utsunomiya. So he published many publications about the nitrogen fixation bacteria of sago. We also follow his researches. And so another one is the AMF. So for collecting the phosphorus. So we are doing such research in Malaysia, Thailand, and partly in Indonesia as well. So the participant Aidil Azhar, I got his greetings through the SNS at this moment. So he's also doing the microbes, the experiment, so employing the AMF. So in this laboratory also, in our laboratory also, so applying the AMF for the sago seedling. Now we are detecting the photosynthetic rate and some other the parameters. Yes, we expect the role of the microbes under the poor soil environment. Yes. And the next one is about coating, seed coating.
For second, okay.
Seed coating. We never tried the seed coating for sago yet. For this other crops, I'm doing the works for the direct seeding rice, some others, but for the sago, we never tried the seed coating yet. We are trying to remove the germination inhibitors from the seed coat tissue. We achieve it, but so for improving the other efforts, for example, employing the phytohormone. So phytohormone will be some kind of the phytohormone will be available for increasing the sago germination. But so the negative influence also will happen. That's why we should select the kind of the phytohormone and concentration of the application more in detail. So that we should accumulate more the results.
Okay.
Thank you.
Okay, thank you so much, Professor Ehara. So anyone have a question more or not? You can raise your hand or type your question in the chat box feature. We have one question in the chat box for the question is just wait a minute. Okay. The question is from Vina Eka Aristia. dear Professor Ehara, how to answer the problem of sago which is still partially managed. Even though the potential for sago is quite high for the industry, how to make sago in culture in the daily food, how to make sago culture in the daily food menu. It's mean about the feedstock availability, Sensei. So how we know that maybe we still rare or barely the sago farm with the intensively cultivation.
Yeah, intensive cultivation, and so the for example, for the private sector, who will have the processing or the post processing. So one of the most important thing is the stable providing of the material from the farm, from the processing factory to the industrial. So actually, we will have the unstable the production amount depend on the month, the season, but for the more higher utilization in private sector or industries, so the very stable providing of the material will be very important. For such the efforts, we should improve the of course cultivation method, and so the how can I say marketing process as well, together with not only the technical.
Okay, thank you so much for your answer. We have one more question. So from the chat box, the question is from Mr. Sembiring. What is the proper handling and processing of inorganic waste of sago palm? So he asked about the handling inorganic waste in sago palm industry.
Yes, if we follow the conventional starch extraction method, farmer level, nearly 50% of the starch will be remained in the residue. It means the sago residue will have the fiber together with carbohydrate. So of course, from such the residue, we can recover remained starch. But if we utilize the total utilization of the residue, we can convert such the residue to the other the way. Probably someone will expect to utilize for the feeding material as well. But before feeding material, so that we can utilize such the residue as the growing media for some plants or the how can I say mushroom something. So such the utilization way we know from the other food residue. Probably sago also will be utilized for the various the utilization. So to be the resource from residue to be the resource.
Okay, so we have one more question. Is to Professor Ehara. Is from Ismet Inuito. The question is why there is no sago plantation in commercial. There is only in the jungle. So this is about intensive cultivation. Is there any problem for how to grow the sago in in modern or in intensively cultivation?
So in our understanding, the first large-scale plantation owned by the private sector was established in Indonesia, in Riau, Pulau Riau, by the Sampurna Agro, I know. So sometimes, so the their plantation kindly accept our graduate students to conduct the survey there. And but so I heard from them they will have some difficulties. Now we are talking about how we can find the better collaboration with the private sector from their business, the interest from our academic interest. So that now the time to make such the collaboration. Probably we will be able to expand their effort. Then if you visit the East Malaysia, not the large size companies, but so the small or mid-sized individual farmers or the farmer kind of the cooperative something. So they are managing their Sego forest with very clean management. That's why if so that we can make further efforts, of course we will be able to set the more large scale, the business scale, the cultivation. I had such the new motivation. It happened from the Bangka Island, but they are focusing on the processing. So they will transfer their material from the other island into the Bangka. But so of course from the cultivation processing to the more so the understream, so that we can make such the network probably. And so that this is the time to do to go step forward probably, considering the current situation and the social situation in Europe, then some other.
Okay, thank you, Professor Ehara, for your question, for your answer. So now we have the last question from Mr. Astu Unadi. So please, you can ask question. And
yes.
To who? Yes.
Yeah, thank you. Thank you very much. My question is to Professor Arkeman, IPB. Your topic of research is very interesting and very promising for agriculture development in Indonesia, especially supply chain management. As we know that the data of the production demand of the agriculture product in Indonesia is fluctuating. So how to apply your research on that method so that we do not import the agriculture product, particularly for agriculture product, for example, chili and onion, white onion, and other product. Yeah, it is very interesting. Thank you.
Okay, thank you, Mr. Astu Unadi. Professor Yandra, are you still with us? Hello, hello, Professor. Maybe Professor Yandra is busy now because he's in immigration. So for question, Mr. Astu, we will send by email for Professor Yandra, and he will answer later. Okay. Okay.
Thank you.
So okay, thank you. Okay. Now this session, the time is over, so we have to finish 10:30, but now 10:32. So ladies and gentlemen, okay, we already hear all our two speakers, and we know food security is important issue, actually against the climate change affected many sectors. So by using advanced technology in agriculture, we hope we can achieve the food security. So we would like thanks to Professor Ehara and Professor Yandra Arkeman for joining this conference, and our research organization is very much appreciated it. And also for the audience, thank you to be wonderful participant during this session, and hope see you again, and from me, thank you for all. And wassalamualaikum warahmatullahi wabarakatuh. This session is finished, and I hand over to Master of Ceremony, Ibu Risma. Please, thank you. Thank you so much.
Big applause for the chairman and all the speakers. Thank you for the chairman,
so much.
Bapak Yusuf Andriana, PhD, for leading this session.
Ada suaranya?
Tidak ada suaranya. Tidak ada suara.
Thank you very much, Prof. Hiroshi Ehara, for sharing knowledge with us. We highly appreciate it for your contribution to this conference. Thank you very much.
Sekarang okay, please, Bapak Tripuji Prayitno. And then we would like to extend our appreciation for Professor Dr. Yandra Arkeman. Please, Bapak Yusuf Andriana. Oh, sorry. Please, Bapak Tri Puji Priyatno to deliver the certificate.
Okay, thank you very much, Prof. Yandra Arkeman, for your contribution to this conference. Thank you very much.
And also certificate of appreciation for the chairman, Bapak Yusuf Andriana, PhD. Please, Bapak Tri Puji Prayitno to deliver the certificate.
Okay. Also for Yusuf Andriana for moderating this session. Thank you very much.
Okay, thank you.
Okay, thank you, Bapak Tri Puji Priyatno, and big applause for all the speakers and the chairman. Ladies and gentlemen, next we will continue to the second plenary session. For that, we would like to invite Ibu Dr. Bes Tisnamurti as the chairman. But we would like to read the curriculum vitae from Ibu Dr. Bes Tisnamurti. Ibu Bes Tisnamurti graduated from Faculty of Animal Science and Fishery, Diponegoro University in 1982. She started her career as researcher at the Indonesian Research Institute for Animal Production as a sheep breeder. The degree of Master of Science was pursued from the Department of Animal Science, University of California, Davis in 1988, and her doctorate degree was completed at the Graduate School of ITB University in 2001. Her main interest is exploring characteristics of local animal genetic resources, and also she already published 112 scientific papers and contributing author in several books. Ibu Dr. Bes Tisnamurti, a warm welcome.
Thank you so much for this. Thank you so much for the valuable time. So this is now we are moving to the next plenary session, and I would like to introduce three distinguished speakers from around the world. We really appreciate your time to share your valuable opinion or experience to this conference. Mana presentasinya? Okay, the first speaker will be Professor Dr. Roger Hegarty, and he will present his presentation on technologies in reducing greenhouse gases emission from livestock, current and future research. He's interested in ruminant nutrition, and he graduated from the agriculture science with bachelor and master degree in 1984. And then he received his degree also from University of New England in 1990. He has approximately 140 reference publications and led a strong postgraduate school at UNE, and now looks forward to working with colleagues in BRIN. Our next speaker, the next one, will be Professor Dr. Cepi Sujana with his topic on cattle oil palm integration system as a viable strategy for Indonesian sustainable food, feed, and energy production. He's a resource economics optimizing models in system modeling and livestock policy. He received the first degree from the Pajajaran University, and then later on to the economics and studies from the University of Colorado, and then applied economics from the University of Minnesota. And then in 1987, he received a PhD in agricultural economics from the Oklahoma State University. And now let's move to the third speaker, which is Dr. Charles Masambe from the Makerere University College of Natural Sciences, Department of Zoology, Entomology, and Fisheries Sciences. He's going to present the topic on the opportunities and challenges in improving resilience and production of cattle in a changing climate in Uganda. He received his veterinary medicine degree from the Makerere University, and then pursue his master in environment and natural resources from the same university, and then his PhD about molecular population genetics. And he published many high-index scientific papers and contributing authors in several books. Now let me allow Professor Roger Hegarty from Ag Research, New Zealand, for his presentation. Roger, you have around 20 minutes presentation. Hi, how are you? New Zealand is about 6 hours ahead of us, you know, so it's about 4 o'clock in the afternoon by now. Okay.
We'll just see if that sharing is going to work properly.
Yeah, seems to be.
Huh?
Yeah, it's okay right now.
Okay.
Bisa dikedein nggak? Dari siapa? Dari Dian. Okay.
Well, let's see what happens when we go.
Can you have like the slideshow, Roger?
Is that looking okay for you?
Yeah, okay.
Yeah, clear.
Happy? Okay. If there is a problem, call out and we will work it out.
All right.
So, thank you, Bess. Thank you, conference organisers and participants. Today, I want to spend a little time sharing with you about research in mitigation for ruminant emissions, particularly enteric emissions. And rather than just give you a list of technologies for reducing emissions, I wanted to spend a little time looking at the context for research in livestock emissions, the idea that greenhouse gases are just one of many topics, the picture of our research environment in the Asia-Pacific region, and then explore together how we can marry up productivity and food security with mitigation and emissions outcomes. And then eventually I will get to talk about what I was meant to speak about, which was how do we mitigate emissions with things that we can do today, as well as things that we can do in the future. So that will be our strategy. The picture on the right there is just our sheep respiration chambers in Armidale in Australia. Okay. Well, if I was a hungry person, I think I would be much more interested in another mouthful of food than I would have been interested in whether my livestock produced less emissions. And I think that that conflict or challenge between food and emissions is an important one. I like the saying that Kofi Annan, when he was running the UN, had for when he was speaking of irrigation and water use in Africa. He said our target is more crop per drop. That is, we want more animal product for every unit of input that we have. And I think we can see the same sort of thing, the marriage between how much food we can get out per unit of greenhouse gas produced. And when we look at it that way, what we would call emissions intensity, we managed to link the animal or the greenhouse gas targets, such as the climate action, sustainable development goal. It marries up with the top line, the poverty, the well-being and the hunger targets amongst those sustainable development goals. So I think as scientists in the region, our real push is to improve production efficiency of animals, whether you view that as animal product out per unit of feed consumed, or whether you look at that as animal product out per unit of greenhouse gas produced, doesn't really matter. But it's a metric, an expression, this methane emission intensity that is that really does well marrying food security and environmental management together in the one enterprise. And why it's important for us today is if we look at this map, this chart, which shows the greenhouse gas cost of producing beef in different economies. So the CO2 production cost or greenhouse gas cost of producing beef, we go over to the right-hand side, we follow the blue line. We find that in a low-income country, the greenhouse gas cost of producing beef is somewhere between 5 and 10 times higher than in the high-income country. So in our region or in the low-income countries, we're really not efficient at producing ruminant products at the moment. And so that becomes a target for us. It is great to have ambitions and targets for mitigation, but let's just have a little look at our research context. The FAO would tell us that there's some hundreds of millions of people who are hungry in the Asian region. And we realise that if we look at the emission sources, that the low and medium income countries are very much the major sources of livestock greenhouse gas, particularly if we include China in that Asia bracket. So we've got a hungry people or a people needing more food at least. We've got ourselves being significant sources of livestock emissions, but our research budget is very constrained. So in Southeast Asia, we know that the proportion of the GDP going on research in agriculture is almost a tenth of what it is in the high income countries. So we are behind best practice there. But I shall say that the rest of the world is not great when it comes to emissions research from livestock. So down the bottom there, it is saying in the world where climate finance or mitigation finance is delivered, less than 1%, something like 0.2% of all the abatement finance going out into the agriculture, forestry and land use sector, only that 0.2% is going to enteric emissions. So we've identified a big challenge with a small budget and a very unsupportive world. Now, to people like me, $1 million is a lot of money, but you and I don't want to just do research. We want to transform our region. And we know that to go from the NDC, our ambition, if you like, that our country's put in for mitigation, if we want to achieve that NDC, we're going to need a tier 2 inventory for our livestock. We're going to need some climate smart technologies that I'll talk about shortly, and we're going to need climate finance. And again, while I'm not an economist, I just want to identify for you the importance not just of the research, but of a strategy to apply that research. And the example I'd give here is Kenya. On the right-hand side, you can see a glossy brochure from ICFAS, I think, and it says that they've done a lot of work in Kenya on inventory and on dairy smallholders, and yet they're saying, look, for us to be able to change the practice of hundreds of thousands of smallholder dairies in Kenya, we will need to spend $200 million in one country for one industry. So we get excited about our research, but let's realize that the real challenge is from going from research to implementation. Okay. I think most of us are interested in what we can do rather than just our dreams. So if I look at this description here, which is again from Kenya, I admit, the people there have looked at what can we do in our country that is going to do what you say, Roger, to boost productivity, which is on the right-hand side with the black circles, and to reduce the emissions intensity, the greenhouse gas cost per litre of milk. So what technologies have we got? And we look at the list down the left-hand side, and we see that they are very simple things. They are better grasses, they are using legumes, they are providing supplements, whether that's a concentrate or something local or urea molasses block, and simple things like health management in livestock. All of these things are what I would call today's technologies, and we'll look at them a little further. But there are things out there that can reduce the emission intensity, or the negative values on the in the blue circles, and increase production relative to the baseline, or the black circles on the right-hand side. So I think we are in quite a hopeful situation looking to manage our livestock emissions and our food security. Now, I know a number of you here will work for government departments who are responsible for inventory. And my experience with inventory is all they're really interested in is lowering the absolute emissions. So less gigograms of carbon coming out of agriculture, thank you. But in practice, I think the emissions intensity metric or unit is a more useful one. I think there's 3 reasons we can look at pursuing that as our livestock industry goal in the ASEAN region. Firstly is because the Paris Agreement allows us to, as it says in that underlined section there, regarding low greenhouse gas emissions development, this should occur in a manner that does not threaten food production. So greenhouse is interesting, but food is critical. Secondly, so many countries have a forecast rise in livestock numbers. That's their business as usual situation. If we can make food production more efficient from livestock, we can reduce the emissions associated with that livestock food production or milk or fibre production. So we do actually reduce the absolute emissions from our country. And the last thing which excites me most, but I won't talk much on, is just if we have more productive animals, you and I as producers have tremendous flexibility to reduce numbers or increase numbers, to reduce emissions or increase numbers, depending on the market forces that are at play. So when we have efficient livestock production, we have flexibility about how we work in a carbon economy. If we have inefficient livestock, we have no opportunity to change the way we do things. Okay, I was meant to be talking about mitigation technologies. So let me just start with what I think are the can-do technologies, the technologies that you and I can implement in our region even now. We don't need men and women in white coats in science labs to deliver these things for us or discover these things. These are things like improving animal health and their reproductive and nutritional management, all with the intention of lowering emissions intensity. The principle of these on-farm management changes is quite simply, and I speak as a nutritionist here, quite simply that a lot of energy consumed by animals goes to just keeping their body running. So, for instance, my body weight has not changed in 30 years, but I keep eating. So I am very inefficient. There is no production from my food. But with ruminants, what we want is them always to be producing milk or live weight gain. And we want more of the energy they consume to go into productive purposes and less to go into just maintaining their body. How can we do that? Well, we can feed our animals so that the young animals grow faster and they reach slaughter weight more quickly. We can...
Roger, excuse me,
Yes.
could you have your full screen for your presentation?
I do, but what you're telling me is you are not seeing it. Is that what you are telling me? Sure. You are only seeing part screen?
Yeah.
Okay.
Yeah. Can you make like a full screen of it?
Yeah, let me just stop sharing and I will come back if that is okay.
Okay, let's do it.
I won't go away, I promise you that. Sorry, I thought you were seeing screen two. Is that looking better?
Yeah. Thank you so much.
Sorry to have tortured you with a small screen. Okay, so these are things that you and I can do today. Obviously, if we have animals that are not growing, not producing milk, not slaughter animals, we have non-productive animals that produce methane and nothing else. So if the social circumstances permit, we should be eliminating them. We should be using better nutrition to increase milk and growth of milk production and growth of all our animals. And we should be looking after their health status so that their productivity is not limited by disease. And of course, I know we have often imported high genetic merit animals to environments that cannot support them. And we've learned the lesson that we need to match the genotype to the environment. So, team, all of these are things that we can do today. And all of these things are things that are financially sensible. But I want to encourage you that many of these things are not being done. And I say that for Australia as much as for elsewhere in the ASEAN region. These things are not being done, even though they offer financial success or financial gain. So we must put some effort into working out how these profitable activities can be taken up before we make the next jump to new technologies that may not offer the level of profitability that these management techniques do. So let's not live in a fool's paradise and think that farmers will take up methane technologies when they have not taken up these money-making technologies. Okay, so I was meant to look a little futuristically. So some of you will know this cow in the picture here. There is a technology that has been developed in Europe in which the methane or the air from the cow's nose is drawn into a catalytic system and broken down to water and carbon dioxide. So there are some really novel discoveries coming into play. But I think on the right-hand side of the picture, we see really what I would call the 4 pillars of mitigation and of future mitigation: feed additives, general animal feeding, animal breeding, and vaccination. And so I want together just to step through those things now for a few more minutes. Before we do, a little advertisement here if I can. Many of us in the research world work alone and we can get discouraged and we feel we are not close to the cutting edge. There is an organisation or a partnership called the Global Research Alliance on greenhouse gases that many of you will know. It is for agricultural research, and it basically consists of 4 research groups with some hundreds of people in the team, in the email group. There's a livestock group, a paddy rice, croplands, and sort of soil carbon and modelling group. The people who are members of this group, and many of you are, I know, it creates opportunities for global projects. So you can participate in a bigger group, a European group, a Asia Pacific group. And there is also funding for training and research investment for your team or your laboratory. So I think if you have not already come across Global Research Alliance, largely funded by New Zealand, but certainly not all, please please go and look at that website and join a research group so you can be as well informed as possible. Okay, let's look at these future mitigation strategies. Feed additives. Something that is easily used in controlled feeding or cut and carry systems, but not so much in extensive grazing. So there are 2 sorts of additives to reduce emissions. There are the natural products from long chain fatty acids or oils, through 9 or 10 categories, as we see on the top line there. And I could have added saponins in there, as well as essential oils and those other things. But while those natural sources are showing some promise, I should say the only one in that top line that is highly effective is seaweed, and only some varieties of seaweed, particularly Asparagopsis. So people have gone to look for more pure high-impact additives. So, for instance, in Asparagopsis, one of the main bioactive compounds is bromoform. So now in our region, 2 companies at least are looking to synthesize bromoform without using seaweed and put that in as a direct, pure feed additive. So that work is in progress. Similarly, we know the Dutch company that developed 3-NOP, or as it's known, Bovair. A lot of investment in that product, pure compound that's showing promise. The same promise is not there for antibiotics or for antiprotozoals. We just haven't got ways of reducing protozoa effectively at the moment. But all of these technologies, they all face the same 4 challenges. What is their efficacy? And as I look at that list above, the only product that consistently would give mitigation above 50% would be seaweed or its active ingredient bromoform. Most of those other components will give us 5 to 10% mitigation. The 3-nitroxypropanol will give us, let's say, 20 to 30%. So that is...
Excuse me, Roger, you have another 3 minutes maybe left.
Perfect, thank you.
Thank you so much. Sorry.
So efficacy is important. We need these things to produce economic gain for the farmer. It may be through carbon credits, but ideally we need to better define the production benefits from these things, because the production benefits are very small. So we need large experiments to pick up 3 to 5% differences. It is important these things are safe in the food chain. So the bromoform and seaweed, as an example, is under intense focus as it brings iodine into the food chain, as it brings bromoform into the food chain. And of course, many of these things are volatile. So how can they work for people like you and me in tropical countries? How do we deliver them? So that is one of the key aspects there. In terms of general nutrition, it is not a needy research area. We know 3 things. Firstly, high starch diets reduce methane yield. Secondly, feeding animals better reduces emissions intensity. And thirdly, we live in hope that these bioactive forages, plants with tannins and saponins, are going to be able to serve 2 functions: to not only reduce emissions, but also provide dry season feed and high protein feed to improve our animal productivity. I think breeding for low methane ruminants is happening in the the high-income countries. You can see a number of projects there, and the genetic findings from that will feed forward to all countries as people establish genomic breeding values for, say, the leading dairy cows in the world. So a lot of prospects for genetic improvement. And let me just finish on vaccination. Almost all the vaccination work in the world is being done or managed through New Zealand. They are doing a very thorough job on developing the vaccine, but publishing very little. There are two reasons for that. One is that they want to be able to pass the information over to a commercial company and still have the intellectual property so the company can make money. If they publish the results, no company can make money, so they will not do it. And the second thing is it is a very slow process. As we say, Rome is not built in a day, and nor are we seeing vaccine results that are spectacular enough to filter out and enthuse us. So let me just finish with what I think is a way forward. We need to find a way forward, and we need to work on a food environment partnership to get multiple outcomes in our food systems. And I think for us, that is by our science focus going to emissions intensity. I think to make change now, we need to implement what I have called today's technologies. And we really need to address those things are already profitable, but people are not doing them. Why not? Let's solve that problem before we go to new products that have only a methane outcome. I'd encourage you that we should be working as a global team, and the GRA networks are just one mechanism for that. And likewise, I am quite hopeful that we will discover new products for tomorrow, because barely a month goes past without some new product coming into the conversation in my world. So I would thank you for your attention, and Ibu Bess, thank you for your time today. Thank you.
Thank you so much, Roger. We really appreciate that. Very nice presentation. And would you be patient to stay with us? Because we will have the question session at the end of after the two speakers. Meanwhile, you can check on the chat box. There are already two questions, regarding your presentation. Okay. And let me move on to the next speaker, which is Professor Dr. Cepi Sujana. Pak Cepi, are you ready? So his presentation is quite promising. You are still, yeah, okay. Quite promising. So we are hoping that the oil palm plantation can be one of the food resources, food and energy in the future. So the floor is yours. You have like 20 minutes presentation. Thank you.
Thank you, Ibu Bess.
Yes.
Hello, everyone. Good morning, ladies and gentlemen. I would like to, first of all, to thank the organizer of this conference who has invited me to this very important event. I'm very honored to have the opportunity to address and share the ideas on the development of cattle oil palm integration system in Indonesia. It is a very great opportunity to meet all of you in this important event. Let me begin with my first presentation. Indonesian Association of Integrated Cattle Oil Palm Entrepreneurs and Observers, called GAPENSISCA. This is just new organization. It's only established was in March of this year, which is very new. And we are very interested in looking at many research and application of this integration system all over Indonesia, which has begun in as early as 1997. But so far, out of 16 million hectares of palm plantation areas, only 130,000 hectares has applied this new system. Okay, let us see the ownership of this total 16.4 million hectares. This is a report from Ministry of Agriculture in 2020. 53% of the 16 million hectares belong to private enterprises, and then 42% belong to smallholders. and only 0.8%, 0.8 hectares, which is only 5% belong to state-owned enterprise. So looking at this portion, it is very challenging for us, particularly the palm plantation farmer in Indonesia, to also think about the joining operation between private enterprises and smallholders, because this will add a total of 95% of the total land available for oil palm plantation in Indonesia. Next. If you look at the some assumption of biomass available from the oil palm estate, for example, we will have palm leaves, which is 5%, and then palm frond, 7%, empty fruit bunch, about 16%, fiber, some 34%, and palm kernel, 27%. With the assumption of 130 palm trees per hectares, 22 frond per tree per year, and third frond for feed, and then 4 tons of palm oil per year. So from 1,000 kilogram of fresh fruit bunch, we will have 250 kilogram palm oil, 294 kilogram of palm mud, 180 kilogram of fiber, and 35 kilogram palm kernel cakes. This is very good opportunity for livestock raising under the palm oil palm plantation in Indonesia. Next. If we look at the overall Indonesian islands, there are 5 provinces, which is Riau. This is the largest oil palm plantation estate in Indonesia, and West Kalimantan. The second one, the third one is Central Kalimantan. The fourth one is North Sumatra, and then the last one, the fifth one, is East Kalimantan. Next. If you look at the red spot there, this is the provinces just mentioned before. North Sumatra from the left, and then Riau, and then South Sumatra, West Kalimantan, Central Kalimantan, and East Kalimantan. Next. Looking at the livestock subsector then, so far with the report from Ministry of Agriculture in 2021, Indonesia has the total consumption, annual consumption of 696,000 tons of beef per year. But the domestic production can only serve for 473,000 tons. Therefore, the live cattle import and beef import will provide the additional beef for the domestic consumption, which is 185,000 for live cattle import, equivalent to beef, and then 96,000 ton for beef imports. This is very challenging for Indonesia because beef is categorized as high income elastic commodities, and Indonesia has some 270 million population and has the growing middle income and upper income households, and this will push the demand for beef from year to year. Historically, Indonesia was able to export instead until 1997 or something, but after that we import feeder stock to provide some more beef production for domestic consumption. So up to now, our imports is continue to increase, and this will challenge whether Indonesia will keep the traditional approach to produce beef and beef cattle production from eastern part of Indonesia, such as West and East Nusa Tenggara, which is the grazing system lands was available at that time. But now the grazing area in those areas is is continue to decrease about 3% a year. But on the other hand, we have some 16.4 million hectares of oil palm plantation in the west part of Indonesia, such as in North Sumatra, Riau, South Sumatra, West Kalimantan, Central Kalimantan, and East Kalimantan. So this is one of the reason why the approach for integrated production of beef and oil palm system become one of the option for the future. We know that land resources is fixed. We cannot have additional land for production of food, and demand for food is continue to increase because the increasing population. And then we of course need the diversification. Since 1997, as I said before, some of the small farmers and smallholders and some companies try to integrate the production of cattle, beef cattle, under the oil palm plantation. But this approach moved very slowly because there was no research, but then there were some research, but only spotted research. It's not the thorough research from breeding, feeding, management, disease control, and marketing. But now Gapensiska expecting that those kind of research has to be conducted to make sure that people who are interested in investing oil palm plantation areas together with beef cattle production will have very secure information, and then they will try to spend some resources on this approach. Next. The reason for low national beef production, as I mentioned before, part of them, that is the increasing rate of national beef consumption. And then more than 80% of our beef cattle population in Indonesia is managed by traditional smallholders, farmers, as a side income and saving purposes. We also have low index of cattle ready to slaughter. Well, for example, there was a research saying that only 41% of cattle ready to slaughter, but they didn't enter to the market because they wait some time with targeted marketing on particular time of a year. So although we have enough animal to be slaughtered, but they did not enter to the market. This is the very low index of cattle ready to slaughter. The fourth one, the non-economic oriented of management practices of cow-calf operation, it is done by intensive system because usually the cow-calf operation has to be run using an approach of extensive system, such as the one that we have an opportunities now under the oil palm plantation area. The fifth one is decreasing trend of grazing areas for other purposes. I mentioned before, in the eastern part of Indonesia, such as the west and east Nusa Tenggara, there is a reduction or decreasing rate of 0.3% per year of grazing area. So in the future, it is very dangerous for the supplying region of beef cattle in Indonesia if we don't move to some other options, such as integrating with the oil palm plantation areas. The last one, of course, this is very high transportation cost because Indonesia is composed as many islands, and as an archipelago, you have to move one product to another space from producer area to the consumer area is getting very expensive. Next. Just take a look at the current total population of beef cattle in Indonesia, which is reached from this report from Ministry of Agriculture in 2019. Our total beef cattle production reaches 16.6 million heads, and 5 million of them are males population, and then 11.3 are female population. So we still have the opportunity to increase our population because we have lots of female calf, heifers, and cow in total compared to the calf, steers, and bull as a total population. This situation will be very challenging for us whether or not we can put our male and female population into the system of production under the oil palm plantation area. Next. Next slide, please. Yes. So we can assume, for example, out of 16.3 million hectares of oil palm plantation we have now, which is the largest area in the world, just assume 50% of these areas apply the integration system, cattle and oil palm, then with another assumption of 2 heads per hectare of oil palm plantation can serve per hectare, then there will be additional beef cattle population of 16 million heads, which is close to the current total population of beef cattle in Indonesia. This is just a very simple calculation, but of course this is not easy in the implementation because so far, this I just mentioned before, out of 16 million hectares of oil palm plantation, so far only 130,000 hectares of oil palm plantation that is now applying the integration system between beef cattle and oil palm. Next. This is the concept why the cattle oil palm integration system will benefit for all of us. If we don't integrate between these two sectors, then we only have oil palm products, then beef cattle farming product, which is very low. And as just mentioned before, only 80% of the cattle population in Indonesia are raised by smallholders. They're very inefficient. So with this integration system, instead of we have O on the left and then B on the right, but we also have OB, is an intersection between oil palm plantation and beef cattle farming. This is a mutual benefit that creates added value from cattle oil palm integration, which is OB, which will add to our total benefit. That is O plus B plus OB, instead of only O then only B. This is just a simple concept of why the integration system between cattle and oil palm plantation has a good prospect for the future. Next. This is the rationale for cattle oil palm integration, which is symbiosis mutualism, mutual benefit from relationship between oil palm estate and beef cattle farming. Plant biomass and process palm oil as animal feeds, that is leaves, palm frond, empty fruit bunds, fiber, mud, palm kernel, and other vegetation. This is very useful for feeds for beef cattle. And on the other hand, cattle produce organic fertilizer, bio-urine. Cattle also do the weedings, also do some farm traction, which is draft power, produce calf, and of course the life gain of each individual animal raised under the oil palm plantation. Next. Another notes from the advantages from the integration, among others, palm estate provide biomass, that is mentioned before, leaves, palm frond, empty fruit bunds, fiber, understory, and other vegetation under the palm trees, and processed palm oil such as mud, palm kernel available for animal feeds. Second one, cattle produce calf, feeder stock, organic fertilizer, bio-urine, do the weedings as and also play as a draft animal power. The third one, for the oil palm plantation management, this approach will reduce herbicide costs to 24 to 43%, increase the fresh fruit buns production by 15 to 25%, and reduce fertilizer costs by 30 to 40%. And the most important thing also is the community development for the local people, which is increase the welfare and the income for the farmer, both oil palm farmer and livestock farmer. Next. The integrated cattle and oil palm system, we call it short SISCA, is an acronym for a system cattle oil farm integration system. SISCA generally involves cattle directly grazing the native pasture and cover crops that exist under established oil palm. In commercial SISCA enterprises, cattle remain permanently in oil palm plantation, rotating from one block to another and only returning to the cattle yard every 3 months. Additional concentrate feeds or forages are required because the understory forage resource is of low quality and density. Next. Okay. As far as the cattle management is concerned, if we talk about the integration system between cattle and oil palm plantation, there are at least 3 options we have. The first one is intensive system, which is 24-hour cattle are put on the confine, on the barn, utilize palm oil byproduct and understory vegetation. Barn are located close in the vicinity or close by the oil palm plantation. Feeds are cut and carry, and then this system option also produce feeder stock and feedlot business. The second one is a semi-intensive, which is grazed during the daytime and the animal put in the barn during the night. This option is a combination of both grazing and confining, and utilize palm oil byproduct and understory vegetation, producing cows, feeder stock, and finished feeder stock. The last one is extensive option in which animals are grazed all year round. They keep out of the barn all the time. And the new approach now is very useful. That is, we can use what we call the electric fence to keep cattle in one area from the time that we look at the stocking rate of the animal in one area according to the vegetation available in that area. We can confine them naturally using the electric fence. This option, of course, providing barns and drafting yards, utilize also palm oil byproduct and understory vegetation, and also produce cow calf operation producing cows and feeder stock. Next. This is the illustration of how rotational extensive grazing, the last option that we just talked about, which is animal are grazed all year round. They never put in the barn. They move from one block to another block using the electric fence. And then they only coming back to the same area to the cattle yard every 3 months. This is the best practices of PT Siska in South Kalimantan. Next. Yeah, this is another interesting performance using integration between beef cattle and oil palm plantation. As far as cow calf operation is concerned, the conception rate can be achieved as high as 83%, and calving 78%, weaning 72%, mortality of cows 2.8%, mortality of calf 4.4%, and then calving interval 14.6 months. For rearing purposes, the average daily gain achieve 0.46 kilogram per day, and then life weight average for this life weight winning is 122 kilogram per head, and then mortality 2.4%. For patterning purposes, the average daily gain reached 0.68 kilogram per head, and then life weight average, this is for yearling, which is 205 kilogram per head, with mortality 0.67. This is on the left. This is the illustration. What is the cattle yard in open pasture, under palm pasture grazing infrastructure that categorized as best practices of the Siska Range in South Kalimantan. Next. Then, as I mentioned earlier, that if
have only 1 minute left, maybe can you
okay,
just
okay, we can extend this presentation in the discussion, because I would like to pinpoint the benefit of integrating the ownership between private enterprise and smallholders, which is more than 90% of the total area. Next. Yeah, this is the multiple benefit. We can discuss later because the time is constrained. Lots of benefit from oil palm mega sector. What this research by PASPI in 2016 mentioned. Lots of things that can be achieved as far as sustainable development goal indicators. Next. Okay, concluding of this presentation is that food, feeds, and energy can be assessed from this integration system. For example, food, we can have beef, mutton, oleo foods, and staple food produce such as sorghum, corn, soybean during the 5 years period of replanting, because oil palm farmers have to wait until the replant trees has the production. So this is the option. Feeds, palm leaves, palm frond, etc. It is available for the livestock. And then for the energy, we can access from the first generation of biofuel in the form of biodiesel, and second generation biofuel in the form of biomass-based bioethanol and POMI-based biogas. They produce jointly and sustainably. Thanks, Ibu Bes. Please forgive me for the time.
I know. No worry. Very excellent presentation, Pak Cepi.
Thank you.
Promising, and hopefully that the oil palm company or maybe smallholder farmers be part of the system. Thank you so much. Now let's move on to the last speaker, Dr. Charles Masembe from the College of Natural Science, Makerere University. Charles, are you already with us?
Yes, I am.
Thank you so much. So you are like 4 hours behind of us, yeah? So it's maybe like still in the morning. We are about noon right the time. So hi, how are you, Charles? Nice to meet you. Okay. So time is yours. We have around 15 to 20 minutes for your presentation.
Okay, thank you very much. Greetings to everyone, and I thank you for this opportunity for me to speak to you on this day. I'm going to, and thank you very much the chairperson of the session for a very nice introduction, and to my previous speakers who have touched a bit here and there, especially on cattle. We kind of face the same challenges, and that means we must come together and provide the solutions. We are asking ourselves in Uganda, how can we counter the challenges? How can we take advantage of the opportunities that there exist for us to be able to make sure that we produce cattle? Because then one thing is very right, climate is continuing to change. So it will not, we have to do quite a lot of effort, but the trend show that is going to change, it is continuing to change. But also, as the previous speaker mentioned, we still need food. We need all the varieties of food for our well-being. It is indeed a global village. So Uganda is somewhere this side. If I can show, where is this pointer here? Okay, but if you can see my cursor, then I'll use that. So Uganda is somewhere this side, and then we are right. We are here, right? And then we have Japan here. And just for the record, Chair, as you showed on the screen, right now I'm broadcasting from here, from Japan, because I'm here as a visiting professor to Kyoto University.
So you are not real from Uganda, yeah? Okay, go ahead.
Thank you very much. Our university, Makerere University, is one of the oldest universities in Uganda, and maybe indeed in Africa. We just celebrated our 100 years of existence, and we keep doing research to counter the society challenges. I present to you work from our molecular genetics laboratory. Yeah, it's a modest place, but we do quite many things, and our aim is usually to generate data which addresses conservation from wildlife and also in livestock, as we will see later on, to decipher issues as far as evolution is concerned. Now that there's a large interaction between livestock and wildlife, what are those pathogens that can be shared back and forth? And then the human aspect comes in as far as One Health is concerned. And again, knowledge transfer. We are made many times, as in the South, in the global South, we don't generate the knowledge, we don't generate the technology, but then we absorb the technology, and we have the challenges which that technology can address. So we cannot live in a silo. We have to reach out to our partners. We have to reach out to the global audience. We have to reach out to you in Indonesia, here in Japan, so that we can share and transfer knowledge and make sure that we appropriately use the technology that have been developed. And also for lesson learning, I can tell you that I've learned quite a lot from the beginning of this conference, and I'm happy to have attended. And I've also given the link, the YouTube link, to my classes, because I teach masters and undergraduate. I've sent the YouTube link for them to be able to log on and watch. Hopefully they are watching. And all that goes to capacity building, because we are not growing any younger, and you cannot have a forest which has got only one tree. You need every hands on the deck. So we have looked at evolution, and we have looked at strength. We're also looking forward to strengthening cooperations, both at national and global scale. And this is where, as we also go ahead in the presentation, please feel free to reach out. We're happy for collaboration. And we all speak in this sustainable development goals, whichever way that we can. We meet a certain target, we contribute. There's no single country, there's no single research institute which is going to say, now, yes, I have touched it, I've completed the sustainment SDG number 5, SDG number 7. No, we all contribute to that. And again, I'm happy that we are contributing. Uganda is kind of unique because it is located at the confluence of different biogeographic areas, the savanna rainforest, the dry areas, so they all converge around Uganda, as we also see later on. And then we also have the Great Rift Valley, so the Gregory Rift Valley, the western arm, and then the eastern arm. They kind of encircle Uganda. So Uganda is sitting somewhere in there. And that has quite a lot as far as the climate, as far as the evolution, adaptation, and biodiversity is concerned. You talked about zones here, and I also mentioned here that in Uganda, we have got several agroecological zones because of the vegetation, because of the environment, because of the microclimate. For example, the areas around Lake Victoria, this is Lake Victoria, the areas around the Lake Victoria, that one fall within the Lake Victoria Crescent. They have got quite a unique environment, a unique vegetation in there, and all the way up to the northern part of the country. So we have those variations. And talking about cattle, today I'm going to speak on cattle. We have the majestic Ankole cattle, but as we'll see later on, we also have several other cattle in Uganda, which are nicely distributed across the region of the country. So we have the Ankole Longhorn cattle, which is very well known for its horns, which are going out and then going up. And the distance between one horn could be up to maybe 3 meters or something. No, maybe 2 meters or something. And then we have the Karimojong Zebu cattle, which is kind of hardy, and you can really see the environment where it is staying. It is staying in this environment, but they are surviving. Then we have got the Teso Zebu cattle, which is also staying in a unique environment. And then we have got the Nganda cattle, and some other types of cattle as well, because of the variations in the vegetation in the country, the people have adapted to keeping certain types of animals, because these cattle are suited to survive certain environmental challenges, including vectors, pathogens like East Coast fever, and quite many others. If you look at an environment like this, we say, well, maybe livestock may not survive, but the livestock have adapted to survive in different environments of the country. And they can also stay with the several ticks. These are so many ticks which could not survive, which a Frisian could not keep even a single tick. But you find many of these livestock, given these horrible environments that they live in, they still have many pathogens. But what is very important about the Ankole cow or our local breeds is that specifically the Ankole cow, it has got a very good attribute for tick resistance. It can grow relatively faster. The milk quantity and quality is very good, and if you look at the amount of fats which are in the milk, if you analyze the milk of the Ankole cow and compare to that of the Frisian, you'll surely select that for the Ankole cow. The meat itself has got a low cholesterol level, and when it comes to lifestyle diseases, then that becomes very important. The tenderness of the meat from the Ankole cow is not compared to any other animal. The marbling ability is also very, very super, and the feed efficiency is also very good. And again, I've mentioned just again to re-emphasize the resistance. But this is what's happening also on the global scale. South Africa, our dear country, the southern South Africa, they saw the benefits of this Ankole cow also, and they have already taken it to South Africa. So you can see how much such a cow can cost compared to that in Uganda. And even in the US, they have already taken it. It is already in the US. And I think maybe there are aspects as far as patenting are concerned. And what is this conservation status by our FAO? Well, we are still going to check it out. So what is the difference? What is the importance of these ecological areas and adaptation? We have, I think, just like you in Indonesia, we have 11 million cattle, and you have about the same number in the same 2-digit figure. But the livestock in our country, it has survived in the different environments, in the different agroecological zones, and the people who have been keeping these cows, they have been keeping them from time and again. When it comes to celebrations of Christmas or any festive day, there's no farmer who is going to slaughter his best performing animal. They'll perform those ones which don't, they will slaughter those which don't give good results. So inadvertently, they are doing selective breeding without knowing. So if these people have done selective breeding without their knowledge, do we as scientists, as the elites in research, should we come in and disrupt that adaptation that they have selected for, or should we make efforts to support them and such that we can be able to produce even much better? But now, many governments, not only in Uganda, but many other areas, I also saw it in the previous slide, presentation, that many farmers, they prefer crossbreeding, they prefer foreign breeds because of the apparent increase in production. But then, if you do the crossbreeding, aren't you diluting what is already adapted to your environment, such as poor forage, such as gregariousness, or such as feed conversion? So we have not yet investigated or characterized the diversity in our local animals, in our local cows, and this can go for other domestic animals as well, so that we can use that as a baseline for improved reproduction and also adapting to climate change. Therefore, it is important to identify and characterize genes that are responsible for this resistance, genes that are responsible for this adaptation, so that we don't look to getting a new animal and we begin a readaptation, but we build on what nature and our pastoralists have been selecting for millennia and millennia. Therefore, if we do that, we shall be able to get resilient genotypes, which can be useful in sustainable farming and in the advent of climate change. So are we just sitting there lamenting? Well, no, you contribute a bit and then you move on. So we have done a characterization of the genetic diversity of indigenous cattle populations in the different cattle areas, as I will be showing. And then we have also tried to look for distribution of selective sweeps in relation to different variations in the environment. And also now that you have got, I saw the person who talked about the Internet of Things, data is now available. You can get the vegetation index across several years. You can get the mapping of the diseases geographically across several years. Then you can say, okay, look, everything that exists on the planet has got a GIS, a geographical reference. What are the geographical references? What are the climate key references as far as this part is concerned? And how come that the certain genotypes are located in certain areas and not in other areas? So you get a concerted effort from a multidisciplinary approach from different perspectives. So you get the vegetation index, you get the climate index, and then you overlay it, the genotype. So what we did here, you get this, the map of Uganda, and you get a grid, and you slap it, you overlay it on the that helps you to make sure that you don't sample haphazardly, but in the end you will have covered the whole country, and then you'll be able to analyze your data. And many times when you do our analysis, when you go to the field, you collect a sample, and then 2 months later or 1 year down the road, you find some unique genotypes, and then you ask yourself, wait a minute, this animal which we got, where we got this sample, where was it from? Oh, it was in certain area. Was it male or female? You look into your field book. Yes, it was male. Okay. What other attributes did it have? You can't have it because you did not record everything. So what we have decided to do, what we did is that from this cell, from this grid, every grid has got a name. And then so we come here and we take the photo of an animal. And then we say, this is Uganda, it is Bosporus, it is cell D8, and animal 180, meaning that we can still go back in our database or on our website and we're able to locate this animal. You never know what you'll be able to find. So samples collected, and these are ear nicks and also the blood or serum for disease investigation, and even for further investigations. You never know what you'll get. So this is how we collected the samples, and we dotted across in several areas. the area which is, if an area is marked red, then we have finished sampling there. If it is yellow, then we're still going on. And then from there, using the SNP chip, we did the SNP genotyping and also did modeling to find out how population genomics, environmental parameters can be combined together and do an analysis using the appropriate SNPs. I would say this is the most, I would show this and say, well, maybe this is the most key finding. There are others yet, but if you look with me, I told you I've got the different agroecological zones, because this is Uganda, agroecological zones, this is the Victoria Crescent. And then we have got I'll take two major breeds. We have got the Ankole breed, and then we have got the Zebu. If you look on this map here, you will see with me that there's a large part of Uganda and very little red in the southern part. So the green is dominating here, and the red very little in this part of the world, part of the country. But if you, there's quite a lot of red, and the green has infiltrated much more than the red has infiltrated the south. The green has infiltrated much more in the north than the red has infiltrated the south. What does this mean? This means that we are seeing a lot of Ankole breed associated genes, associated loci, and they're invading the northern part of the country. But when we look back, we know from our history that there's been encouragement of crossbreeding and then restocking, and the people are encouraged, they're always going ahead and buying cattle from down here and taking it up here. This is where we come in as scientists to try and advise government, to advise the key players, because then you are getting the genes from the south and introducing them into the north, and now you are getting a new type of animal, kind of, and you're not changing the vegetation, you're not changing the feed that is available, you're not changing the agroecological region. And so how do you expect this animal to continue surviving, to continue performing much better? And we have even already seen this one when it comes to calving. When you get artificial insemination with a bull from Ankole, and then you do breeding in the Zebu cow, then there will be challenges at patrician. Many times you have to go in and do the cesarean section to try and save the mother and the calf. So this is a lesson for us all to learn. And also what we found here that at the global scale, there's a bovine SNP chip.
Charles?
Yes?
Charles, you have like about 2 minutes left,
okay,
maybe?
Perfect.
It's very limited. I'm sorry about that.
It's all right. There are some unique SNPs that were located in our local animals, which are not included in the global bovine SNP chip. And then we have come up with some modeling and some approaches which we think they could be taken forward to try and adapt and also continue improving on the production of livestock. Indeed, our other colleagues from Iliri and other places, they found that, well, the Ankole cow is quite unique from other Boss breeds as well. So the challenges, there are quite many, the linkages between the stakeholders, the infrastructure, the human capital, and the biotechnology. This is where we look out to you, participants in this audience, and also beyond, to be able to partner with us, so we can partner with you, so that we can continue to do technology transfer and lesson learned, and even bring up the breeder organizations and strengthen the farmer systems. We have some IP laws already there. That one, maybe they will be used to address the issues, because when you're talking about genetic resources and the climate change and production, you're looking at the intellectual property. So we have quite a number of intellectual property laws which can be useful, but we can also learn from Indonesia, especially in the area of bovine, and also their aspect with the chili research. We have done quite a lot there. This work that I presented is not mine alone. I'm only a messenger, and there are many people, there are many institutions which have contributed here. If you see I've left out your institution and you're attending a conference, please pardon me for that, but it was not an intention for me to leave it out. But we appreciate the support of many people. And then I also appreciate the ICFAS committee, which gave me the opportunity to present to such a very wonderful audience. Tri Puji Priyatno, thank you very much for this. And the Puji Lestari, thank you very much. I thank you all.
Thank you so much, Charles, for your excellent presentation. Now we have very limited time. We have only about 15 minutes. And there are many comments from the chat box. Charles, you can take a look on the chat box. There are like 2 questions for you. And now I would like to hand over to Roger. Roger, could you respond to the question raised by the audience? We have like 5 minutes, Roger. And then the next, Pak Cepi Sujana, you have also 5 minutes, Pak Cepi, and then Charles, another 5 minutes. Thank you. So Roger, time is yours.
Come back to life. Sure. So thank you, Ibubes. So look, I have done my best to answer those questions as we go through. Maybe I will just make some general comment, particularly following on from the Uganda presentation we just heard. Look, there's a real opportunity for us to use greenhouse gas not as a punishment, not as a stick, but as we would say, as a carrot, as an incentive to help our farmers to manage their farms in a way that is going to be more profitable to them. And I've had a number of students who have been extension officers in Indonesia, and I appreciate the very strong communication the government departments have with the producers there. And I really think that we have opportunity to use greenhouse gas control as a motivator for change, to help farmers do things that are in their financial interest, such as improving their nutritional management, such as managing livestock that are, if not crossbred, because not everybody likes crossbred, but genetically suited to their place. We know a lot of Southeast Asian cattle are very little, very small, whether that's barley cattle or yellow cattle. And so that genetic limits us a little bit. But instead of just going for high genetic merit cattle, we need to work up to that so we do not sacrifice our environmental advantage by putting in genetics that is inappropriate. So I think all of those things about managing your nutrition, managing your animal health, all of those things that are productively and financially sensible are also helping us to drive down our emissions intensity. And I think that makes farmers feel that they are doing good for the environment, and it is commendable, rather than trying to tell them you are doing something very bad by having cattle producing emissions. So I think how we approach the issue with farmers is important, and I think we have much to offer them with today's technology, even if we don't have feed additives that are ready for use.
Okay, thank you so much, Roger. Very nice explanation. And now I would give opportunity to Pak Cepi.
Yes,
Cepi, you have like about 5 minutes with 8 questions. Maybe you can just general response.
I know. I have 9 questions, very interesting one. But if I spend 1 minute each of the question, then I will need 9 minutes, right? So I will just. Okay, I will just respond in very general term. I think those who ask the question can also take a look at my presentation. I think the presentation will be shared also to the participant, right? Yes, Pak Diki, which breed? As far as we know, Bali cattle, which is a very die-hard breed of animals under every condition, but is very susceptible with Jembrana, okay? And on the other hand, the Brahman cross is a bigger, but also need an adaptation before they getting used to the new areas. Pak Nasir, you can, I was running out of time when I was going to the last two slides. There was a nucleus palm estate partnership. That is, maybe can answer your question. And also on the slide on the multiple benefit of oil palm mega sector there on the last two side. Ibu Risa, we will keep learning on a lot of things that you consider as drawback, for example, and we also have categorized whether this information is mythos or facts. So we have learned a lot of things, and also will contribute to why the adaptation or implementation is going very slow. On soil compaction, Mr. Satya, I have yet no final information, but as far as I know, there is one big company in Central Kalimantan. They run 500 head per 30 hectares per 1 day. So if we talk about the soil compaction, nowadays the harvesting fresh fruit bunch also using tractor. And this tractor will going forth and backward every 2 weeks around the palm trees, and there has no problem with that. So the issue of soil compaction is already answered, along with the issue on Ganoderma. We have also research on that, but we keep learning and do some more research on the thing that still need the answer. Cattle, Ibu Anna, cattle owned by locals or managed by locals, owned by and managed by private enterprise. Yes, both cases are true. Particularly, this farmer, cattle farmer, were the transmigrant, and they are familiar with keeping animal, which is cattle. And once they become the transmigrant and have 2 hectares, and they plant the oil palm, and then they also merge between the management of cattle and also oil palm. Yes, both cases are true. There is also one private enterprise who own and manage their own cattle as well as their own oil palm plantation. Ibu Delisa Nora from YouTube. Her question: how synergy land management and sustainable animal feeds? I think I have presented in one of my slides the option on grass-fed, which is the confined, and then the grazing, and then the semi-intensive option of this. As far as this option is concerned, I think this is related to the availability of grasses or feed available on the oil palm plantation. From Pak Azhar, farmer as oil palm or farmer or cattle farmer. I said before, initially farmer were the transmigrant, and then they were given 2 hectares of land, and they plant the oil palm, but also they raise cattle because they have long time experience on raising cattle on Java. And then they learn from experiences as far as technical issues is concerned. They learn, and you can visit also our website if you would like to have more answer or information from this application. From Pak Hakim, BRIN can be done by for dairy cattle. I think we don't have that information as as per now, I think we will consider in the future, because the management system for beef are very much different than for dairy cattle. From Pak Astu, cattle in palm plantation did not increase much. Yes, I mentioned earlier, out of 16.4 million hectares of oil palm plantation, so far only 130,000 hectares that has been applicating this approach the system, because there are lots of information which is not sure for those who are interested in putting some investment on this issue. If you look at my slide on the performance of the integration system, you can look at the best practices on cow-calf operation. I put information there on conception rate of 80%, calving rate 78%, and winning rate 72%. Say if you have 100 cows, you will have 72 winning animal calf. It's if we have lots of population like this, then the improvement, the increasing population of cattle raising under the oil palm plantation will, of course, you will see that it is very productive, because they don't have any restriction on feeds compared to some others area, which is very, very difficult to find feeds, especially for those cut and carry system on Java. The last one, question from yes, this is from Pak Astu.
Astu is the last one.
Yes. I think I have one information that the Siska enterprise start with maybe around 50 animals. Now has sold around 300 heads of finished animal in 4 years. So if more and more enterprise like this, I think it's very significant, the improvement of cattle population under the oil palm system. The last one is palm oil byproduct. I think it's very excellent concentrate so far. In the past, we export of this soybean cake, because the oil palm enterprise is very happy. There is someone who removed this product, but actually we in turn import the what you call the feed, ready feed to those countries that we export the cakes. Yes, so we can use it by ourselves in domestically. Thank you. Please contact our website, Instagram, and also Facebook, as I put on the very last slide on my presentation.
Thank you so much for your response, Pak Cepi Sujana. Now we move on to the last speaker. Charles, would you like to respond? We have like 3 or 4 questions, so time is yours.
Yeah. Thank you very much, Chair. Penny Lestari, yes, you are interested in selective breeding. Yes, the selective breeding is we're also very interested in that. And if you have got techniques from using the crop, applying it in crop selective breeding, but I'm sure even those principles can be applied in the animal, although with a little tweak. Just like you mentioned that if you have a result which you don't like, you discard the seeds. Then what do you do with the result of hybridization when it does not meet your target? Then you just control it and you don't introduce into the breeding for the next generation. But yes, we are happy to link with you. We are happy to learn from each other. Together, we are stronger. Dicky, how do we improve how do we do genetic improvement? Of course, looking at the evolution of the cattle from the Auroch and all the way back in the millennia of years, these animals have been, they migrated, they follow the human migrations. So definitely there's genetics of this and that species. It is the amount which varies. But the question is, you asked, do we need to improve the Ankole, the Ankole cow? The question is, I would twist it and say, do we need to maintain? Do we need to improve? Because now what is happening is haphazard. We do not have a farmer or breeders association. It is a farmer visits another farmer and say, okay, your herd looks very nice. Which bull did you use? I use this one. Okay, can I borrow that one? And this also goes into Risa Antanu's question, whether there's a mating system in Uganda or not. The quick answer would be, no, there's no mating system, but is there anything in between? Yes, there's something in between. Some farmers use the artificial insemination from the national animal genetic resources. Some farmers, they use the borrowed bulls because they have seen a bull which is good. Some farmers have got a bull which is resident in the herd. So it is a mixture of things. Just like Roger mentioned, this is when we come in. We have got all this evidence. We have got all this information. How can we support the farmer? How can we encourage the farmer so that we move together into this era of climate change and improve production? I thank you.
Are you finished with your response, Charles?
Yes, I am.
Okay, thank you so much. Since we are limited tough time, so I'd like to end the session. I'm not going to make any conclusion of this session because so many questions is a very interesting and very attractive, interactive discussion. I think if we leave it into live presentation for all, So thank you so much for Professor Roger Hegarty from the New Zealand. Thank you so much for Professor Cepi Sojana from Bogor, as well as Dr. Charles Masambe from Uganda. My great apology if during guiding the session, I have like some inappropriate wording. So I hope everything is running well with you and your research. By now, I would like to hand over to the committee. Thank you so much.
Thank you.
Thank you. Okay, big applause for the chairman and all the speakers. Thank you very much, Ibu Dr. Bes Tisnamurti, for leading this session. And thank you for all speakers for the excellent presentation. We would like to extend our appreciation for the chairman and all the speakers, and we have certificate of appreciation for all speakers and for the chairman, Ibu Dr. Bes Tisnamurti. And we would like to invite the chairman of ICFAS 2022 committee, Bapak Tri Puji Priyatno, PhD, to deliver the certificate for all the speakers and the chairman.
Okay, thank you for Professor Roger Hegarty for sharing about greenhouse gas emission reduction. We highly appreciate your time with us today.
My pleasure. Thank you very much, and thank you for the committee inviting me to speak. It was a privilege.
And also for Professor Cepi Sujana, it was interesting topic shared on cattle oil palm integration system. Thank you for your contribution.
Thank you very much. to the organizing committee. Very excellent.
Masuk ya? Suara baterai nggak masuk.
And also for Dr. Charles Masembe, thank you for sharing about cattle production in Uganda. Thank you again for all speakers' contribution in this conference. Thank you very much.
Thank you. Thank you very much. It is nice to link up with this part of the world.
And also thank you for Dr. B. Tisnamurti for moderating this session. Thank you, Ibu Bes.
Thank you so much, Pak Puji.
Enggak, ini kan udah stop.
Okay, thank you very much. Ladies and gentlemen, next we have break until 1 o'clock. Then we hope all of you along with us in parallel session. But during the break time, we have information from ICFAS Science Indonesia about practical and reliable sampling preparation and testing for fertilizer, cereals, grains, and feedstuff. With moderator Ibu Warda Marisa. She is an application specialist, ICFAS Science, and the speaker is Ibu Amanahwati. But before that, we are delighted to present to you the thumbnail video ICFAS Science. Please enjoy it, and to Ibu Warda Marisa, please, time is yours after this video.
Halo. Halo, halo. Halo, assalamualaikum. Waalaikumsalam.
Oke.
Just tes.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Selamat siang Bapak dan Ibu. Selamat beristirahat. Tapi selama beristirahat kami akan menemani Bapak Ibu dalam lunch break seminar hari ini di acara First International Conference on Food and Agriculture Sciences 2022. Hari ini kami dari PT ICFAS Science Indonesia, kami akan membawakan topik lunch break seminar, yaitu dengan judul Practical and Reliable Sampling Preparation and Testing for Fertilizer, Cereals, Grains, and Feedstuff. Sebelum mulai, mewakili PT ICFAS Science Indonesia, saya ingin mengucapkan terima kasih banyak kepada seluruh panitia yang bertugas dan Badan Riset dan Inovasi Nasional yang sudah menyelenggarakan acara hari ini. Baik, Bapak Ibu, sebelum mulai pemaparan materi hari ini, mohon izinkan saya untuk memperkenalkan diri. Saya Warda Marisa, saya Application Specialist dari PT ICFAS Science Indonesia. Hari ini saya bertugas sebagai moderator. Nah, karena tidak mengenal kata saya.
Boleh tanya, Bu?
Ya, gimana Pak?
Ya, maaf, Bu. Nanti untuk room itu apakah otomatis, Bu, kita buat atau kita gimana caranya?
Mungkin nanti setelah selesai lunch break seminar, nanti akan dibantu oleh tim panitia, Pak. Semoga cukup membantu ya, Pak. Baik, saya akan lanjut. Jadi sebelum mulai pemaparan, saya akan memperkenalkan terlebih dahulu pembicara untuk lunch break seminar hari ini, yaitu Miss Amanahwati. Miss Amanah lulus dari Gajah Mada University tahun 2016 dan dalam bidang kimia dan sudah join dari ITS Sains Indonesia sejak tahun 2018. Miss Amanah ini sangat berkompeten dan expert dalam hal high-end instrument, terutama untuk automatic titrator, thermal, element, dan particle size analyzer, serta alat high-end lainnya. Jadi nanti Bapak Ibu bisa langsung bertanya setelah pemaparan. Jadi kita akan punya sesi tanya-jawab, dan juga yang paling penting adalah kami juga menyiapkan kuis dengan hadiah total Rp500.000 untuk 5 orang pemenang. Baik, tanpa berlama-lama, saya akan persilakan Miss Amanah untuk mulai materinya. Baik, terima kasih Ibu Warda Marisa atas perkenalannya. Ya, terima kasih Bapak Ibu semua atas kehadirannya pada siang hari ini. Saya Amanahwati, seperti yang disampaikan Ibu Marisa, saya akan menyampaikan sedikit informasi di lunch break seminar ini tentang practical and reliable sampling preparation and testing for fertilizer, cereals, grain, and feedstuff. Sebelumnya, izinkan saya untuk sedikit memperkenalkan ITS Science Indonesia. Jadi ITS Science Indonesia adalah salah satu grup dari ITS Group. Headquarter kami ada di Singapura dan di Indonesia sendiri kami sudah berdiri dari tahun 1997. Kami memiliki beberapa sister company di beberapa negara. Yang paling terbaru yang join di tahun 2021 adalah Kamboja. Ini adalah alamat kantor kami di Indonesia, ada di Jakarta, Surabaya, dan Makassar. Oke, langsung saja ke topik seminar hari ini. Terkait dengan food safety atau food security, kami coba ingin men-share informasi mengenai bagaimana men-sampling sebagai tahap preparasi dan menganalisa beberapa bahan makanan dan bahan support untuk agriculture juga, seperti pupuk, sereal, biji-bijian, dan pakan ternak. Sedikit saya bahas mungkin tentang food security. Kita tahu bahwa food security sebetulnya adalah suatu akses yang dimiliki oleh setiap orang, dan pada setiap waktu untuk mendapatkan makanan yang bernutrisi tinggi, makanan yang baik, dan makanan yang aman, sehingga bisa meningkatkan produktivitas dan kehidupan yang lebih sehat. Terkait dengan food security, kita tahu ada 3 isu utama. Yang pertama adalah perdagangan makanan secara global, kemudian pertumbuhan populasi dunia yang semakin meningkat, dan perubahan iklim. Yang terakhir dari faktor perubahan iklim. Kita tahu bahwa dengan isu perubahan iklim ini banyak sekali isu yang menyebabkan food security ini menjadi penting atau menjadi perhatian, seperti meningkatnya patogen di produk agriculture, kemudian penggunaan pestisida yang semakin banyak karena hamanya pun semakin banyak, kemudian adanya logam-logam berbahaya, kemudian mikotoksin dari produk sampingan jamur, dan kemudian dari produk-produk perairan sendiri yang terkontaminasi. Ini adalah beberapa jenis penyebabnya ya, ada bakteri, parasit, virus, kemudian toksin-toksin yang terbentuk secara natural, polutan logam berbahaya. Dan menurut WHO sendiri, makanan yang tidak higienis ternyata menyebabkan lebih dari 200 penyakit yang berbeda, dari diare sampai kanker di setiap tahunnya. Kemudian dari setiap tahunnya 1 dari 10 manusia mengalami sakit, dan menurut WHO dalam 1 tahun tersebut terdapat 420.000 kematian dari total 600 juta orang di dunia ini yang diakibatkan oleh makanan yang tidak higienis atau makanan yang tidak aman.
Oleh karena itu kita penting sekali untuk melakukan analisa terhadap makanan baik secara kimia maupun biologi. Terkait dengan judul seminar ini, saya akan paparkan mengenai 4 jenis bahan dari pupuk sebagai support material untuk produk agriculture, kemudian sereal dan biji-bijian sebagai bahan utama dari makanan pokok kita, baik itu roti, mie, ataupun beras, kemudian pakan ternak yang menjadi makanan utama dari protein hewani yang tentunya juga kita konsumsi. Ketika semua bahan ini sudah aman, dipastikan aman, kita bisa pastikan bahwa makanan tersebut juga aman untuk dikonsumsi dan disajikan di keluarga kita. Untuk analisa pertama adalah analisa kimia. Proses pertama yang dilakukan adalah proses preparasi. Preparasi sendiri memiliki pengertian yaitu adalah penghancuran atau pengurangan ukuran dari ukuran yang besar menjadi ukuran yang lebih kecil sehingga mudah diekstraksi atau mudah direaksikan. Dan ukuran-ukuran itu tergantung dari aplikasi atau parameternya sendiri. Di sini ada beberapa jenis alat preparasi atau alat milling yang konfigurasinya atau spesifikasinya itu bergantung dari ukuran awal sampel atau feed size dan ukuran akhir sampel atau nilai ukuran akhir kehalusan yang diinginkan. Selain itu juga ada tahap dalam beberapa pengukuran, ada pengukuran kadar air, kemudian ada juga pengukuran zat-zat yang mudah menguap mungkin dengan menggunakan furnace, dan terakhir adalah tahap analisis. Tahap analisis ini bisa menganalisis kadar logam, baik itu logam berat maupun logam-logam major yang memang dibutuhkan sebagai nutrisi di pangan itu sendiri. Yang kedua adalah analisa biologi. Sama seperti analisa kimia, tahap pertama yang kita lakukan adalah preparasi, dan kemudian untuk analisanya ini terkait dengan bahan-bahan organik yang terbentuk secara natural ya, contohnya seperti mikotoksin, aflatoksin yang bisa kita analisa dengan absorbance micropet spectrophotometer atau UV spectrophotometer. Dan saya akan coba menjelaskan sedikit per tahap mengenai analisa laboratorium untuk bahan pangan ini. Yang pertama adalah sample preparation. Seperti yang saya sebutkan bahwa sample preparation ini menggunakan alat milling. Alat-alat milling ini banyak jenisnya, bergantung dari secara alat mungkin kita bisa lihat dari jenis pisau atau jenis penghancur yang digunakan. Itu pun akan disesuaikan dengan ukuran awal dari sampel atau bahan pangan itu sendiri. Ada rotor mill, ball mill, knife mill. Untuk rotor mill ini kita bisa lihat bahwa alat penghancurnya adalah seperti blade ini. Biasanya digunakan untuk sampel-sampel yang masih besar ukurannya, seperti daging, sayur. Kemudian ada ball mill, ini biasanya digunakan untuk menghaluskan sampel menjadi ukuran yang lebih halus lagi, atau bisa dikatakan ukuran-ukuran yang kehalusannya seperti bubuk. Biasanya menggunakan ball mill. Kemudian ada knife mill. Knife mill ini adalah alat yang digunakan untuk menganalisa sampel yang lunak seperti daging, sayuran, buah-buahan, dan mungkin bahan pangan berair lainnya. Oke, untuk sampel preparation ini kita tidak harus melakukannya dalam satu tahap. Sangat memungkinkan untuk dilakukan dalam 2 tahap, tergantung dari final ukuran yang diinginkan. Jadi untuk sampel yang materialnya keras, kita bisa hancurkan dulu dengan alat rotor mill tadi, kemudian lagi dengan ultracentrifugal mill. Ini biasanya ketika kita ingin mendapatkan sampel berukuran di bawah 100 mikrometer. Kemudian ada pula untuk sampel yang lunak, kita bisa hancurkan dengan alat cutting mill di awal. Kemudian jika ingin halus lagi, kita bisa haluskan dengan alat ultracentrifugal mill atau ZM200 ini adalah salah satu model dari ultracentrifugal mill. Nah, ini adalah salah satu contoh alat milling dari cutting mill model SM100. Spesifikasinya adalah material yang bisa masuk berukuran di bawah 60 kali 80 mm. Nanti nilai kehalusannya setelah milling itu ada di range 0,25 sampai 20 mm. Jika ingin halus lagi bisa dihaluskan dengan SR300. Dia memiliki feed size atau ukuran sampel awal di bawah 25 mm dan final kehalusannya itu di bawah 50 mikron. Kemudian setelah dihaluskan kita bisa masukkan ke dalam sample divider. Alat ini berfungsi untuk mensampling ya, jadi bisa mensampling secara representatif. Selanjutnya, jika ingin mendapatkan material yang lebih halus lagi dengan ukuran di bawah 50 mikrometer, kita bisa gunakan rotor mill yang ultra centrifugal adalah ZM300 atau ball mill MM500 kontrol. Ini juga alat yang digunakan untuk mendapatkan kehalusan yang sangat kecil. Biasanya berfungsi untuk ekstraksi atau analisa mikotoksin dan sebagainya. Ini adalah salah satu contoh bahan yang telah dipreparasi. Bahannya adalah fertilizer, ukuran awalnya 5-15 mm dan bobotnya 130 gram. Kemudian dihancurkan dengan alat ZM300 dan didapatkan hasil akhirnya adalah 98,5%, bisa dilihat ini gambar 4 ya, jadi cukup halus, ukurannya di bawah 500 mikrometer. Lanjut untuk sampel pakan, ukuran awalnya 0-20 mm dalam bentuk pelet, kemudian dihancurkan dengan alat knife mill. Jadi knife mill ini seperti blender, bisa dilihat blade-nya. Untuk ukuran akhir yang didapatkan itu di bawah 1 mm. Untuk di gambar 4 ini terlihat ada ukuran powder dengan penggaris 1 mm. Selanjutnya adalah sampel jagung kering. Ini juga memiliki ukuran awal 7 mm, cukup besar. Dengan alat ZM300 ini bisa dihasilkan sampel powder dengan ukuran kehalusan 150 mikrometer. Ini sangat baik sekali ya ukuran ini untuk digunakan dalam analisa mikotoksin. Selanjutnya ini adalah biji-bijian yang masih mentah. Ini ukuran awalnya 2-5 mm, kemudian dihancurkan dengan alat rotor mill juga, untuk modelnya adalah cyclone mill twister. Ukuran akhirnya ini mencapai di bawah 1 mm. Lalu ada sereal. Sereal ini ukurannya 85 mm. Nah, untuk sampel yang besar seperti ini kita bisa potong secara manual terlebih dahulu dengan pisau. Selanjutnya setelah mencapai ukuran yang lebih kecil bisa langsung dimasukkan ke alat ZM300 ini dan akan didapatkan ukuran yang sangat halus di bawah 1 mm untuk setiap partikelnya. Nah, ini adalah beberapa contoh lainnya seperti sampel beras. Ini menggunakan alat rotor mill juga. Ini bisa menghasilkan ukuran di bawah 100 mikrometer dengan komposisi 80%. Kemudian ada sampel hazelnut. Ini kita tahu bahwa bijinya cukup keras. Nah, ini menggunakan alat cutting mill model SM100. Hasil akhirnya bisa mencapai kehalusan 1-2 mm. Kemudian untuk sampel kentang yang sudah digoreng pun kita bisa analisa dengan menggunakan knife mill untuk sampel-sampel yang lunak. Ini hasilnya sangat homogen di bawah 1 mm. Kemudian untuk sampel daging kita bisa menggunakan knife mill juga. Untuk ukurannya ini kita bisa lihat cukup besar ya, di bawah 20 mm. Dan hasil akhirnya ini sangat halus, bisa dilihat di sini ini pun di bawah 1 mm. Oke, kalau tadi kita sudah bicara tentang tahap preparasi, sekarang kita masuk ke analisa sampel. Untuk analisa sampel atau proses penentuan kadar ya biasanya, salah satu alat yang digunakan adalah alat element analyzer. Nah, yang ada di layar ini adalah alat element analyzer untuk mengukur kadar nitrogen. Kalau mungkin yang kita tahu alat untuk mengukur kadar nitrogen biasanya dengan menggunakan metode Kjeldahl. Ini ada alat untuk mengukur nitrogen dengan metode Dumas. Jadi metodenya ini adalah dengan sistem pembakaran. Kemudian sangat singkat, dilakukannya mungkin tidak lebih dari 10 menit dan ini bisa dilakukan untuk banyak sampel. Mungkin bisa sampai 40 atau 60 sampel sekaligus akan dibakar secara bersamaan dan akan didapatkan hasil nitrogennya pun secara bersamaan. Untuk contoh pengukurannya, ini ada sampel dari beberapa tepung ya. Bisa dilihat ini ada kadar nitrogen yang dihasilkan untuk setiap tepung. Kemudian kita juga bisa langsung konversi ke kadar protein. Jadi alat ini adalah PC control yang di software tersebut kita bisa masukkan konstanta untuk protein. Jadi kita bisa dapatkan kadar protein sekaligus. Kemudian yang kedua adalah untuk contoh penentuan kadar nitrogen di pakan ternak. Di pakan ternak ini kita dapatkan beberapa hasil untuk beberapa sampel seperti pakan ternak untuk sapi, pakan ternak untuk ayam dan sebagainya. Ini juga kita dapatkan kadar nitrogennya hampir mirip karena memang untuk pakan ternak sendiri kurang lebih kebutuhan nitrogennya itu hampir sama. Dan kita juga bisa langsung dapatkan kadar protein dengan memasukkan nilai konstanta untuk kadar protein tersebut. Yang ketiga adalah penentuan kadar nitrogen di pupuk anorganik. Seperti yang kita tahu bahwa penentuan nitrogen di pupuk anorganik menjadi hal yang penting karena kandungan nitrogen di pupuk akan membuat tanaman itu tumbuh semakin besar dan tentunya akan meningkatkan kualitas tumbuhan yang diberikan pupuk tersebut. Untuk pupuk yang dianalisa ada amonium nitrat, kemudian pupuk cair dan NPK. Nah, kita bisa lihat di sini untuk kadar nitrogennya, kita tahu bahwa di amonium nitrat itu kadar nitrogennya itu cukup besar, di angka 34,8%, kemudian di pupuk NPK di posisi kedua untuk kadar nitrogennya, dan untuk pupuk cair ini cenderung lebih kecil untuk kadar nitrogennya. Dan ini untuk sampel dengan range bobot 20-100 mg, dan waktu pengukurannya hanya 5 menit. Jadi meminimalkan penggunaan bahan kimia, meminimalkan waktu pengerjaan, dan juga lebih cepat karena sampel yang dianalisa bisa langsung dalam jumlah banyak. Ini adalah alat rapid Max dan Rapid Seed. Jadi memang ada dua alat yang digunakan untuk penentuan kadar nitrogen. Yang memiliki cerobong ini disebut Rapid and Max karena dia bisa mengakomodasi sampel dalam jumlah yang lebih besar seperti tanah atau pupuk. Kemudian Rapid and Exit ini yang tidak memiliki cerobong digunakan untuk sampel dengan bobot yang kecil, artinya kadar nitrogen, artinya matriks yang berada di sampel itu tidak terlalu besar seperti sampel-sampel makanan atau sampel-sampel protein hewani. Ini adalah hasil pengukuran untuk susu hazelnut dan susu almond, penentuan kadar nitrogen dari Rapid and Exit dan Rapid and Max. Bisa dibandingkan bahwa kedua alat ini menghasilkan kadar nitrogen yang kurang lebih hampir sama. Ini mungkin sedikit cara kerjanya, jadi sampel hanya dimasukkan, kemudian dibakar, dan nanti akan diubah menjadi gas. Gas nitrogen akan diubah menjadi gas, nitrogen akan dirubah menjadi gas nitrogen, kemudian akan dibaca oleh detektor, dan nanti ini yang akan dikonversi menjadi kadar nitrogen di dalam sampel. Ini adalah sedikit spesifikasi dari kedua alat ini, Rapid N dan Rapid Max. Selanjutnya adalah analisa untuk mycotoxin menggunakan alat ELISA. Jadi ini ada alat ELISA dari biotech. Biotech ini cukup familiar ya, digunakan untuk menganalisa kadar mycotoxin, aflatoxin, atau fumonisin. Ini adalah salah satu contoh jurnal yang telah menggunakan alat biotech untuk menganalisa organik polutan tersebut. Bisa dilihat kadar yang dihasilkan ini mencapai range ppb, artinya untuk kadar-kadar yang sangat rendah, alat ini sangat mungkin digunakan untuk menganalisa kadar yang sangat kecil. Selanjutnya ini untuk sampel buah-buahan kering didapatkan pula dalam range ppb, jadi ini sangat sensitif untuk pembacanya. Selain itu alat biotech juga digunakan sebagai, karena ini ELISA adalah metode yang primer, metode yang utama ya untuk menentukan kadar mycotoxin di makanan. Jadi ada jurnal yang ingin menentukan kadar fumonisin tapi dengan metode NIR. Namun dia masih menggunakan biotech sebagai referensi metode. untuk menganalisa kadar mikotoksin, kemudian dibandingkan dengan hasil pembacaan dari NIR tersebut. Oke, mungkin ini yang bisa saya sampaikan. Terima kasih atas perhatiannya Bapak Ibu. Untuk selanjutnya saya kembalikan ke Ibu Warda Marisa.
Baik, terima kasih Miss Amanah. Wah, terima kasih pemaparannya sangat luar biasa. Jadi ada 3 kategori alat yang di-share oleh Miss Amanah untuk hari ini. Jadi yang pertama untuk preparasi sampel dari REG, mulai dari knife mill, ball mill, terus kemudian alat berikutnya adalah untuk pengujian nitrogen analyzer dari elementar. Terus terakhir juga sempat di-share oleh Miss Amanah, yaitu alat ELISA reader dari Agilent Biotech. Nah, Bapak Ibu, mungkin kalau misalnya ada pertanyaan bisa langsung ditanyakan di kolom chat. Jadi nanti kita akan bahas. Nah, kebetulan nih ada satu pertanyaan dari Ibu Tri Budianti. Apakah bisa preparasi sampel dengan freeze drying?
Ya, terima kasih Ibu Bu Tri Budianti. Ya Bu, untuk sampel freeze drying, dengan alat kami, nanti ada semacam aksesoris atau tambahan. Jadi Ibu menambahkan seperti zat pendingin ya, bisa secara cryogenik atau menggunakan liquid nitrogen. Jadi sangat memungkinkan untuk menganalisa sampel dalam suhu ruang ataupun suhu dingin. Seperti itu. Aplikasinya cukup luas.
Baik, terima kasih untuk jawabannya Miss Amanah. Dan mungkin Bapak Ibu kalau misalnya ada pertanyaan lagi boleh dituliskan di kolom chat. Nah, mungkin ada pertanyaan. Jadi tadi selain alat untuk preparasi sampel, untuk menghaluskan sampel, kita juga sempat membahas alat elementar nih dari yaitu untuk uji kadar nitrogen. Nah, kalau tadi saya lihat ada banyak juga sampel yang bisa sekaligus dikerjakan ya. Dan sepertinya mungkin ada pertanyaan seperti ini. Ketika sampelnya banyak, pasti membutuhkan waktu yang sangat lama, mungkin bisa lebih dari 1 jam. Nah, apakah alat ini bisa ditinggal atau misalnya auto di semacam kita setting, terus kita tinggal, nanti kembali lagi hasilnya sudah selesai?
Ya, tentu alat ini bisa ditinggal, jadi pengoperasiannya sangat mudah. Yang harus kita lakukan di awal adalah mempreparasi sampel dengan tadi menghaluskan sampel. Setelah itu sampel yang sudah halus kita masukkan ke dalam wadah. Jadi wadahnya itu ada yang dari crucible, ada juga yang dari tin foil. Sampel tersebut dapat kita langsung masukkan dan setelah setelah ready, sampel tersebut akan dimasukkan ke dalam karosel. Jadi ada semacam karosel di bagian atas alat, itu adalah tempat sampel diletakkan. Untuk selanjutnya sampel karosel tersebut akan berputar. Nanti sampel-sampel tersebut akan masuk ke dalam sistem pembakaran satu per satu. Setelah sampel yang satu selesai, sampel yang lain akan bergantian masuk ke dalam sistem pembakaran. Dan itu dilakukan secara otomatis. Kita tinggal men-setting berapa banyak sampel, kemudian penamaan sampelnya, identitas sampelnya tinggal kita setting, nanti setelah selesai hasilnya pun akan langsung keluar semuanya, baik dalam grafik maupun dalam nilai kuantitinya, seperti itu.
Baik, ini ada pertanyaan lagi dari Ibu Ervika Rahayu. Apakah bisa dibandingkan hasil uji protein dengan elementar analyzer dengan metode JEDAL? Terus kemudian ada satu lagi, mungkin bisa sekalian karena elementar, apakah alat untuk pembacaan nitrogen analyzer ini bisa membaca NH3 dari sampel cair?
Oke, terima kasih Ibu Ervika, Ibu Ervika ya, dan Ibu Hikmah. Oke, mungkin saya jawab pertanyaan dari Ibu Hikmah dulu karena ini lebih singkat. Jadi untuk pembacaan sampel cair itu sangat bisa Bu. Jadi sampel yang bisa dianalisa untuk elementar ini sampel padat, powder, dan cair itu bisa langsung dianalisa. Nanti untuk sampel cair bisa langsung dimasukkan ke dalam wadah. Jika membutuhkan alat yang lebih khusus, misalnya lebih spesifik ya untuk sampel cair, kami juga menyediakan aksesoris khusus. Namun jika tidak menggunakan aksesoris, sebetulnya dengan tin foil atau crucible pun juga langsung bisa dilakukan untuk pengujian sampel cair tersebut. Selanjutnya untuk Ibu Ervika, Oke, ini pertanyaan yang cukup sering ditanyakan karena metode yang umum di Indonesia itu adalah metode KELDAL ya Bu ya. Jadi untuk jika ditanyakan apakah bisa dibandingkan, jawabannya bisa. Namun kita tidak bisa memastikan nilainya betul-betul sama, itu tidak bisa karena ini adalah metode yang berbeda. Selain itu dengan metode pembakaran sampel yang dilakukan itu benar-benar secara keseluruhan. Jadi kita bisa memastikan bahwa nitrogen yang kita analisa adalah nitrogen secara total di dalam sampel. Nah, kalau kita melihat KELDAL, KELDAL ini kan sebenarnya ada proses destruksi, kemudian ada lagi proses evaporasi, baru titrasi. Nah, ini sebenarnya banyak step. Nah, biasanya kekurangan dari KELDAL ini ada beberapa nitrogen yang mungkin tercecer ya, jadi tidak total gitu untuk hasilnya. Jadi kalau kita bandingkan hasil pengukuran KELDAL dan DUMAS, biasanya hasil pengukuran DUMAS itu akan sedikit lebih besar karena tadi untuk metode pembakaran sampel itu akan dibakar secara keseluruhan karena kita akan mengubah si nitrogen di sampel menjadi gas N2. Gas N2 tersebut akan dibaca oleh detektor. Nah, detektor ini yang akan mengkonversinya menjadi data yang akan dikalkulasi di software. Depends on formula yang kita input seperti itu. Baru kita mendapatkan hasilnya. Kurang lebih seperti itu.
Baik, Sama, terima kasih banyak untuk jawabannya, sangat luar biasa. Ini sebenarnya kita ada beberapa pertanyaan lagi, tapi berhubung kita punya kuis, jadi mungkin satu pertanyaan terakhir. Jadi mungkin saya bisa simpulkan atau kumpulkan jadi satu untuk yang nitrogen analyzer ini. Apakah sampel viskositas berpengaruh? Terus kemudian unsur lain selain nitrogen, apakah tidak mengganggu hasil analisa? Terus kemudian untuk terakhir sistem pembakarannya, apakah tidak menggunakan bahan kimia sama sekali?
Oke. Yang pertama viskositas. Jadi viskositas itu tidak berpengaruh ya Bu ya, karena sistem utuh itu tidak ada ketentuan khusus. Sampel dalam bentuk utuh akan langsung dibakar, kemudian langsung dianalisa seperti itu. Paling yang membedakan antara satu sampel dengan sampel yang lain adalah matriksnya. Kalau memang kadar nitrogennya terlalu kecil dan matriksnya terlalu besar, mungkin kita akan sedikit perlu menambahkan bobot sampel supaya kadar nitrogennya terbaca. Seperti itu. Kemudian yang kedua tadi unsur lain. Oh ya, unsur lain. Jadi khusus untuk alat rapid max and exit atau rapid and exit ini memang dikhususkan untuk menganalisa kadar nitrogen. Jadi apabila ada unsur-unsur lain di dalam alat ini sebetulnya ada teknologi yang namanya purge and trap. Jadi dia adalah apa ya namanya seperti kolom. Dia akan memblok unsur-unsur yang lain selain nitrogen, sehingga hanya nitrogen saja yang diubah menjadi gas dan dibaca oleh detektor. Sebetulnya kami juga memiliki beberapa model lain untuk analisa unsur lainnya seperti karbon, hidrogen, atau dalam satu alat bisa digunakan untuk analisa karbon, hidrogen, dan nitrogen dalam waktu yang bersamaan, itu juga ada. Nah, itu balik lagi dari teknologi yang purge and trap tadi, ada kolom yang digunakan untuk memblok setiap unsur yang tidak diinginkan, seperti itu. Kemudian yang terakhir tadi, bahan kimia. Iya, jadi untuk bahan kimia sebetulnya kalau untuk kadar nitrogen tidak ada ya Bu ya. Jadi memang sampel langsung dimasukkan ke dalam wadah tadi, tin foil atau crucible. Namun jika ibu memang memiliki prosedur khusus yang harus dilakukan seperti penambahan bahan kimia tertentu atau lainnya, itu bisa ditambahkan. Namun mayoritas sih untuk pengukuran kadar nitrogen itu tidak ada chemical tambahan atau bahan kimia tambahan. Sampel dapat langsung dibakar.
Baik, terima kasih untuk jawabannya, Miss Amanah. Mungkin terakhir ini ada satu pertanyaan mengenai Elisa dari Ibu Indra Stuti. Berhubung waktu kita sudah habis, jadi mungkin saya bisa bantu untuk jawab singkat. Jadi untuk cek strain virus atau cendawan bisa Bu, nanti tergantung dengan reagen yang dipakai. Jadi reagen ELISA kit atau yang untuk mendeteksinya itu disesuaikan dengan virus atau spesies virus atau fungi yang ingin diuji. Terus kemudian perlu memasukkan standar tertentu, iya betul perlu, karena untuk uji misalnya kadar, mikotoksin, dan sebagainya itu menggunakan daerah standar yang sudah diketahui konsentrasinya. Mungkin seperti itu. Jadi semua sudah terjawab, jadi kita akan langsung mulai ke kuis. Jadi mungkin ini yang ditunggu-tunggu, mungkin kita akan running kuis selama 30 detik ke depan. Jadi siap-siap Bapak Ibu, mungkin boleh dibantu untuk share. Jadi untuk kuis kali ini Bapak Ibu hanya perlu menjawab dengan cepat dan tepat di kolom chat. Jadi nanti tim kami akan melihat siapa jawaban Bapak Ibu bisa menjawab dengan cepat dan tepat. Nanti kami akan tentukan pemenangnya saat ini juga. Terus kemudian nanti Bapak Ibu bisa hubungi kami untuk mengklaim hadiah. Baik, Bapak Ibu sudah siap semuanya? Kalau sudah siap, saya akan mulai dari pertanyaan pertama. Oke, berikut ini adalah rotor mill terbaru dari brand Reds, yaitu A, GM 300, B, SR 300, C, ZM 300, dan Delta SR 100. Wah, oke, jawabnya sudah banyak nih jawaban yang sudah masuk. Oke, kita langsung saja lock. Sudah ada yang menjawab dengan benar, yaitu Bapak Diki Pamungkas. Selamat Bapak Diki Pamungkas. Oke, baik. Mungkin langsung ke kuis nomor 2. Jadi akan dibawa oleh Miss Amanah.
Oke, baik Bapak Ibu, untuk pertanyaan yang kedua, sehalus apakah rotor mill SR300 dalam menghaluskan biji-bijian atau sereal? Nah, ini bisa dilihat gambarnya ya Bapak Ibu, jadi kalau tadi menyimak presentasi saya mungkin bisa menjawab ini gambar yang mana dari sampel biji-bijian atau sereal. Ayo Bapak Ibu.
Oke, baik. Untuk pertanyaan kuis nomor 2, kita sudah lock jawabannya. Jadi jawabannya adalah A. Yang pertama kami lihat menjawab benar adalah Ibu Penny Wahyu Prihandini. Selamat Ibu Penny. Nanti kami akan hubungi Ibu ya. Terima kasih.
Iya, Pak.
Oke, pertanyaan berikutnya. Kuis nomor 3. Salah satu instrumen yang dapat digunakan untuk menentukan kadar nitrogen pada sampel biji-bijian adalah A. Thermoscientific nanodrop, B. Elementar rapid max and exit, C. Memert universal oven, D. Carbolite Gero ashing furnace. Yang mana nih? Oke, kita cek satu-satu jawabannya. Oke, wah ini sudah ada jawabannya. Ibu Susi dari PRAI BRIN. Selamat Ibu Susi.
Terima kasih.
Oke, baik. Selanjutnya kita lanjut ke kuis nomor 4.
Oke, selanjutnya pertanyaan nomor 4 ya Bapak Ibu. Pada tahun 2021, ICFAS Group memiliki kantor baru yang berlokasi di New Zealand, B. Kamboja, C. Thailand, D. Filipina. Wah ini mudah sekali nih Bu.
Dan sudah ada yang sudah menjawab, yaitu Bapak Bapak Matias
Makasih.
Pratama.
Ya, makasih.
Selamat ya Pak Matias. Oh,
Makasih.
Bapaknya online. Halo Pak.
Halo.
Nanti bisa diklaim ke kami ya Pak, ke ITS Sains Indonesia, bukan ke panitia ICFAS ya. Ini khusus dari sponsor dari kami. Oke, baik. Selanjutnya ini adalah kuis terakhir, jadi Bapak Ibu siap-siap.
Oke. Yang terakhir, instrumen berikut dapat digunakan untuk mendukung pengujian mikotoksin berbasis ELISA pada pakan atau biji-bijian, kecuali. Nah, yang mana nih? Kecuali ya Bapak Ibu ya, pilihan A, B, C, atau D.
Kecuali ya, ini Bapak Ibu ya, kecuali. Kita cek jawabannya Bapak Ibu. Wah ini banyak sekali yang jawab ya, jadi sebentar kita akan cek. Oke. Yang kecuali ya Bapak Ibu ya, kecuali. Jadi kita akan cari yang menjawab. Ini dia, kita sudah dapat. Ini Bapak atau Ibu ya? Yang pertama kali menjawab, jadi jawaban untuk kuis nomor 5 ini adalah C, Carbonate Zero Ashing Furnace. Jadi ini tidak dipakai untuk pengujian ELISA. Jadi yang pertama kali menjawab adalah Bapak atau Ibu Windu Negara. Oh, Ibu selamat Ibu.
Terima kasih.
Bapak, Pak.
Oh, Bapak.
Oh, Bapak. Ya, maaf.
Oh, Pak Windu Negara. Pak Windu Negara, karena Bapak yang menang terakhir nih, boleh nggak sekalian saya request untuk sebutin nih, kalau yang A ini alat apa, B alat apa, C alat apa, D alat apa. Kok Bapak bisa jawab yang C bener nih?
Karena kalau C ini saya biasa gunakan untuk bahan organik dibakar, sehingga kalau pakai tanur ini pasti hangus dan mikotoksin pasti hilang semua.
Oke, wah benar sekali Pak Windu, terima kasih sudah menjawab pertanyaannya.
Mantap Pak Windu.
Oh ya, mantap Pak Windu. Jadi ini sambil makan siang sambil bisa menjawab ya, masih bisa mikir ternyata.
Iya, bonus tumbler dong.
Iya, boleh Pak.
Bisa, boleh request, boleh tumbler, boleh banget. Nah, baik, karena kita sudah sharing materi juga dan kita juga udah sharing kuis dan hadiah untuk 5 pemenang. Jadi nanti kami akan hubungi Bapak dan Ibu yang sudah menang. Terima kasih untuk partisipasinya. Mungkin terakhir, burung irian dan burung cendrawasih terbang lepas ke udara mencari jati diri. Sekian dan terima kasih. Sampai kita berjumpa lagi. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih Bapak Ibu semuanya. Assalamualaikum.
Hadiahnya lewat
Selamat
mana
siang.
nanti, Mbak?
Gimana, Bu?
Hadiahnya ngechat kemana?
Oh,
nanti kita yang hubungi ya, Bu ya.
Nanti kita personal chat, Bu.
Oh. Thank you.
Terima kasih, Ibu.
Sama-sama.
Mungkin saya kembalikan ke panitia. Terima kasih.
Okay, thank you very much, Ibu Warda Marisa, and congratulations for the winner. Ladies and gentlemen, next we will continue to the parallel session. For those who join the parallel session, please be noted that the parallel session 1 will have 17 rooms. 8 presenters per room, and each presenter has 15 minutes for 10 minutes for the presentation and 5 minutes for the discussion. You may enter the room as informed in the program book by clicking the icon on your screen, and please make sure that you enter the right room for you before you leave the main room, and don't be hesitant to ask us if you have any question. Ladies and gentlemen, after the parallel session, we have completed all the session in our conference for today. We hope that it is a fruitful event and we gain more information, knowledge for more innovation and collaboration in the future. Let us remind you that tomorrow the conference will start at 7:30 o'clock, and the agenda are plenary session 3 and 4, parallel session 3, and of course the announcement for the best presenter, best paper, and the best participant and closing ceremony. So please join us again in the main room tomorrow with the same Zoom link as today, and you can also check the details in the program book. Thank you. On behalf of the organizing committee, we would like to apologize for any inconvenience during this conference on first day. Thank you very much for your participation until we meet again tomorrow. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Stay safe and healthy.
Excellencies, ladies and gentlemen. Next, we will continue to the parallel session, and maybe you can join the parallel session based on the field of study by clicking the breakout room button below and choose your destination of the breakout room. And do not hesitate to reach us for any questions if you still can find the breakout room. Actually, the breakout room button is located below. And for these who joined the parallel session, please be noted that the parallel session 1 will have 17 rooms, 8 presenters per room, and each presenter has 15 minutes with 10 minutes for the presentation and 5 minutes for the discussion. And you may enter the room as informed in the program book by clicking on the icon on your screen.
Sembilan delapan lima.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology Indonesia. Through the 3 directions, science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Indonesia, terdapat 14,3 juta hektar lahan perkebunan kelapa sawit. Selama ini, lahan perkebunan tersebut hanya dimanfaatkan untuk pertanaman monokrop. Padahal, produktivitas dan efisiensi lahan dapat ditingkatkan dengan diversifikasi, salah satunya dengan mengintegrasikan perkebunan sawit dengan pembiakan sapi. Lahan perkebunan yang sangat luas berpotensi sebagai sumber pakan hijauan murah untuk penggembalaan sapi. Dari sisi demand, Indonesia sangat membutuhkan pasokan anak sapi atau sapi bakalan untuk digemukkan. Pemerintah tengah menggalakkan pembiakan sapi di dalam negeri untuk mengurangi beban impor. Beberapa perusahaan telah menerapkan integrasi perkebunan sawit dengan pembiakan sapi ini. Misalnya PT Buana Karya Bakti di Kalimantan Selatan dan PT Kalteng Andini Palmal Sari di Kalimantan Tengah. Usaha yang mereka lakukan dinamakan Sistem Integrasi Sapi Kelapa Sawit, disingkat SISKA.
Manajemen kebun ternyata bisa mengintegrasikan sawit dengan sapi yang kemudian bisa menghasilkan beberapa hal yang kami anggap itu adalah sesuatu yang baik. Suatu saat ini akan bisa menjadi bisnis alternatif sebagai diversifikasi.
Di lahan kelapa sawit tumbuh berbagai macam rumput yang merupakan gulma untuk perkebunan sawit. Namun, sebagian merupakan rumput yang bisa dimanfaatkan sebagai pakan sapi. Sapi digembalakan di bawah sawit, dan mereka bisa merumput dengan bebas. Dalam model SISKA, kebun sawit dibagi dalam beberapa blok penggembalaan. Kelompok-kelompok sapi dibiarkan menggembala dan makan di sebuah blok dan pindah ke blok lainnya keesokan harinya. Perputaran ini disebut sebagai rotasi grazing dan akan berjalan selama 3 bulan. Bagi perkebunan, sapi berperan sebagai biological mower yang membersihkan gulma dan mengurangi biaya pembersihan. Perkebunan pun berkurang ketergantungannya terhadap penggunaan herbisida dan bahan kimia lainnya.
Kita dari kebun dituntut untuk bisa efisien mengenai biaya perawatan. Nah, setelah adanya sapi, sekarang kita sangat terbantu, Pak. Pertama, untuk perawatan kita hanya selektif nih. Jadi, untuk gulma-gulma yang terbilang daun lunak, ini tidak kita kendalikan karena nanti bakal jadi makanan sapi. Kita hanya mengendalikan yang sifatnya berbatang keras seperti anakan kayu.
Ini adalah satu bisnis yang sangat efisien. Karena apa? Karena biaya untuk usaha peternakan itu adalah biaya pakan. Nah, ketika pakan itu bisa didapat dari sumber pakan alami yang ada di kebun sawit, yang pasti biayanya akan lebih murah.
Membiarkan sapi di perkebunan sawit tentu bukan hal mudah. Pengelolaan ternak dan perkebunan harus selaras, mengakomodasikan kebutuhan ternak sapi maupun pekerjaan di kebun, dan agar keduanya harmonis. Selain itu, ternak membutuhkan perhatian 24 jam per hari.
Sustainable food production for our growing world population requires modern breeding strategies and effective quality control procedures for agriculture and aquaculture. This can be achieved through the production of high-quality seeds and improved yield in plant and seafood farming. An important tool for breeding is the determination of ploidy levels. The ploidy level of an organism is characterized by the number of chromosomes pairs. This is specific to each species. Deviations from regular ploidy levels can have positive or negative effects on the individual. An increased number of chromosome sets, called polyploidy, can produce faster growing and bigger plants or seafood, or create plants with an increased production of secondary metabolites like essential oils. To get plants with seedless fruits, plant breeders produce triploid, sterile individuals. Checking the ploidy levels of such plants guarantees that only seedless fruits are formed. Negative effects can be induced by aneuploidy, characterized by an abnormal number of chromosomes. Aneuploid plants are often stunted. This makes checking for aneuploidy important in quality control of seed production. In all these instances, checking ploidy levels helps to improve yield, quality, and productivity. So farmers gain more benefits with the same amount of investment. For more than 35 years, Sysmex Partech has been the leading supplier of complete solutions for ploidy analysis, offering a broad range of dedicated reagents, instruments, and analyzing software, optimized for different sample material and organisms like rice, potatoes, sugarcane, corn, and oysters. Even challenging oxidized plant material becomes easy to handle with our solutions. Sysmex's unique complete solution for ploidy analysis with dedicated instruments, reagents, and analysis software like the automated ploidy detection tool support manual and automated high throughput measures and analysis in accordance with ISO and REACH guidelines. Start now and benefit from reliable, high-quality and cost-efficient solutions based on the Sysmex experience.
ITS Science Indonesia merupakan salah satu divisi bisnis dari ITS Group yang berkantor utama di Singapura. ITS Science Indonesia menawarkan berbagai macam instrumen analitik dan medis, peralatan laboratorium umum, bahan kimia, dan bahan habis pakai lainnya. Selama lebih dari 40 tahun, ITS Group bergerak maju dengan visi memberikan pengaruh di dalam industri yang kami jalani. Kultur perusahaan kami untuk selalu mengedepankan profesionalisme, partnership, dan performance. ITS Group tersebar di berbagai negara Asia Tenggara, yaitu Malaysia, Singapura, Thailand, Vietnam, Indonesia, Filipina, dan Kamboja. ITS Sains Indonesia memiliki 2 kantor yang berlokasi di Kelapa Gading, Jakarta Utara, dan Suku Manunggal, Surabaya. Berikut portfolio produk yang kami representasikan di Indonesia. Produk-produk yang kami representasikan merupakan produk-produk unggulan di bidangnya. Selain itu, kami juga bangga bekerja sama dengan berbagai pihak, mulai dari lembaga pemerintah, industri, hingga universitas. Bila Anda memerlukan bantuan untuk laboratorium Anda, hubungi kami. ITS Sains Indonesia, Bridging Science, Inspiring Possibilities.
Wakil Presiden Republik Indonesia tiba di tempat
agar fasilitas riset pangan BRIN ini pada akhirnya dapat mendukung pengembangan produk halal dan sehat khas Indonesia, terutama produk-produk yang berasal dari bahan lokal dan komoditas pangan tradisional.
Riset dan inovasi lah yang mendasari pertumbuhan dunia usaha dan juga menciptakan lapangan kerja yang akan mendorong pertumbuhan ekonomi negara.
bagi kelompok tani kita bermanfaat sekali. Menggunakan biaya operasional, baik dari peternak yang biasanya mengembala itu menghabiskan dalam 2 hari itu 3 liter bensin. Manfaatnya itu satu, keduanya dari tingkat keamanan, dari tingkat pemeliharaan kita bisa terkontrol. Mudah-mudahan dengan adanya komunikasi dengan perusahaan kita bisa maju Pak di bidang ternak sapi ini.
Kalau ini kan dijaga baik.
Nama saya Sarif, asisten Abdeling Monorejo. Dengan adanya sapi di kebun itu, salah satunya adalah mengurangi biaya-biaya operasional yang ada di Abdeling. Kita ada koordinasi mengenai rotasi-rotasi grazing, kemudian kita berhubungan dengan rotasi-rotasi panen. Jadi itu yang sebagai patokan kami di Abdeling. Kami pegang ada semacam peta yang dibentuk, yang diolah rotasi dari blok ke blok. Kalau di sini untuk sementara rencananya semua blok Pak. Jadi 1052 hektar.
Semua orang berhak mendapat kesempatan yang lebih baik, dan kami percaya itu. Karenanya, sudah 30 tahun kami dedikasikan diri untuk berjalan denganmu, sahabat kami, para petani dari seluruh pelosok negeri. Sebuah mimpi besar, memang, tetapi kami yakin bisa dimulai dari langkah terkecil. Yang juga paling penting, seperti mengembangkan benih berkualitas hasil penelitian yang menjadi ciri khas kami. Jarak dan medan yang harus ditempuh bukan halangan bagi kami untuk terjun langsung ke lapangan. Kadang penuh keringat, kadang ditemani terik yang menyengat. Tak masalah, karena disinilah perjalanan kami bersamamu dimulai. Percobaan demi percobaan kami lakukan bersama untuk mencari mana varietas terbaik nantinya, yang kami rawat sepenuh hati dalam pengawasan terbaik, agar tiap benihnya mampu menyerap nutrisi bumi sepenuhnya, hingga mereka terus tumbuh sehat sampai hasil panen terlihat. Prosesnya memang panjang dan tak mudah, tetapi dengan inilah benih-benih terpilih sampai ke genggamanmu. Untuk kemudian dikemas menjadi produk cap panah merah yang akan membantu petani-petani selanjutnya. Kami sadar ada banyak hal yang masih harus dilakukan untuk maju bersamamu. Karenanya, pelatihan tercipta untuk kami, supaya bisa selalu siaga membantumu. Dan untukmu, kembangkan kemampuan bertani dengan bantuan ilmu serta teknologi terkini. Kami juga selalu siap menjawab setiap pertanyaanmu. Di setiap pendampingan yang kamu perlukan, kami ada untukmu. ketika kami melihatmu berhasil, mendapat kesempatan, serta mencapai apa yang kami mimpikan. Itulah pencapaian terbesar kami dalam menjadi sahabat yang paling baik bagimu. Terima kasih telah berjalan bersama kami selama 30 tahun ini. Mari terus menjadi sahabat dalam berpuluh tahun mendatang. ICFAS Indonesia, sahabat petani yang paling baik.
ITS Sains Indonesia merupakan salah satu divisi bisnis dari ITS Group yang berkantor utama di Singapura. ITS Sains Indonesia menawarkan berbagai macam instrumen analitik dan medis, peralatan laboratorium umum, bahan kimia, dan bahan habis pakai lainnya. Selama lebih dari 40 tahun, ITS Group bergerak maju dengan visi memberikan pengaruh di dalam industri yang kami jalani. Kultur perusahaan kami untuk selalu mengedepankan profesionalisme, partnership, dan performance. ITS Group tersebar di berbagai negara Asia Tenggara, yaitu Malaysia, Singapura, Thailand, Vietnam, Indonesia, Filipina, dan Kamboja. ITS Sains Indonesia memiliki 2 kantor yang berlokasi di Kelapa Gading, Jakarta Utara, dan Suku Manunggal, Surabaya. Berikut portfolio produk yang kami representasikan di Indonesia. Produk-produk yang kami representasikan merupakan produk-produk unggulan di bidangnya. Selain itu, kami juga bangga bekerja sama dengan berbagai pihak, mulai dari lembaga pemerintah, industri, hingga universitas. Bila Anda memerlukan bantuan untuk laboratorium Anda, hubungi kami. ITS Sains Indonesia, Bridging Science, Inspiring Possibilities.
Saya kira kedepannya sangat baik prospeknya di kedua sisi ya, baik dalam peningkatan harga itu sendiri maupun peningkatan produktivitas di ekonominya dengan daging nasional.
Dan kami harapkan bahwa SSP ini bisa mendampingi sampai dengan tahun 2026 atau bahkan seterusnya selama pengembangan Siska dilaksanakan di Provinsi Kalimantan Selatan.
mengucapkan Bismillahirrahmanirrahim. Fasilitas riset pangan di Pusat Riset Teknologi dan Proses Pangan, Badan Riset dan Inovasi Nasional sebagai laboratorium rujukan riset halal Indonesia, saya nyatakan diresmikan.
Adalah tulang punggung penyedia pangan dan lapangan kerja bagi ratusan juta penduduk Indonesia. Pertanian juga menjadi poros pemeliharaan lingkungan dan pemberdayaan masyarakat pedesaan, memberikan dukungan bagi industri-industri lain dalam meningkatkan perekonomian nasional. Namun, pertanian Indonesia menghadapi berbagai macam tantangan. Perubahan iklim, banjir, kekeringan, alih fungsi lahan pertanian, serangan organisme pengganggu tanaman, penggunaan teknologi 4.0 juga seiring dengan pertumbuhan penduduk dunia yang meningkat pesat, dunia termasuk Indonesia dihadapkan pada ancaman kekurangan pangan. Berbagai cara dilakukan untuk menghadapi tantangan tersebut. Salah satunya, adopsi teknologi pertanian berbasis produk rekayasa genetik dan inovasi pemulihan tanaman. Buah-buahan yang tidak mudah busuk, tahan infeksi tanaman virus, produk tanaman yang sehat dan bebas hama, penggunaan produk perlindungan tanaman yang memenuhi standar, serta penggunaan teknologi berkelanjutan pada pertanian. Bioteknologi tanaman dalam pertanian selalu memastikan para petani mendapatkan teknologi terbaik untuk kebutuhan pertanian berkelanjutan yang berkontribusi pada ketahanan pangan dengan mengedepankan kajian ilmiah untuk memastikan keamanan pangan, pakan, dan lingkungan. CropLife Indonesia merupakan bagian dari federasi global yang beranggotakan asosiasi regional dan nasional dari 91 negara. CropLife Indonesia merupakan asosiasi nirlaba yang mewakili kepentingan petani industri benih dan pestisida. CropLife Indonesia bertujuan mempromosikan pertanian berkelanjutan untuk kepentingan petani, konsumen, dan keberlanjutan lingkungan hidup. Sebagai organisasi yang mewakili kepentingan petani, konsumen, industri benih dan pestisida, CropLife Indonesia berkomitmen menjunjung tinggi kajian ilmiah dan mendukung pelaksanaan peraturan pemerintah demi terwujudnya penyediaan teknologi baru bagi pertanian. Berfokus pada penelitian, pengembangan, dan edukasi pertanian untuk menghasilkan manfaat maksimal pada penggunaan yang aman dan berkelanjutan pada produk pertanian. Memerangi dan memberantas produk pertanian palsu dan ilegal yang bersinergi dengan pemerintah dan aparat penegak hukum. Meningkatkan pengetahuan dan pemahaman publik pada industri, adopsi teknologi, dan mitigasi risiko pertanian untuk meningkatkan kualitas hasil pertanian. Produksi produk perlindungan tanaman yang aman dan berkualitas, serta penggunaan teknologi berkelanjutan pada pertanian. Divisi pada CropLife Indonesia berbagi peran demi kepentingan petani, industri benih, dan pestisida. Sebagai mitra bagi pemerintah dalam mendukung pelaksanaan peraturan dengan menjunjung tinggi kajian ilmiah yang bersifat objektif dan dapat dipertanggungjawabkan. Sebagai upaya untuk membimbing petani agar dapat menghasilkan manfaat maksimal dari produk perlindungan tanaman. Sebagai peran dalam penegakan hukum dan kampanye anti pemalsuan yang bersinergi dengan pemerintah. Sebagai upaya peningkatan efektivitas dan efisiensi dalam pengendalian resistensi pestisida. Demi terwujudnya pengetahuan dan pemahaman publik mengenai industri pestisida, mitigasi risiko, dan manfaatnya dalam membantu meningkatkan kualitas hasil pertanian. Sebagai upaya membantu petani memenuhi kebutuhan pertanian dengan bioteknologi tanaman terbaik dan berkelanjutan. CropLife Indonesia akan bersinergi dan menjadi salah satu kekuatan sumber daya pembangunan nasional dalam memajukan industri dan penyaluran produk benih dan bioteknologi perlindungan tanaman. Juga berkontribusi untuk meningkatkan ketersediaan pangan dan standar hidup petani kita, serta konsumen dalam semua aspek, baik ekonomi, sosial, dan lingkungan.
Breakroom dong panitia.
Adalah tulang punggung penyedia pangan dan lapangan kerja bagi ratusan juta penduduk Indonesia. Pertanian juga menjadi poros pemeliharaan lingkungan dan pemberdayaan masyarakat pedesaan, memberikan dukungan bagi industri-industri lain dalam meningkatkan perekonomian nasional. Namun, pertanian Indonesia menghadapi berbagai macam tantangan. Perubahan iklim, banjir, kekeringan, alih fungsi lahan pertanian, serangan organisme pengganggu tanaman, penggunaan teknologi 4.0 juga seiring dengan pertumbuhan penduduk dunia yang meningkat pesat, dunia termasuk Indonesia dihadapkan pada ancaman kekurangan pangan. Berbagai cara dilakukan untuk menghadapi tantangan tersebut. Salah satunya, adopsi teknologi pertanian berbasis produk rekayasa genetik dan inovasi pemulihan tanaman. Buah-buahan yang tidak mudah busuk, tahan infeksi tanaman virus, produk tanaman yang sehat dan bebas hama, penggunaan produk perlindungan tanaman yang memenuhi standar, serta penggunaan teknologi berkelanjutan pada pertanian. Bioteknologi tanaman dalam pertanian selalu memastikan para petani mendapatkan teknologi terbaik untuk kebutuhan pertanian berkelanjutan yang berkontribusi pada ketahanan pangan dengan mengedepankan kajian ilmiah untuk memastikan keamanan pangan, pakan, dan lingkungan. CropLife Indonesia merupakan bagian dari federasi global yang beranggotakan asosiasi regional dan nasional dari 91 negara. CropLife Indonesia merupakan asosiasi nirlaba yang mewakili kepentingan petani industri benih dan pestisida. CropLife Indonesia bertujuan mempromosikan pertanian berkelanjutan untuk kepentingan petani, konsumen, dan keberlanjutan lingkungan hidup. Sebagai organisasi yang mewakili kepentingan petani, konsumen, industri benih dan pestisida, CropLife Indonesia berkomitmen menjunjung tinggi kajian ilmiah dan mendukung pelaksanaan peraturan pemerintah demi terwujudnya penyediaan teknologi baru bagi pertanian. Berfokus pada penelitian, pengembangan, dan edukasi pertanian untuk menghasilkan manfaat maksimal pada penggunaan yang aman dan berkelanjutan pada produk pertanian. Memerangi dan memberantas produk pertanian palsu dan ilegal yang bersinergi dengan pemerintah dan aparat penegak hukum. Meningkatkan pengetahuan dan pemahaman publik pada industri, adopsi teknologi, dan mitigasi risiko pertanian untuk meningkatkan kualitas hasil pertanian. Produksi produk perlindungan tanaman yang aman dan berkualitas, serta penggunaan teknologi berkelanjutan pada pertanian. Divisi pada CropLife Indonesia berbagi peran demi kepentingan petani, industri benih, dan pestisida. Sebagai mitra bagi pemerintah dalam mendukung pelaksanaan peraturan dengan menjunjung tinggi kajian ilmiah yang bersifat objektif dan dapat dipertanggungjawabkan. Sebagai upaya untuk membimbing petani agar dapat menghasilkan manfaat maksimal dari produk perlindungan tanaman. Sebagai peran dalam penegakan hukum dan kampanye anti pemalsuan yang bersinergi dengan pemerintah. Sebagai upaya peningkatan efektivitas dan efisiensi dalam pengendalian resistensi pestisida. Demi terwujudnya pengetahuan dan pemahaman publik mengenai industri pestisida, mitigasi risiko, dan manfaatnya dalam membantu meningkatkan kualitas hasil pertanian. Sebagai upaya membantu petani memenuhi kebutuhan pertanian dengan bioteknologi tanaman terbaik dan berkelanjutan. CropLife Indonesia akan bersinergi dan menjadi salah satu kekuatan sumber daya pembangunan nasional dalam memajukan industri dan penyaluran produk benih dan bioteknologi perlindungan tanaman. Juga berkontribusi untuk meningkatkan ketersediaan pangan dan standar hidup petani kita, serta konsumen dalam semua aspek, baik ekonomi, sosial, dan lingkungan.
Banyak banget pengalaman baru dan ilmu baru yang saya dapat.
Tentunya pengalaman di sini sangat bermanfaat dan benar-benar berharga bagi saya.
Selama saya magang di Siska,
Tentunya saya belajar banyak hal, tidak hanya secara teori,
Tapi juga praktis secara langsung di lapang.
terutama mengenai integrasi sawit sapi dan juga manajemen perkebunan.
harapan saya bisa belajar lebih lanjut di
Australia. MBKM PT Siska, always be the best. Yes, yes, yes.
Yogyakarta, the city of education and culture, has its own stories and romances in every corner of the city. Each corner will bring us back to the memories that make us to always come back to the city of yearning. Yogyakarta has some traditional foods such as gudeg, mangut lele, lombok ijo, tempe bacem, and bronkos, which are findable in street food stall, lesehan, angkringan, home industry, and restaurant. But then, how can we fulfill our longing for these traditional foods when we are far away? Research and Development Division for Natural Materials Technology, Indonesian Institute of Sciences, has been developing packaging technology for ready-to-eat foods. Traditional foods are processed and packaged in cylindrical can, so it has longer period of shelf life and increased its value. The implementation of packaging technology developed consistently in the institution. The institution has been working along with partners to implement the packaging technology. They manage to process and package 42 kinds of traditional foods from all over Indonesia, such as mangut lele, lombok ijo, tempe bacem, tempe kari, bronkos. You haven't visited Yogyakarta if you haven't eaten gudeg. The cooking process of raw jackfruits using a stirred process was called ngudeg in Javanese. So, the traditional food produced was then called as gudeg by people of Yogyakarta. Gudeg is served with addition side dishes such as pindang egg, slices of chicken meat, krecek condiment, tolo beans, tofu, and tempe. This traditional food became an example of our canned traditional foods. Let us show you the process. First, cans are sterilized in autoclave. An autoclave used high-pressured, high-temperature steam as a sterilizing agent. Then in the filling step, gudeg are filled in cans. The next step then continued by exhausting and seaming process. After being tightly sealed, the cans go under another sterilization step using autoclave. This sterilization process is an essential step for the canned foods. After the sterilization process, canned food products are cooled down at room temperature and then quarantined for 2 weeks in sterile room for quality controlling. The cans are labeled and ready to be sold. The implementation of the technology is able to enhance the production capacity of canned foods and increase the sales turnover in Yogyakarta's traditional foods processing industries. Furthermore, these culinary industries are getting more knowledge on the hygiene, safety, and standardization of food processing technology. The packaging technology has received a certification of good manufacturing process or GMP from the Indonesian National Agency of Drug and Food Control. In addition, canned traditional foods have received positive responses from many people. Yogyakarta will always be the city that feels like home. However, it's always been nice to be back to Yogyakarta, the city of yearning with the greatly delicious traditional local food.
BRIN. Kedepannya akan dilakukan pengembangan metode autentikasi dan deteksi yang lebih cepat dan akurat berbasis DNA, metabolomik, proteomik, dan lipidomik.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology Indonesia. Through the 3 directions, science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Indonesia terdapat 14,3 juta hektar lahan perkebunan kelapa sawit. Selama ini lahan perkebunan tersebut hanya dimanfaatkan untuk pertanaman monokrop. Padahal produktivitas dan efisiensi lahan dapat ditingkatkan dengan diversifikasi, salah satunya dengan mengintegrasikan perkebunan sawit dengan pembiakan sapi. Lahan perkebunan yang sangat luas berpotensi sebagai sumber pakan hijauan murah untuk penggembalaan sapi. Dari sisi demand, Indonesia sangat membutuhkan pasokan anak sapi atau sapi bakalan untuk digemukkan. Pemerintah tengah menggalakkan pembiakan sapi di dalam negeri untuk mengurangi beban impor. Beberapa perusahaan menerapkan integrasi perkebunan sawit dengan pembiakan sapi ini. Misalnya PT Buana Karya Bakti di Kalimantan Selatan dan PT Kalteng Andini Palmal Sari di Kalimantan Tengah. Usaha yang mereka lakukan dinamakan Sistem Integrasi Sapi Kelapa Sawit, disingkat SISKA.
Manajemen kebun ternyata bisa mengintegrasikan sawit dengan sapi yang kemudian bisa menghasilkan beberapa hal yang kami anggap itu adalah sesuatu yang baik. Suatu saat ini akan bisa menjadi bisnis alternatif sebagai diversifikasi.
Di lahan kelapa sawit tumbuh berbagai macam rumput yang merupakan gulma untuk perkebunan sawit. Namun, sebagian merupakan rumput yang bisa dimanfaatkan sebagai pakan sapi. Sapi digembalakan di bawah sawit, dan mereka bisa merumput dengan bebas. Dalam model SISKA, kebun sawit dibagi dalam beberapa blok penggembalaan. Kelompok-kelompok sapi dibiarkan menggembala dan makan di sebuah blok dan pindah ke blok lainnya keesokan harinya. Perputaran ini disebut sebagai rotasi grazing dan akan berjalan selama 3 bulan. Bagi perkebunan, sapi berperan sebagai biological mower yang membersihkan gulma dan mengurangi biaya pembersihan. Perkebunan pun berkurang ketergantungannya terhadap penggunaan herbisida dan bahan kimia lainnya.
Kita dari kebun dituntut untuk bisa efisien mengenai biaya perawatan. Nah, setelah adanya sapi, sekarang kita sangat terbantu, Pak. Pertama, untuk perawatan kita hanya selektif nih. Jadi, untuk gulma-gulma yang terbilang daun lunak, ini tidak kita kendalikan karena nanti bakal jadi makanan sapi. Kita hanya mengendalikan yang sifatnya berbatang keras seperti anakan kayu.
Ini adalah satu bisnis yang sangat efisien. Karena apa? Karena biaya untuk usaha peternakan itu adalah biaya pakan. Nah, ketika pakan itu bisa didapat dari sumber pakan alami yang ada di kebun sawit, yang pasti biayanya akan lebih murah.
Membiarkan sapi di perkebunan sawit tentu bukan hal mudah. Pengelolaan ternak dan perkebunan harus selaras, mengakomodasikan kebutuhan ternak sapi maupun pekerjaan di kebun, dan agar keduanya harmonis. Selain itu, ternak membutuhkan perhatian 24 jam per hari.
ITS Sains Indonesia merupakan salah satu divisi bisnis dari ITS Group yang berkantor utama di Singapura. ITS Sains Indonesia menawarkan berbagai macam instrumen analitik dan medis, peralatan laboratorium umum, bahan kimia, dan bahan habis pakai lainnya. Selama lebih dari 40 tahun, ITS Group bergerak maju dengan visi memberikan pengaruh di dalam industri yang kami jalani. Kultur perusahaan kami untuk selalu mengedepankan profesionalisme, partnership, dan performance. ITS Group tersebar di berbagai negara Asia Tenggara, yaitu Malaysia, Singapura, Thailand, Vietnam, Indonesia, Filipina, dan Kamboja. ITS Sains Indonesia memiliki 2 kantor yang berlokasi di Kelapa Gading, Jakarta Utara, dan Sukomanunggal, Surabaya. Berikut portfolio produk yang kami representasikan di Indonesia. Produk-produk yang kami representasikan merupakan produk-produk unggulan di bidangnya. Selain itu, kami juga bangga bekerja sama dengan berbagai pihak, mulai dari lembaga pemerintah, industri, hingga universitas. Bila Anda memerlukan bantuan untuk laboratorium Anda, hubungi kami. ITS Sains Indonesia, Bridging Science, Inspiring Possibilities.
pangan BRIN ini pada akhirnya dapat mendukung pengembangan produk halal dan sehat khas Indonesia, terutama produk-produk yang berasal dari bahan lokal dan komoditas pangan tradisional.
Riset dan inovasilah yang mendasari pertumbuhan dunia usaha dan juga menciptakan lapangan kerja yang akan mendorong pertumbuhan ekonomi negara.
Kelompok tani Kapokran Tani Maju yang posisinya ada di Desa Wonorejo, Kecamatan Sabui, Kabupaten Kabupaten. Bagi kelompok tani kita bermanfaat sekali menggunakan biaya operasional, baik dari peternak yang biasanya mengembala itu menghabiskan dalam 2 hari itu 3 liter bensin. Manfaatnya itu satu, keduanya dari tingkat keamanan, dari tingkat pemeliharaan kita bisa terkontrol. Mudah-mudahan dengan adanya komunikasi dengan perusahaan kita bisa maju Pak di bidang ternak sapi ini.
Kalau ini kan bisa sapi baik.
Saya Sarif, asisten Abdeling Wonorejo. Dengan adanya sapi di kebun itu salah satunya adalah mengurangi biaya-biaya operasional yang ada di Abdeling. Kita ada koordinasi mengenai rotasi-rotasi grazing, kemudian kita berhubungan dengan rotasi-rotasi panen. Jadi itu yang sebagai patokan kami di Abdeling. Kami pegang ada semacam peta yang dibentuk, yang diolah rotasi dari blok ke blok. Kalau di sini untuk sementara rencananya semua blok, jadi 1052 hektar.
Semua orang berhak mendapat kesempatan yang lebih baik, dan kami percaya itu. Karenanya, sudah 30 tahun kami dedikasikan diri untuk berjalan denganmu, sahabat kami, para petani dari seluruh pelosok negeri. Sebuah mimpi besar, memang, tetapi kami yakin bisa dimulai dari langkah terkecil. Yang juga paling penting, seperti mengembangkan benih berkualitas hasil penelitian yang menjadi ciri khas kami. Jarak dan medan yang harus ditempuh bukan halangan bagi kami untuk terjun langsung ke lapangan. Kadang penuh keringat, kadang ditemani terik yang menyengat. Tak masalah, karena disinilah sehat sampai hasil panen terlihat. Prosesnya memang panjang dan tak mudah. Tetapi dengan inilah benih-benih terpilih sampai ke genggamanmu. Untuk kemudian dikemas menjadi produk cap panah merah yang akan membantu petani-petani selanjutnya. Kami sadar ada banyak hal yang masih harus dilakukan untuk maju bersamamu. Karenanya, pelatihan tercipta untuk kami supaya bisa selalu siaga membantumu. Dan untukmu, kembangkan kemampuan bertani dengan bantuan ilmu serta teknologi terkini. Kami juga selalu siap menjawab setiap pertanyaanmu di setiap pendampingan yang kamu perlukan. Kami ada untukmu. Dan ketika kami melihatmu berhasil mendapat kesempatan serta mencapai apa yang kamu mimpikan, itulah pencapaian terbesar kami dalam menjadi sahabat yang paling baik bagimu. Terima kasih telah berjalan bersama kami selama 30 tahun ini. Mari terus menjadi sahabat dalam berpuluh tahun mendatang. ICFAS Indonesia, sahabat petani yang paling baik.
ITS Sains Indonesia merupakan salah satu divisi bisnis dari ITS Group yang berkantor utama di Singapura. ITS Sains Indonesia menawarkan berbagai macam instrumen analitik dan medis, peralatan laboratorium umum, bahan kimia, dan bahan habis pakai lainnya. Selama lebih dari 40 tahun, ITS Group bergerak maju dengan visi memberikan pengaruh di dalam industri yang kami jalani. Kultur perusahaan kami untuk selalu mengedepankan profesionalisme, partnership, dan performance. ITS Group tersebar di berbagai negara Asia Tenggara, yaitu Malaysia, Singapura, Thailand, Vietnam, Indonesia, Filipina, dan Kamboja. ITS Sains Indonesia memiliki 2 kantor yang berlokasi di Kelapa Gading, Jakarta Utara, dan Sukomanunggal, Surabaya. Berikut portfolio produk yang kami representasikan di Indonesia. Produk-produk yang kami representasikan merupakan produk-produk unggulan di bidangnya. Selain itu, kami juga bangga bekerja sama dengan berbagai pihak, mulai dari lembaga pemerintah, industri, hingga universitas. Bila Anda memerlukan bantuan untuk laboratorium Anda, hubungi kami. ITS Sains Indonesia, Bridging Science, Inspiring Possibilities.
kira kedepannya sangat baik prospeknya di kedua sisi ya, baik dalam peningkatan harga itu sendiri maupun peningkatan produktivitas di minyak dan daging nasional.
Dan kami harapkan bahwa SSP ini bisa mendampingi sampai dengan tahun 2026 atau bahkan seterusnya selama pengembangan Siska dilaksanakan di Provinsi Kalimantan Selatan.
Mengucapkan Bismillahirrahmanirrahim, fasilitas riset pangan di Pusat Riset Teknologi dan Proses Pangan, Badan Riset dan Inovasi Nasional sebagai laboratorium rujukan riset halal Indonesia, saya nyatakan diresmikan.
adalah tulang punggung penyedia pangan dan lapangan kerja bagi ratusan juta penduduk Indonesia. Pertanian juga menjadi poros pemeliharaan lingkungan dan pemberdayaan masyarakat pedesaan, memberikan dukungan bagi industri-industri lain dalam meningkatkan perekonomian nasional. Namun, pertanian Indonesia menghadapi berbagai macam tantangan. Perubahan iklim, banjir, kekeringan, alih fungsi lahan pertanian, serangan organisme pengganggu tanaman, penggunaan teknologi 4.0 juga seiring dengan pertumbuhan penduduk dunia yang meningkat pesat, dunia termasuk Indonesia dihadapkan pada ancaman kekurangan pangan. Berbagai cara dilakukan untuk menghadapi tantangan tersebut. Salah satunya, adopsi teknologi pertanian berbasis produk rekayasa genetik dan inovasi pemulihan tanaman. Buah-buahan yang tidak mudah busuk, tahan infeksi tanaman virus, produk tanaman yang sehat dan bebas hama, penggunaan produk perlindungan tanaman yang memenuhi standar, serta penggunaan teknologi berkelanjutan pada pertanian. Bioteknologi tanaman dalam pertanian selalu memastikan para petani mendapatkan teknologi terbaik untuk kebutuhan pertanian berkelanjutan yang berkontribusi pada ketahanan pangan dengan mengedepankan kajian ilmiah untuk memastikan keamanan pangan, pakan, dan lingkungan. Indonesia merupakan bagian dari Federasi organisasi global yang beranggotakan asosiasi regional dan nasional dari 91 negara. CropLife Indonesia merupakan asosiasi nirlaba yang mewakili kepentingan petani industri benih dan pestisida. CropLife Indonesia bertujuan mempromosikan pertanian berkelanjutan untuk kepentingan petani, konsumen, dan keberlanjutan lingkungan hidup. Sebagai organisasi yang mewakili kepentingan petani, konsumen, industri benih dan pestisida, CropLife Indonesia berkomitmen menjunjung tinggi kajian ilmiah dan mendukung pelaksanaan peraturan pemerintah demi terwujudnya penyediaan teknologi baru bagi pertanian. Berfokus pada penelitian, pengembangan, dan edukasi pertanian untuk menghasilkan manfaat maksimal pada penggunaan yang aman dan berkelanjutan pada produk pertanian. Memerangi dan memberantas produk pertanian palsu dan ilegal yang bersinergi dengan pemerintah dan aparat penegak hukum. Meningkatkan pengetahuan dan pemahaman publik pada industri, adopsi teknologi, dan mitigasi risiko pertanian untuk meningkatkan kualitas hasil pertanian. Produksi produk perlindungan tanaman yang aman dan berkualitas, serta penggunaan teknologi berkelanjutan pada pertanian. Divisi pada CropLife Indonesia berbagi peran demi kepentingan petani, industri benih, dan pestisida. Sebagai mitra bagi pemerintah dalam mendukung pelaksanaan peraturan dengan menjunjung tinggi kajian ilmiah yang bersifat objektif dan dapat dipertanggungjawabkan. Sebagai upaya untuk membimbing petani agar dapat menghasilkan manfaat maksimal dari produk perlindungan tanaman. Sebagai peran dalam penegakan hukum dan kampanye anti pemalsuan yang bersinergi dengan pemerintah. Sebagai upaya peningkatan efektivitas dan efisiensi dalam pengendalian resistensi pestisida. Demi terwujudnya pengetahuan dan pemahaman publik mengenai industri pestisida, mitigasi risiko, dan manfaatnya dalam membantu meningkatkan kualitas hasil pertanian. Sebagai upaya membantu petani memenuhi kebutuhan pertanian dengan bioteknologi tanaman terbaik dan berkelanjutan. CropLife Indonesia akan bersinergi dan menjadi salah satu kekuatan sumber daya pembangunan nasional dalam memajukan industri dan penyaluran produk benih dan bioteknologi perlindungan tanaman. Juga berkontribusi untuk meningkatkan ketersediaan pangan dan standar hidup petani kita, serta konsumen dalam semua aspek, baik ekonomi, sosial, dan lingkungan. adalah tulang punggung penyedia pangan dan lapangan kerja bagi ratusan juta penduduk Indonesia. Pertanian juga menjadi poros pemeliharaan lingkungan dan pemberdayaan masyarakat pedesaan, memberikan dukungan bagi industri-industri lain dalam meningkatkan perekonomian nasional. Namun, pertanian Indonesia menghadapi berbagai macam tantangan. Perubahan iklim, banjir, kekeringan, alih fungsi lahan pertanian, serangan organisme pengganggu tanaman, penggunaan Penggunaan teknologi 4.0 juga seiring dengan pertumbuhan penduduk dunia yang meningkat pesat, dunia termasuk Indonesia dihadapkan pada ancaman kekurangan pangan. Berbagai cara dilakukan untuk menghadapi tantangan tersebut. Salah satunya, adopsi teknologi pertanian berbasis produk rekayasa genetik dan inovasi pemulihan tanaman. Buah-buahan yang tidak mudah busuk, tahan infeksi tanaman virus, produk tanaman yang sehat dan bebas hama, penggunaan produk perlindungan tanaman yang memenuhi standar, serta penggunaan teknologi berkelanjutan pada pertanian. Bioteknologi tanaman dalam pertanian selalu memastikan para petani mendapatkan teknologi terbaik untuk kebutuhan pertanian berkelanjutan yang berkontribusi pada ketahanan pangan dengan mengedepankan kajian ilmiah untuk memastikan keamanan pangan, pakan, dan lingkungan. CropLife Indonesia merupakan bagian dari federasi global yang beranggotakan asosiasi regional dan nasional dari 91 negara. CropLife Indonesia merupakan asosiasi nirlaba yang mewakili kepentingan petani industri benih dan pestisida. CropLife Indonesia bertujuan mempromosikan pertanian berkelanjutan untuk kepentingan petani, konsumen, dan keberlanjutan lingkungan hidup. Sebagai organisasi yang mewakili kepentingan petani, konsumen, industri benih dan pestisida, CropLife Indonesia berkomitmen menjunjung tinggi kajian ilmiah dan mendukung pelaksanaan peraturan pemerintah demi terwujudnya penyediaan teknologi baru bagi pertanian. Berfokus pada penelitian, pengembangan, dan edukasi pertanian untuk menghasilkan manfaat maksimal pada penggunaan yang aman dan berkelanjutan pada produk pertanian. Memerangi dan memberantas produk pertanian palsu dan ilegal yang bersinergi dengan pemerintah dan aparat penegak hukum. Meningkatkan pengetahuan dan pemahaman publik pada industri, adopsi teknologi, dan mitigasi risiko pertanian untuk meningkatkan kualitas hasil pertanian. Produksi produk perlindungan tanaman yang aman dan berkualitas, serta penggunaan teknologi berkelanjutan pada pertanian. Divisi pada CropLife Indonesia berbagi peran demi kepentingan petani, industri benih, dan pestisida. Sebagai mitra bagi pemerintah dalam mendukung pelaksanaan peraturan dengan menjunjung tinggi kajian ilmiah yang bersifat objektif dan dapat dipertanggungjawabkan. Sebagai upaya untuk membimbing petani agar dapat menghasilkan manfaat maksimal dari produk perlindungan tanaman. Sebagai peran dalam penegakan hukum dan kampanye anti pemalsuan yang bersinergi dengan pemerintah. Sebagai upaya peningkatan efektivitas dan efisiensi dalam pengendalian resistensi pestisida. Demi terwujudnya pengetahuan dan pemahaman publik mengenai industri pestisida, mitigasi risiko, dan manfaatnya dalam membantu meningkatkan kualitas hasil pertanian. Sebagai upaya membantu petani memenuhi kebutuhan pertanian dengan bioteknologi tanaman terbaik dan berkelanjutan. CropLife Indonesia akan bersinergi dan menjadi salah satu kekuatan sumber daya pembangunan nasional dalam memajukan industri dan penyaluran produk benih dan bioteknologi perlindungan tanaman. Juga berkontribusi untuk meningkatkan ketersediaan pangan dan standar hidup petani kita, serta konsumen dalam semua aspek, baik ekonomi, sosial, dan lingkungan.
Banyak banget pengalaman baru dan ilmu baru yang saya dapat.
Tentunya pengalaman di sini sangat bermanfaat dan benar-benar berharga bagi saya.
Selama saya magang di Siska,
Tentunya saya belajar banyak hal, tidak hanya secara teori,
tapi juga praktis secara langsung di lapang.
terutama mengenai integrasi sawit sapi dan juga manajemen perkebunan.
harapan saya bisa belajar lebih lanjut di
Australia.
MBKM PT Siska.
Always be the best. Yes, yes, yes.
Yogyakarta, the city of education and culture, has its own stories and romances in every corner of the city. Each corner will bring us back to the memories that make us to always come back to the city of yearning. Yogyakarta has some traditional foods such as gudeg, mangut lele, lombok ijo, tempe bacem, and bronkos, which are findable in street food stall, lesehan, angkringan, home industry, and restaurant. But then, how can we fulfill our longing for these traditional foods when we are far away? Research and Development Division for Natural Materials Technology, Indonesian Institute of Sciences, has been developing packaging technology for ready-to-eat foods. Traditional foods are processed and packaged in cylindrical can, so it has longer period of shelf life and increased its value. The implementation of packaging technology developed consistently in the institution. The institution has been working along with partners to implement the packaging technology. They manage to process and package 42 kinds of traditional foods from all over Indonesia, such as mangut lele, lombok ijo, tempe bacem, tempe kari, bronkos. You haven't visited Yogyakarta if you haven't eaten gudeg. The cooking process of raw jackfruits using a stirred process was called ngudeg in Javanese. So, the traditional food produced was then called as gudeg by people of Yogyakarta. Gudeg is served with addition side dishes such as pindang egg, slices of chicken meat, krecek condiment, tolo beans, tofu, and tempe. This traditional food became an example of our canned traditional food. Let us show you the process. First, cans are sterilized in autoclave. An autoclave uses high-pressure, high-temperature steam as a sterilizing agent. Then, in the filling step, gudeg are filled in cans. The next step then continued by exhausting and seaming process. After being tightly sealed, the cans go under another sterilization step using autoclave. This sterilization process is an essential step for the canned foods. After the sterilization process, canned food products are cooled down at room temperature and then quarantined for 2 weeks in sterile room for quality controlling. The cans are labeled and ready to be sold. The implementation of the technology is able to enhance the production capacity of canned foods and increase the sales turnover in Yogyakarta's traditional foods processing industries. Furthermore, these culinary industries are getting more knowledge on the hygiene, safety, and standardization of food processing technology. The packaging technology has received a certification of good manufacturing process or GMP from the Indonesian National Agency of Drug and Food Control. In addition, canned traditional foods have received positive responses from many people. Yogyakarta will always be the city that feels like home. However, it's always been nice to be back to Yogyakarta, the city of yearning with a greatly delicious traditional local food.
metabolomik, proteomik, dan lipidomik.
Ya, kalau begitu berarti di sini kok bukan di
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology Indonesia. Through the 3 directions, science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Indonesia, terdapat 14,3 juta hektar lahan perkebunan kelapa sawit. Selama ini, lahan perkebunan tersebut hanya dimanfaatkan untuk pertanaman monokrap. Padahal, produktivitas dan efisiensi lahan dapat ditingkatkan dengan diversifikasi, salah satunya dengan mengintegrasikan perkebunan sawit dengan pembiakan sapi. Lahan perkebunan yang sangat luas berpotensi sebagai sumber pakan hijauan murah untuk penggembalaan sapi. Dari sisi demand, Indonesia sangat membutuhkan pasokan anak sapi atau sapi bakalan untuk digemukkan. Pemerintah tengah menggalakkan pembiakan sapi di dalam negeri untuk mengurangi beban impor. Beberapa perusahaan telah menerapkan integrasi perkebunan sawit dengan pembiakan sapi ini. Misalnya PT Buana Karya Bakti di Kalimantan Selatan dan PT Kalteng Andini Palmal Sari di Kalimantan Tengah. Usaha yang mereka lakukan dinamakan Sistem Integrasi Sapi Kelapa Sawit, disingkat SISKA.
Manajemen kebun ternyata bisa mengintegrasikan sawit dengan sapi yang kemudian bisa menghasilkan beberapa hal yang kami anggap itu adalah sesuatu yang baik. Suatu saat ini akan bisa menjadi bisnis alternatif sebagai diversifikasi.
Di lahan kelapa sawit tumbuh berbagai macam rumput yang merupakan gulma untuk perkebunan sawit. Namun, sebagian merupakan rumput yang bisa dimanfaatkan sebagai pakan sapi. Sapi digembalakan di bawah sawit, dan mereka bisa merumput dengan bebas. Dalam model SISKA, kebun sawit dibagi dalam beberapa blok penggembalaan. Kelompok-kelompok sapi dibiarkan menggembala dan makan di sebuah blok dan pindah ke blok lainnya keesokan harinya. Perputaran ini disebut sebagai rotasi grazing dan akan berjalan selama 3 bulan. Bagi perkebunan, sapi berperan sebagai biological mower yang membersihkan gulma dan mengurangi biaya pembersihan. Perkebunan pun berkurang ketergantungannya terhadap penggunaan herbisida dan bahan kimia lainnya.
Kita dari kebun dituntut untuk bisa efisien mengenai biaya perawatan. Nah, setelah adanya sapi, sekarang kita sangat terbantu, Pak. Pertama, untuk perawatan kita hanya selektif nih. Jadi, untuk gulma-gulma yang terbilang daun lunak, ini tidak kita kendalikan karena nanti bakal jadi makanan sapi. Kita hanya mengendalikan yang sifatnya berbatang keras seperti anakan kayu.
Ini adalah satu bisnis yang sangat efisien. Karena apa? Karena biaya untuk usaha peternakan itu adalah biaya pakan. Nah, ketika pakan itu bisa didapat dari sumber pakan alami yang ada di kebun sawit, yang pasti biayanya akan lebih murah.
Membiarkan sapi di perkebunan sawit tentu bukan hal mudah. Pengelolaan ternak dan perkebunan harus selaras, mengakomodasikan kebutuhan ternak sapi maupun pekerjaan di kebun, dan agar keduanya harmonis. Selain itu, ternak membutuhkan perhatian 24 jam per hari.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology Indonesia. Through the 3 directions, science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Indonesia, terdapat 14,3 juta hektar lahan perkebunan kelapa sawit. Selama ini, lahan perkebunan tersebut hanya dimanfaatkan untuk pertanaman monokrop. Padahal, produktivitas dan efisiensi lahan dapat ditingkatkan dengan diversifikasi, salah satunya dengan mengintegrasikan perkebunan sawit dengan pembiakan sapi. Lahan perkebunan yang sangat luas berpotensi sebagai sumber pakan hijauan murah untuk penggembalaan sapi. Dari sisi demand, Indonesia sangat membutuhkan pasokan anak sapi atau sapi bakalan untuk digemukkan. Pemerintah tengah menggalakkan pembiakan sapi di dalam negeri untuk mengurangi beban impor. Beberapa perusahaan telah menerapkan integrasi perkebunan sawit dengan pembiakan sapi ini. Misalnya PT Buana Karya Bakti di Kalimantan Selatan dan PT Kalteng Andini Palma Lestari di Kalimantan Tengah. Usaha yang mereka lakukan dinamakan sistem integrasi
ladies and gentlemen who still in the main room, please rename your name and then put the room number so the committee can assign you to the dedicated room. Thank you very much.
Improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology Indonesia. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Indonesia terdapat 14,3 juta hektar lahan perkebunan kelapa sawit. Selama ini lahan perkebunan tersebut hanya dimanfaatkan untuk pertanaman monokrop. Padahal produktivitas dan efisiensi lahan dapat ditingkatkan dengan diversifikasi, salah satunya dengan mengintegrasikan perkebunan sawit dengan pembiakan sapi. Lahan perkebunan yang sangat luas berpotensi sebagai sumber pakan hijauan murah untuk penggembalaan sapi. Dari sisi demand, Indonesia sangat membutuhkan pasokan anak sapi atau sapi bakalan untuk digemukkan. Pemerintah tengah menggalakkan pembiakan sapi di dalam negeri untuk mengurangi beban impor. Beberapa perusahaan telah menerapkan integrasi perkebunan sawit dengan pembiakan sapi ini. Misalnya PT Buana Karya Bakti di Kalimantan Selatan dan PT Kalteng Andini Palma Lestari di Kalimantan Tengah. Usaha yang mereka lakukan dinamakan Sistem Integrasi Sapi Kelapa Sawit, disingkat SISKA.
Manajemen kebun ternyata bisa mengintegrasikan sawit dengan sapi yang kemudian bisa menghasilkan beberapa hal yang kami anggap itu adalah sesuatu yang baik. Suatu saat ini akan bisa menjadi bisnis alternatif sebagai diversifikasi.
Di lahan kelapa sawit tumbuh berbagai macam rumput yang merupakan gulma untuk perkebunan sawit. Namun, sebagian merupakan rumput yang bisa dimanfaatkan sebagai pakan sapi. Sapi digembalakan di bawah sawit, dan mereka bisa merumput dengan bebas. Dalam model SISKA, kebun sawit dibagi dalam beberapa blok penggembalaan. Kelompok-kelompok sapi dibiarkan menggembala dan makan di sebuah blok dan pindah ke blok lainnya keesokan harinya. Perputaran ini disebut sebagai rotasi grazing dan akan berjalan selama 3 bulan. Bagi perkebunan, sapi berperan sebagai biological mower yang membersihkan gulma dan mengurangi biaya pembersihan. Perkebunan pun berkurang ketergantungannya terhadap penggunaan herbisida dan bahan kimia lainnya.
Kita dari kebun dituntut untuk bisa efisien mengenai biaya perawatan. Nah, setelah adanya sapi, sekarang kita sangat terbantu, Pak. Pertama, untuk perawatan kita hanya selektif nih. Jadi, untuk gulma-gulma yang terbilang daun lunak, ini tidak kita kendalikan karena nanti bakal jadi makanan sapi. Kita hanya mengendalikan yang sifatnya berbatang keras seperti anakan kayu.
Ini adalah satu bisnis yang sangat efisien. Karena apa? Karena biaya untuk usaha peternakan itu adalah biaya pakan. Nah, ketika pakan itu bisa didapat dari sumber pakan alami yang ada di kebun sawit, yang pasti biayanya akan lebih murah.
Membiarkan sapi di perkebunan sawit tentu bukan hal mudah. Pengelolaan ternak dan perkebunan harus selaras, mengakomodasikan kebutuhan ternak sapi maupun pekerjaan di kebun, dan agar keduanya harmonis. Selain itu, ternak membutuhkan perhatian 24 jam per hari.
Sustainable food production for our growing world population requires modern breeding strategies and effective quality control procedures for agriculture and aquaculture. This can be achieved through the production of high-quality seeds and improved yield in plant and seafood farming. An important tool for breeding is the determination of ploidy levels. The ploidy level of an organism is characterized by the number of chromosomes pairs. This is specific to each species. Deviations from regular ploidy levels can have positive or negative effects on the individual. An increased number of chromosome sets called polyploidy can produce faster growing and bigger plants or seafood, or create plants with an increased production of secondary metabolites like essential oils. To get plants with seedless fruits, plant breeders produce triploid, sterile individuals. Checking the ploidy levels of such plants guarantees that only seedless fruits are formed. Negative effects can be induced by aneuploidy, characterized by an abnormal number of chromosomes. Aneuploid plants are often stunted. This makes checking for aneuploidy important in quality control of seed production. In all these instances, checking ploidy levels helps to improve yield, quality, and productivity. So farmers gain more benefits with the same amount of investment. For more than 35 years, Sysmex Partech has been the leading supplier of complete solutions for ploidy analysis, offering a broad range of dedicated reagents, instruments, and analyzing software optimized for different sample material and organisms like rice, potatoes, sugarcane, corn, and oysters. Even challenging oxidized plant material becomes easy to handle with our solutions. Sysmex's unique complete solution for ploidy analysis with dedicated instruments, reagents, and analysis software like the automated ploidy detection tool support manual and automated high-throughput measures and analysis in accordance with ISO and REACH guidelines. Start now and benefit from reliable, high-quality and cost-efficient solutions based on the Sysmex experience.
ITS Sains Indonesia merupakan salah satu divisi bisnis dari ITS Group yang berkantor utama di Singapura. ITS Sains Indonesia menawarkan berbagai macam instrumen analitik dan medis, peralatan laboratorium umum, bahan kimia, dan bahan habis pakai lainnya. Selama lebih dari 40 tahun, ITS Group bergerak maju dengan visi memberikan pengaruh di dalam industri yang kami jalani. Kultur perusahaan kami untuk selalu mengedepankan profesionalisme, partnership, dan performance. ITS Group tersebar di berbagai negara Asia Tenggara, yaitu Malaysia, Singapura, Thailand, Vietnam, Indonesia, Filipina, dan Kamboja. ITS Sains Indonesia memiliki 2 kantor yang berlokasi di Kelapa Gading, Jakarta Utara, dan Sukomanunggal, Surabaya. Berikut portfolio produk yang kami representasikan di Indonesia. Produk-produk yang kami representasikan merupakan produk-produk unggulan di bidangnya. Selain itu, kami juga bangga bekerja sama dengan berbagai pihak, mulai dari lembaga pemerintah, industri, hingga universitas. Bila Anda memerlukan bantuan untuk laboratorium Anda, hubungi kami. ITS Sains Indonesia, Bridging Science, Inspiring Possibilities.
Wakil Presiden Republik Indonesia tiba di tempat
agar fasilitas riset pangan BRIN ini pada akhirnya dapat mendukung pengembangan produk halal dan sehat khas Indonesia, terutama produk-produk yang berasal dari bahan lokal dan komoditas pangan tradisional.
Riset dan inovasilah yang mendasari pertumbuhan dunia usaha dan juga menciptakan lapangan kerja yang akan mendorong pertumbuhan ekonomi negara.
kelompok tani Kapokran Tani Maju yang posisinya ada di Desa Wonorejo, Kecamatan Sapui, Kabupaten Kabupaten. Bagi kelompok tani kita bermanfaat sekali menggunakan biaya operasional, baik dari peternak yang biasanya mengembala itu menghabiskan dalam 2 hari itu 3 liter bensin. Manfaatnya itu satu, keduanya dari tingkat keamanan, dari tingkat pemeliharaan kita bisa terkontrol. Mudah-mudahan dengan adanya komunikasi dengan perusahaan kita bisa maju Pak di bidang ternak sapi ini.
Kalau ini kan menjaga baik-baik.
Nama saya Sarif, asisten Abdeling Wonorejo. Dengan adanya sapi di kebun itu Salah satunya adalah mengurangi biaya-biaya operasional yang ada di aplik. Kita ada koordinasi mengenai rotasi-rotasi grazing, kemudian kita berhubungan dengan rotasi-rotasi panen. Jadi itu yang sebagai patokan kami di updeling. Kami pegang ada semacam peta yang dibentuk, yang diolah rotasi dari blok ke blok. Kalau di sini untuk sementara rencananya semua blok, jadi 1052 hektar.
Semua orang berhak mendapat kesempatan yang lebih baik, dan kami percaya itu. Karenanya, sudah 30 tahun kami dedikasikan diri untuk berjalan denganmu, sahabat kami, para petani dari seluruh pelosok negeri. Sebuah mimpi besar, memang, tetapi kami yakin bisa dimulai dari langkah terkecil. Yang juga paling penting, seperti mengembangkan benih berkualitas hasil penelitian yang menjadi ciri khas kami. Jarak dan medan yang harus ditempuh bukan halangan bagi kami untuk terjun langsung ke lapangan. Kadang penuh keringat, kadang ditemani terik yang menyengat. Tak masalah, karena disinilah perjalanan kami bersamamu dimulai. Percobaan demi percobaan kami lakukan bersama untuk mencari mana varietas terbaik nantinya, yang kami rawat sepenuh hati dalam pengawasan terbaik, agar tiap benihnya mampu menyerap nutrisi bumi sepenuhnya, hingga mereka terus tumbuh sehat sampai hasil panen terlihat. Prosesnya memang panjang dan tak mudah, tetapi dengan inilah benih-benih terpilih sampai ke genggamanmu. Untuk kemudian dikemas menjadi produk cap panah merah yang akan membantu petani-petani selanjutnya. Kami sadar ada banyak hal yang masih harus dilakukan untuk maju bersamamu. Karenanya, pelatihan tercipta untuk kami, supaya bisa selalu siaga membantumu. Dan untukmu, kembangkan kemampuan bertani dengan bantuan ilmu serta teknologi terkini. Kami juga selalu siap menjawab setiap pertanyaanmu. Di setiap pendampingan yang kamu perlukan, kami ada untukmu. Dan ketika kami melihatmu berhasil mendapat kesempatan serta mencapai apa yang kamu mimpikan, itulah pencapaian terbesar kami dalam menjadi sahabat yang paling baik bagimu. Terima kasih telah berjalan bersama kami selama 30 tahun ini. Mari terus menjadi sahabat dalam berpuluh tahun mendatang. ICFAS Indonesia, sahabat petani yang paling baik.
ITS Sains Indonesia merupakan salah satu divisi bisnis dari ITS Group yang berkantor utama di Singapura. ITS Sains Indonesia menawarkan berbagai macam instrumen analitik dan medis, peralatan laboratorium umum, bahan kimia, dan bahan habis pakai lainnya. Selama lebih dari 40 tahun, ITS Group bergerak maju dengan visi memberikan pengaruh di dalam industri yang kami jalani. Kultur perusahaan kami untuk selalu mengedepankan profesionalisme, partnership, dan performance. ITS Group tersebar di berbagai negara Asia Tenggara, yaitu Malaysia, Singapura, Thailand, Vietnam, Indonesia, Filipina, dan Kamboja. ITS Sains Indonesia memiliki 2 kantor yang berlokasi di Kelapa Gading, Jakarta Utara, dan Suku Manunggal, Surabaya. Berikut portfolio produk yang kami representasikan di Indonesia. Produk-produk yang kami representasikan merupakan produk-produk unggulan di bidangnya. Selain itu, kami juga bangga bekerja sama dengan berbagai pihak, mulai dari lembaga pemerintah, industri, hingga universitas. Bila Anda memerlukan bantuan untuk laboratorium Anda, hubungi kami. ITS Sains Indonesia, Bridging Science, Inspiring Possibilities.
Saya kira kedepannya sangat baik prospeknya di kedua sisi ya, baik dalam peningkatan harga itu sendiri maupun peningkatan produktivitas di sapinya pengembangan daging nasional.
Dan kami harapkan bahwa SSP ini bisa mendampingi sampai dengan tahun 2026 atau bahkan seterusnya selama pengembangan Siska dilaksanakan di Provinsi Kalimantan Selatan.
Dengan mengucapkan Bismillahirrahmanirrahim, fasilitas riset pangan di Pusat Riset Teknologi dan Proses Pangan, Badan Riset dan Inovasi Nasional sebagai laboratorium rujukan riset halal Indonesia, saya nyatakan diresmikan.
adalah tulang punggung penyedia pangan dan lapangan kerja bagi ratusan juta penduduk Indonesia. Pertanian juga menjadi poros pemeliharaan lingkungan dan pemberdayaan masyarakat pedesaan, memberikan dukungan bagi industri-industri lain dalam meningkatkan perekonomian nasional. Namun, pertanian Indonesia menghadapi berbagai macam tantangan. Perubahan iklim, banjir, kekeringan, alih fungsi lahan pertanian, serangan organisme pengganggu tanaman, penggunaan teknologi 4.0 juga seiring dengan pertumbuhan penduduk dunia yang meningkat pesat, dunia termasuk Indonesia dihadapkan pada ancaman kekurangan pangan. Berbagai cara dilakukan untuk menghadapi tantangan tersebut. Salah satunya, adopsi teknologi pertanian berbasis produk rekayasa genetik dan inovasi pemulihan tanaman. Buah-buahan yang tidak mudah busuk, tahan infeksi tanaman virus, produk tanaman yang sehat dan bebas hama, penggunaan produk perlindungan tanaman yang memenuhi standar, serta penggunaan teknologi berkelanjutan pada pertanian. Bioteknologi tanaman dalam pertanian selalu memastikan para petani mendapatkan teknologi terbaik untuk kebutuhan pertanian berkelanjutan yang berkontribusi pada ketahanan pangan dengan mengedepankan kajian ilmiah untuk memastikan keamanan pangan, pakan, dan lingkungan. Indonesia merupakan bagian dari federasi global yang beranggotakan asosiasi regional dan nasional dari 91 negara. CropLife Indonesia merupakan asosiasi nirlaba yang mewakili kepentingan petani industri benih dan pestisida. CropLife Indonesia bertujuan mempromosikan pertanian berkelanjutan untuk kepentingan petani, konsumen, dan keberlanjutan lingkungan hidup. Sebagai organisasi yang mewakili kepentingan petani, konsumen, industri benih dan pestisida, CropLife Indonesia berkajian ilmiah dan mendukung pelaksanaan peraturan pemerintah demi terwujudnya penyediaan teknologi baru bagi pertanian. Berfokus pada penelitian, pengembangan, dan edukasi pertanian untuk menghasilkan manfaat maksimal pada penggunaan yang aman dan berkelanjutan pada produk pertanian. Memerangi dan memberantas produk pertanian palsu dan ilegal, yang bersinergi dengan pemerintah dan aparat penegak hukum. Meningkatkan pengetahuan dan pemahaman publik pada industri, adopsi teknologi, dan mitigasi risiko pertanian untuk meningkatkan kualitas hasil pertanian. Produksi produk perlindungan tanaman yang aman dan berkualitas, serta penggunaan teknologi berkelanjutan pada pertanian. Divisi pada CropLife Indonesia berbagi peran demi kepentingan petani, industri benih, dan pestisida. Sebagai mitra bagi pemerintah dalam mendukung pelaksanaan peraturan dengan menjunjung tinggi kajian ilmiah yang bersifat objektif dan dapat dipertanggungjawabkan. Sebagai upaya untuk membimbing petani agar dapat menghasilkan manfaat maksimal dari produk perlindungan tanaman. Sebagai peran dalam penegakan hukum dan kampanye anti pemalsuan yang bersinergi dengan pemerintah. Sebagai upaya peningkatan efektivitas dan efisiensi dalam pengendalian resistensi pestisida. Demi terwujudnya pengetahuan dan pemahaman publik mengenai industri pestisida, mitigasi risiko, dan manfaatnya dalam membantu meningkatkan kualitas hasil pertanian. Sebagai upaya membantu petani memenuhi kebutuhan pertanian dengan bioteknologi tanaman terbaik dan berkelanjutan. CropLife Indonesia akan bersinergi dan menjadi salah satu kekuatan sumber daya pembangunan nasional dalam memajukan industri dan penyaluran produk benih dan bioteknologi perlindungan tanaman. Juga berkontribusi untuk meningkatkan ketersediaan pangan dan standar hidup petani kita, serta konsumen dalam semua aspek, baik ekonomi, sosial, dan lingkungan. adalah tulang punggung penyedia pangan dan lapangan kerja bagi ratusan juta penduduk Indonesia. Pertanian juga menjadi poros pemeliharaan lingkungan dan pemberdayaan masyarakat pedesaan, memberikan dukungan bagi industri-industri lain dalam meningkatkan perekonomian nasional. Namun, pertanian Indonesia menghadapi berbagai macam tantangan. Perubahan iklim, banjir, kekeringan, alih fungsi lahan pertanian, serangan organisme pengganggu tanaman, penggunaan teknologi 4.0 juga seiring dengan pertumbuhan penduduk dunia yang meningkat pesat, dunia termasuk Indonesia dihadapkan pada ancaman kekurangan pangan. Berbagai cara dilakukan untuk menghadapi tantangan tersebut. Salah satunya, adopsi teknologi pertanian berbasis produk rekayasa genetik dan inovasi pemulihan tanaman. Buah-buahan yang tidak mudah busuk, tahan infeksi tanaman virus, produk tanaman yang sehat dan bebas hama, penggunaan produk perlindungan tanaman yang memenuhi standar, serta penggunaan teknologi berkelanjutan pada pertanian. Bioteknologi tanaman dalam pertanian selalu memastikan para petani mendapatkan teknologi terbaik untuk kebutuhan pertanian berkelanjutan yang berkontribusi pada ketahanan pangan dengan mengedepankan kajian ilmiah untuk memastikan keamanan pangan, pakan, dan lingkungan. Indonesia merupakan bagian dari federasi global yang beranggotakan asosiasi regional dan nasional dari 91 negara. CropLife Indonesia merupakan asosiasi nirlaba yang mewakili kepentingan petani industri benih dan pestisida. CropLife Indonesia bertujuan mempromosikan pertanian berkelanjutan untuk kepentingan petani, konsumen, dan keberlanjutan lingkungan hidup. Sebagai organisasi yang mewakili kepentingan petani, konsumen, industri benih dan pestisida, CropLife Indonesia berkomitmen menjunjung tinggi kajian ilmiah dan mendukung pelaksanaan peraturan pemerintah demi terwujudnya penyediaan teknologi baru bagi pertanian. Berfokus pada penelitian, pengembangan, dan edukasi pertanian untuk menghasilkan manfaat maksimal pada penggunaan yang aman dan berkelanjutan pada produk pertanian. Memerangi dan memberantas produk pertanian palsu dan ilegal, yang bersinergi dengan pemerintah dan aparat penegak hukum. Meningkatkan pengetahuan dan pemahaman publik pada industri, adopsi teknologi, dan mitigasi risiko pertanian untuk meningkatkan kualitas hasil pertanian. Produksi produk perlindungan tanaman yang aman dan berkualitas, serta penggunaan teknologi berkelanjutan pada pertanian. Divisi pada CropLife Indonesia berbagi peran demi kepentingan petani, industri benih, dan pestisida. Sebagai mitra bagi pemerintah dalam mendukung pelaksanaan peraturan dengan menjunjung tinggi kajian ilmiah yang bersifat objektif dan dapat dipertanggungjawabkan. Sebagai upaya untuk membimbing petani agar dapat menghasilkan manfaat maksimal dari produk perlindungan tanaman. Sebagai peran dalam penegakan hukum dan kampanye anti pemalsuan yang bersinergi dengan pemerintah. Sebagai upaya peningkatan efektivitas dan efisiensi dalam pengendalian resistensi pestisida. Demi terwujudnya pengetahuan dan pemahaman publik mengenai industri pestisida, mitigasi risiko, dan manfaatnya dalam membantu meningkatkan kualitas hasil pertanian. Sebagai upaya membantu petani memenuhi kebutuhan pertanian dengan bioteknologi tanaman terbaik dan berkelanjutan. CropLife Indonesia akan bersinergi dan menjadi salah satu kekuatan sumber daya pembangunan nasional dalam memajukan industri dan penyaluran produk benih dan bioteknologi perlindungan tanaman. Juga berkontribusi untuk meningkatkan ketersediaan pangan dan standar hidup petani kita, serta konsumen dalam semua aspek, baik ekonomi, sosial, dan lingkungan.
berharga bagi saya.
Selama saya magang di Siska,
Tentunya saya belajar banyak hal, tidak hanya secara teori,
tapi juga praktis secara langsung di lapang, terutama mengenai integrasi sawit sapi dan juga manajemen perkebunan.
harapan saya bisa belajar lebih lanjut di
Australia.
MBKM PT Siska,
Always be the best. Yes, yes, yes.
Yogyakarta, the city of education and culture, has its own stories and romances in every corner of the city. Each corner will bring us back to the memories that make us to always come back to the city of yearning. Yogyakarta has some traditional foods such as gudeg, mangut lele, lombok ijo, tempe bacem, and bronkos, which are findable in street food stall, lesehan, angkringan, home industry, and restaurant. But then, how can we fulfill our longing for these traditional foods when we are far away? Research and Development Division for Natural Materials Technology, Indonesian Institute of Sciences, has been developing packaging technology for ready-to-eat foods. Traditional foods are processed and packaged in cylindrical can, so it has longer period of shelf life and increased its value. The implementation of packaging technology developed consistently in the institution. The institution has been working along with partners to implement the packaging technology. They manage to process and package 42 kinds of traditional foods from all over Indonesia, such as mangut lele, lombok ijo, tempe bacem, tempe kari, bronkos. You haven't visited Yogyakarta if you haven't eaten gudeg. The cooking process of raw jackfruits using a stirred process was called ngudeg in Javanese. So, the traditional food produced was then called as gudeg by people of Yogyakarta. Gudeg is served with addition side dishes such as pindang egg, slices of chicken meat, krecek condiment, tolo beans, tofu, and tempe. This traditional food became an example of our canned traditional foods. Let us show you the process. First, cans are sterilized in autoclave. An autoclave used high-pressured, high-temperature steam as a sterilizing agent. Then in the filling step, gudeg are filled in cans. The next step then continued by exhausting and seaming process. After being tightly sealed, the cans go under another sterilization step using autoclave. This sterilization process is an essential step for the canned foods. After the sterilization process, canned food products are cooled down at room temperature and then quarantined for 2 weeks in sterile room for quality controlling. The cans are labeled and ready to be sold. The implementation of the technology is able to enhance the production capacity of canned foods and increase the sales turnover in Yogyakarta's traditional foods processing industries. Furthermore, these culinary industries are getting more knowledge on the hygiene, safety, and standardization of food processing technology. The packaging technology has received a certification of Good Manufacturing Process or GMP from the Indonesian National Agency of Drug and Food Control. In addition, canned traditional foods have received positive responses from many people. Yogyakarta will always be the city that feels like home. However, it's always been nice to be back to Yogyakarta, the city of yearning with a greatly delicious traditional local food.
autentikasi, dan deteksi kehalalan produk pangan dan turunannya yang telah dilakukan di PLTPP BRIN. Kedepannya akan dilakukan pengembangan metode autentikasi dan deteksi yang lebih cepat dan akurat berbasis DNA, metabolomik, proteomik, dan lipidomik.
Indonesia, terdapat 14,3 juta hektar lahan perkebunan kelapa sawit. Selama ini, lahan perkebunan tersebut hanya dimanfaatkan untuk pertanaman monokrop. Padahal, produktivitas dan efisiensi lahan dapat ditingkatkan dengan diversifikasi, salah satunya dengan mengintegrasikan perkebunan sawit dengan pembiakan sapi. Lahan perkebunan yang sangat luas berpotensi sebagai sumber pakan hijauan murah untuk penggembalaan sapi. Dari sisi demand, Indonesia sangat membutuhkan pasokan anak sapi atau sapi bakalan untuk digemukkan. Pemerintah tengah menggalakkan pembiakan sapi di dalam negeri untuk mengurangi beban impor. Beberapa perusahaan telah menerapkan integrasi perkebunan sawit dengan pembiakan sapi ini. Misalnya PT Buana Karya Bakti di Kalimantan Selatan dan PT Kalteng Andini Palma Lestari di Kalimantan Tengah. Usaha yang mereka lakukan dinamakan Sistem Integrasi Sapi Kelapa Sawit, disingkat SISKA.
Manajemen kebun ternyata bisa mengintegrasikan sawit dengan sapi yang kemudian bisa menghasilkan beberapa hal yang kami anggap itu adalah sesuatu yang baik. Suatu saat ini akan bisa menjadi bisnis alternatif sebagai diversifikasi.
Di lahan kelapa sawit tumbuh berbagai macam rumput yang merupakan gulma untuk perkebunan sawit. Namun, sebagian merupakan rumput yang bisa dimanfaatkan sebagai pakan sapi. Sapi digembalakan di bawah sawit, dan mereka bisa merumput dengan bebas. Dalam model SISKA, kebun sawit dibagi dalam beberapa blok penggembalaan. Kelompok-kelompok sapi dibiarkan menggembala dan makan di sebuah blok dan pindah ke blok lainnya keesokan harinya. Perputaran ini disebut sebagai rotasi grazing dan akan berjalan selama 3 bulan. Bagi perkebunan, sapi berperan sebagai biological mower yang membersihkan gulma dan mengurangi biaya pembersihan. Perkebunan pun berkurang ketergantungannya terhadap penggunaan herbisida dan bahan kimia lainnya.
Kita dari kebun dituntut untuk bisa efisien mengenai biaya perawatan. Nah, setelah adanya sapi, sekarang kita sangat terbantu, Pak. Pertama, untuk perawatan kita hanya selektif nih. Jadi, untuk gulma-gulma yang terbilang daun lunak, ini tidak kita kendalikan karena nanti bakal jadi makanan sapi. Kita hanya mengendalikan yang sifatnya berbatang keras seperti anakan kayu.
Ini adalah satu bisnis yang sangat efisien. Karena apa? Karena biaya untuk usaha peternakan itu adalah biaya pakan. Nah, ketika pakan itu bisa didapat dari sumber pakan alami yang ada di kebun sawit, yang pasti biayanya akan lebih murah.
Membiarkan sapi di perkebunan sawit tentu bukan hal mudah. Pengelolaan ternak dan perkebunan harus selaras, mengakomodasikan kebutuhan ternak sapi maupun pekerjaan di kebun, dan agar keduanya harmonis. Selain itu, ternak membutuhkan perhatian 24 jam per hari.
kelompok tani Kapokran Tani Maju yang posisinya ada di Desa Wonorejo, Kecamatan Serpui, Kabupaten Kabupaten. Bagi kelompok tani kita bermanfaat sekali menggunakan biaya operasional baik dari peternak yang biasanya mengembala itu menghabiskan dalam 2 hari itu 3 liter bensin. Manfaatnya itu satu, keduanya dari tingkat keamanan, dari tingkat pemeliharaan kita bisa terkontrol. Mudah-mudahan dengan adanya komunikasi dengan perusahaan kita bisa maju Pak di bidang ternak sapi ini.
Kalau ini kan dijaga baik-baik.
Saya Sarif, asisten Abdeling Wonorejo. Dengan adanya sapi di kebun itu Salah satunya adalah mengurangi biaya-biaya operasional yang ada di Apdelik. Kita ada koordinasi mengenai rotasi-rotasi grazing, kemudian kita berhubungan dengan rotasi-rotasi panen. Jadi itu yang sebagai patokan kami di Apdelik. Kami pegang ada semacam peta yang dibentuk, yang diolah rotasi dari blok ke blok. Kalau di sini untuk sementara rencananya semua blok, jadi 1052 hektar.
Adalah tulang punggung penyedia pangan dan lapangan kerja bagi ratusan juta penduduk Indonesia. Pertanian juga menjadi poros pemeliharaan lingkungan dan pemberdayaan masyarakat pedesaan, memberikan dukungan bagi industri-industri lain dalam meningkatkan perekonomian nasional. Namun, pertanian Indonesia menghadapi berbagai macam tantangan. Perubahan iklim, banjir, kekeringan, alih fungsi lahan pertanian, serangan organisme pengganggu tanaman, penggunaan teknologi 4.0 juga seiring dengan pertumbuhan penduduk dunia yang meningkat pesat, dunia termasuk Indonesia dihadapkan pada ancaman kekurangan pangan. Berbagai cara dilakukan untuk menghadapi tantangan tersebut. Salah satunya, adopsi teknologi pertanian berbasis produk rekayasa genetik dan inovasi pemulihan tanaman. Buah-buahan yang tidak mudah busuk, tahan infeksi tanaman virus, produk tanaman yang sehat dan bebas hama, penggunaan produk perlindungan tanaman yang memenuhi standar, serta penggunaan teknologi berkelanjutan pada pertanian. Bioteknologi tanaman dalam pertanian selalu memastikan para petani mendapatkan teknologi terbaik untuk kebutuhan pertanian berkelanjutan yang berkontribusi pada ketahanan pangan dengan mengedepankan kajian ilmiah untuk memastikan keamanan pangan, pakan, dan lingkungan. CropLife Indonesia merupakan bagian dari federasi global yang beranggotakan asosiasi regional dan nasional dari 91 negara. CropLife Indonesia merupakan asosiasi nirlaba yang mewakili kepentingan petani industri benih dan pestisida. CropLife Indonesia bertujuan mempromosikan pertanian berkelanjutan untuk kepentingan petani, konsumen, dan keberlanjutan lingkungan hidup. Sebagai organisasi yang mewakili kepentingan petani, konsumen, industri benih dan pestisida, CropLife Indonesia berkomitmen menjunjung tinggi kajian ilmiah dan mendukung pelaksanaan peraturan pemerintah demi terwujudnya penyediaan teknologi baru bagi pertanian. Berfokus pada penelitian, pengembangan, dan edukasi pertanian untuk menghasilkan manfaat maksimal pada penggunaan yang aman dan berkelanjutan pada produk pertanian. Memerangi dan memberantas produk pertanian palsu dan ilegal yang bersinergi dengan pemerintah dan aparat penegak hukum. Meningkatkan pengetahuan dan pemahaman publik pada industri, adopsi teknologi, dan mitigasi risiko pertanian untuk meningkatkan kualitas hasil pertanian. Produksi produk perlindungan tanaman yang aman dan berkualitas, serta penggunaan teknologi berkelanjutan pada pertanian. Divisi pada CropLife Indonesia berbagi peran demi kepentingan petani, industri benih, dan pestisida. Sebagai mitra bagi pemerintah dalam mendukung pelaksanaan peraturan dengan menjunjung tinggi kajian ilmiah yang bersifat objektif dan dapat dipertanggungjawabkan. sebagai upaya untuk membimbing petani agar dapat menghasilkan manfaat maksimal dari produk perlindungan tanaman. Sebagai peran dalam penegakan hukum dan kampanye anti pemalsuan yang bersinergi dengan pemerintah. Sebagai upaya peningkatan efektivitas dan efisiensi dalam pengendalian resistensi pestisida. Demi terwujudnya pengetahuan dan pemahaman publik mengenai industri pestisida, mitigasi risiko, dan manfaatnya dalam membantu meningkatkan kualitas hasil pertanian. Sebagai upaya membantu petani memenuhi kebutuhan pertanian dengan bioteknologi tanaman terbaik dan berkelanjutan. CropLife Indonesia akan bersinergi dan menjadi salah satu kekuatan sumber daya pembangunan nasional dalam memajukan industri dan penyaluran produk benih dan bioteknologi perlindungan tanaman. Juga berkontribusi untuk meningkatkan ketersediaan pangan dan standar hidup petani kita, serta konsumen dalam semua aspek, baik ekonomi, sosial, dan lingkungan.
Saya kira kedepannya sangat baik prospeknya di kedua sisi ya, baik dalam peningkatan sawit itu sendiri maupun peningkatan produktivitas di sapinya pengembangan daging nasional.
Dan kami harapkan bahwa SSP ini bisa mendampingi sampai dengan tahun 2026 atau bahkan seterusnya selama dilaksanakan di Provinsi Kalimantan Selatan.
Adalah tulang punggung penyedia pangan dan lapangan kerja bagi ratusan juta penduduk Indonesia. Pertanian juga menjadi poros pemeliharaan lingkungan dan pemberdayaan masyarakat pedesaan, memberikan dukungan bagi industri-industri lain dalam meningkatkan perekonomian nasional. Namun, pertanian Indonesia menghadapi berbagai macam tantangan. Perubahan iklim, banjir, kekeringan, alih fungsi lahan pertanian, serangan organisme pengganggu tanaman, penggunaan teknologi 4.0 juga seiring dengan pertumbuhan penduduk dunia yang meningkat pesat, dunia termasuk Indonesia dihadapkan pada ancaman kekurangan pangan. Berbagai cara dilakukan untuk menghadapi tantangan tersebut. Salah satunya, adopsi teknologi pertanian berbasis produk rekayasa genetik dan inovasi pemulihan tanaman. Buah-buahan yang tidak mudah busuk, tahan infeksi tanaman virus, produk tanaman yang sehat dan bebas hama, penggunaan produk perlindungan tanaman yang memenuhi standar, serta penggunaan teknologi berkelanjutan pada pertanian. Bioteknologi tanaman dalam pertanian selalu memastikan para petani mendapatkan teknologi terbaik untuk kebutuhan pertanian berkelanjutan yang berkontribusi pada ketahanan pangan dengan mengedepankan kajian ilmiah untuk memastikan keamanan pangan, pakan, dan lingkungan. CropLife Kroplife Indonesia merupakan bagian dari federasi global yang beranggotakan asosiasi regional dan nasional dari 91 negara. Kroplife Indonesia merupakan asosiasi nirlaba yang mewakili kepentingan petani industri benih dan pestisida. Kroplife Indonesia bertujuan mempromosikan pertanian berkelanjutan untuk kepentingan petani, konsumen, dan keberlanjutan lingkungan hidup. Sebagai organisasi yang mewakili kepentingan petani, konsumen, industri benih dan pestisida, Kroplife Indonesia berkomitmen menjunjung tinggi kajian ilmiah dan mendukung pelaksanaan peraturan pemerintah demi terwujudnya penyediaan teknologi baru bagi pertanian. Berfokus pada penelitian, pengembangan, dan edukasi pertanian untuk menghasilkan manfaat maksimal pada penggunaan yang aman dan berkelanjutan pada produk pertanian. Memerangi dan memberantas produk pertanian palsu dan ilegal yang bersinergi dengan pemerintah dan aparat penegak hukum. Meningkatkan pengetahuan dan pemahaman publik pada industri, adopsi teknologi, dan mitigasi risiko pertanian untuk meningkatkan kualitas hasil pertanian. Produksi produk perlindungan tanaman yang aman dan berkualitas, serta penggunaan teknologi berkelanjutan pada pertanian. Divisi pada Kroplife Indonesia berbagi peran demi kepentingan petani, industri benih, dan pestisida. Sebagai mitra bagi pemerintah dalam mendukung pelaksanaan peraturan dengan menjunjung tinggi kajian ilmiah yang bersifat objektif dan dapat dipertanggungjawabkan. Sebagai upaya untuk membimbing petani agar dapat menghasilkan manfaat maksimal dari produk perlindungan tanaman. Sebagai peran dalam penegakan hukum dan kampanye anti-korupsi yang bersinergi dengan pemerintah. Sebagai upaya peningkatan efektivitas dan efisiensi dalam pengendalian resistensi pestisida. Demi terwujudnya pengetahuan dan pemahaman publik mengenai industri pestisida, mitigasi risiko, dan manfaatnya dalam membantu meningkatkan kualitas hasil pertanian. Sebagai upaya membantu petani memenuhi kebutuhan pertanian dengan bioteknologi tanaman terbaik dan berkelanjutan. Kroplife Indonesia akan bersinergi dan menjadi salah satu kekuatan sumber daya pembangunan nasional dalam memajukan penyaluran produk benih dan bioteknologi perlindungan tanaman. Juga berkontribusi untuk meningkatkan kesediaan pangan dan
room 12 is finished.
serta konsumen dalam semua aspek, baik
So we
ekonomi,
can
sosial,
leave
dan
the meeting.
Yes.
Okay, thank you.
Yeah, thank
See
you,
you
sir.
tomorrow.
Yeah, see you tomorrow.
sini sangat bermanfaat dan benar-benar berharga bagi saya.
Selama saya magang di Siska,
Tentunya saya belajar banyak hal, tidak hanya secara teori,
tapi juga praktis secara langsung di lapang, terutama mengenai integrasi sawit sapi dan juga manajemen pasturan.
harapan saya bisa belajar lebih lanjut di
Australia.
MBKM PT Siska,
Always be the best. Yes, yes, yes.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology Indonesia. Through the 3 directions, science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and society.
Indonesia, terdapat 14,3 juta hektar lahan perkebunan kelapa sawit. Selama ini, lahan perkebunan tersebut hanya dimanfaatkan untuk pertanaman monokrop. Padahal, produktivitas dan efisiensi lahan dapat ditingkatkan dengan diversifikasi, salah satunya dengan mengintegrasikan perkebunan sawit dengan pembiakan sapi. Lahan perkebunan yang sangat luas berpotensi sebagai sumber pakan hijauan murah untuk penggembalaan sapi. Dari sisi demand, Indonesia sangat membutuhkan pasokan anak sapi atau sapi bakalan untuk digemukkan. Pemerintah tengah menggalakkan pembiakan sapi di dalam negeri untuk mengurangi beban impor. Beberapa perusahaan telah menerapkan integrasi perkebunan sawit dengan pembiakan sapi ini. Misalnya PT Buana Karya Bakti di Kalimantan Selatan dan PT Kaltang Andini Palma Lestari di Kalimantan Tengah. Usaha yang mereka lakukan dinamakan Sistem Integrasi Sapi Kelapa Sawit, disingkat Siska.
Manajemen kebun ternyata bisa mengintegrasikan sawit dengan sapi yang kemudian bisa menghasilkan beberapa hal yang kami anggap itu adalah sesuatu yang baik. Suatu saat ini akan bisa menjadi bisnis alternatif sebagai diversifikasi.
Di lahan kelapa sawit tumbuh berbagai macam rumput yang merupakan gulma untuk perkebunan sawit. Namun, sebagian merupakan rumput yang bisa dimanfaatkan sebagai pakan sapi. Sapi digembalakan di bawah sawit, dan mereka bisa merumput dengan bebas. Dalam model Siska, kebun sawit dibagi dalam beberapa blok penggembalaan. Kelompok-kelompok sapi dibiarkan menggembala dan makan di sebuah blok dan pindah ke blok lainnya keesokan harinya. Perputaran ini disebut sebagai rotasi grazing dan akan berjalan selama 3 bulan. Bagi perkebunan, sapi berperan sebagai biological mower yang membersihkan gulma dan mengurangi biaya pembersihan. Perkebunan pun berkurang ketergantungannya terhadap penggunaan herbisida dan bahan kimia lainnya.
Kita dari kebun dituntut untuk bisa efisien mengenai biaya perawatan. Nah, setelah adanya sapi, sekarang kita sangat terbantu, Pak. Pertama, untuk perawatan kita hanya selektif nih. Jadi, untuk gulma-gulma yang terbilang daun lunak, ini tidak kita kendalikan karena nanti bakal jadi makanan sapi. Kita hanya mengendalikan yang sifatnya berbatang keras seperti anakan kayu.
Ini adalah satu bisnis yang sangat efisien. Karena apa? Karena biaya untuk usaha peternakan itu adalah biaya pakan. Nah, ketika pakan itu bisa didapat dari sumber pakan alami yang ada di kebun sawit, yang pasti biayanya akan lebih murah.
Membiarkan sapi di perkebunan sawit tentu bukan hal mudah. Pengelolaan ternak dan perkebunan harus selaras, mengakomodasikan kebutuhan ternak sapi maupun pekerjaan di kebun, dan agar keduanya harmonis. Selain itu, ternak membutuhkan perhatian 24 jam per hari.
Sustainable food production for our growing world population requires modern breeding strategies and effective quality control procedures for agriculture and aquaculture. This can be achieved through the production of high-quality seeds and improved yield in plant and seafood farming. An important tool for breeding is the determination of ploidy levels. The ploidy level of an organism is characterized by the number of chromosomes pairs. This is specific to each species. Deviations from regular ploidy levels can have positive or negative effects on the individual. An increased number of chromosome sets, called polyploidy, can produce faster growing and bigger plants or seafood, or create plants with an increased production of secondary metabolites like essential oils. To get plants with seedless fruits, plant breeders produce triploid, sterile individuals. Checking the ploidy levels of such plants guarantees that only seedless fruits are formed. Negative effects can be induced by aneuploidy, characterized by an abnormal number of chromosomes. Aneuploid plants are often stunted. This makes checking for aneuploidy important in quality control of seed production. In all these instances, checking ploidy levels helps to improve yield, quality, and productivity. So farmers gain more benefits with the same amount of investment. For more than 35 years, Sysmex Partech has been the leading supplier of complete solutions for ploidy analysis, offering a broad range of dedicated reagents, instruments, and analyzing software optimized for different sample material and organisms like rice, potatoes, sugarcane, corn, and oysters. Even challenging oxidized plant material becomes easy to handle with our solutions. Sysmex's unique complete solution for ploidy analysis with dedicated instruments, reagents, and analysis software like the automated ploidy detection tool support manual and automated high-throughput measures and analysis in accordance with ISO and REACH guidelines. Start now and benefit from reliable, high-quality and cost-efficient solutions based on the Sysmex experience.
ITS Sains Indonesia merupakan salah satu divisi bisnis dari ITS Group yang berkantor utama di Singapura. ITS Sains Indonesia menawarkan berbagai macam instrumen analitik dan medis, peralatan laboratorium umum, bahan kimia, dan bahan habis pakai lainnya. Selama lebih dari 40 tahun, ITS Group bergerak maju dengan visi memberikan pengaruh di dalam industri yang kami jalani. Kultur perusahaan kami untuk selalu mengedepankan profesionalisme, partnership, dan performance. ITS Group tersebar di berbagai negara Asia Tenggara, yaitu Malaysia, Singapura, Thailand, Vietnam, Indonesia, Filipina, dan Kamboja. ITS Sains Indonesia memiliki 2 kantor yang berlokasi di Kelapa Gading, Jakarta Utara, dan Suku Manunggal, Surabaya. Berikut portfolio produk yang kami representasikan di Indonesia. Produk-produk yang kami representasikan merupakan produk-produk unggulan di bidangnya. Selain itu, kami juga bangga bekerja sama dengan berbagai pihak, mulai dari lembaga pemerintah, industri, hingga universitas. Bila Anda memerlukan bantuan untuk laboratorium Anda, hubungi kami. ITS Sains Indonesia, Bridging Science, Inspiring Possibilities.
Wakil Presiden Republik Indonesia tiba di tempat
agar fasilitas riset pangan BRIN ini pada akhirnya dapat mendukung pengembangan produk halal dan sehat khas Indonesia, terutama produk-produk yang berasal dari bahan lokal dan komoditas pangan tradisional.
Riset dan inovasilah yang mendasari pertumbuhan dunia usaha dan juga menciptakan lapangan kerja yang akan mendorong pertumbuhan ekonomi negara.
Tani Kapokran Kalimajo yang posisinya ada di Desa Wonorejo, Kecamatan Satui, Kabupaten Kalimantan. Bagi kelompok tani kita bermanfaat sekali menggunakan biaya operasional, baik dari peternak yang biasanya mengembala itu menghabiskan dalam 2 hari itu 3 liter bensin. Manfaatnya itu satu, keduanya dari tingkat keamanan, dari tingkat pemeliharaan kita bisa terkontrol. Mudah-mudahan dengan adanya komunikasi dengan perusahaan kita bisa maju Pak di bidang ternak sapi ini.
Kalau ini kan menjaga baik-baik.
Saya Sarif, asisten Abdeling Wonorejo. Dengan adanya sapi di kebun itu, salah satunya adalah mengurangi biaya-biaya operasional yang ada di Abdeling. Kita ada koordinasi mengenai rotasi-rotasi grazing, kemudian kita berhubungan dengan rotasi-rotasi panen. Jadi itu yang sebagai patokan kami di Abdeling. Kami pegang ada semacam peta yang dibentuk, yang diolah rotasi dari blok ke blok. Kalau di sini untuk sementara rencananya semua blok, Pak. Jadi 1052 hektar.
Semua orang berhak mendapat kesempatan yang lebih baik, dan kami percaya itu. Karenanya, sudah 30 tahun kami dedikasikan diri untuk berjalan denganmu, sahabat kami, para petani dari seluruh pelosok negeri. Sebuah mimpi besar, memang, tetapi kami yakin bisa dimulai dari langkah terkecil. Yang juga paling penting, seperti mengembangkan benih berkualitas hasil penelitian yang menjadi ciri khas kami. Jarak dan medan yang harus ditempuh bukan halangan bagi kami untuk terjun langsung ke lapangan. Kadang penuh keringat, kadang ditemani terik yang menyengat. Tak masalah, karena disinilah perjalanan kami bersamamu dimulai. Percobaan demi percobaan kami lakukan bersama untuk mencari mana varietas terbaik nantinya, yang kami rawat sepenuh hati dalam pengawasan terbaik, agar tiap benihnya mampu menyerap nutrisi bumi sepenuhnya, hingga mereka terus tumbuh sehat sampai hasil panen terlihat. Prosesnya memang panjang dan tak mudah, tetapi dengan inilah benih-benih terpilih sampai ke genggamanmu. Untuk kemudian dikemas menjadi produk cap panah merah yang akan membantu petani-petani selanjutnya. Kami sadar ada banyak hal yang masih harus dilakukan untuk maju bersamamu. Karenanya, pelatihan tercipta untuk kami, supaya bisa selalu siaga membantumu. Dan untukmu, kembangkan kemampuan bertani dengan bantuan ilmu serta teknologi terkini. Kami juga selalu siap menjawab setiap pertanyaanmu di setiap pendampingan yang kamu perlukan, kami ada untukmu. Dan ketika kami melihatmu berhasil, mendapat kesempatan, serta mencapai apa yang kamu mimpikan, itulah pencapaian terbesar kami dalam menjadi sahabat yang paling baik bagimu. Terima kasih telah berjalan bersama kami selama 30 tahun ini. Mari terus menjadi sahabat dalam berpuluh tahun mendatang. ICFAS Indonesia, sahabat petani yang paling baik.
ITS Sains Indonesia merupakan salah satu divisi bisnis dari ITS Group yang berkantor utama di Singapura. ITS Sains Indonesia menawarkan berbagai macam instrumen analitik dan medis, peralatan laboratorium umum, bahan kimia, dan bahan habis pakai lainnya. Selama lebih dari 40 tahun, ITS Group bergerak maju dengan visi memberikan pengaruh di dalam industri yang kami jalani. Kultur perusahaan kami untuk selalu mengedepankan profesionalisme, partnership, dan performance. ITS Group tersebar di berbagai negara Asia Tenggara, yaitu Malaysia, Singapura, Thailand, Vietnam, Indonesia, Filipina, dan Kamboja. ITS Sains Indonesia memiliki 2 kantor yang berlokasi di Kelapa Gading, Jakarta Utara, dan Suku Manunggal, Surabaya. Berikut portfolio produk yang kami representasikan di Indonesia. Produk-produk yang kami representasikan merupakan produk-produk unggulan di bidangnya. Selain itu, kami juga bangga bekerja sama dengan berbagai pihak, mulai dari lembaga pemerintah, industri, hingga universitas. Bila Anda memerlukan bantuan untuk laboratorium Anda, hubungi kami. ITS Sains Indonesia, Bridging Science, Inspiring Possibilities.
Saya kira kedepannya sangat baik prospeknya di kedua sisi ya, baik dalam peningkatan harga itu sendiri maupun peningkatan produktivitas di sapinya dengan daging nasional.
Dan kami harapkan bahwa SSP ini bisa mendampingi sampai dengan tahun 2026 atau bahkan seterusnya selama pengembangan Siska dilaksanakan di Provinsi Kalimantan Selatan.
Dengan mengucapkan Bismillahirrahmanirrahim, fasilitas riset pangan di Pusat Riset Teknologi dan Proses Pangan, Badan Riset dan Inovasi Nasional sebagai laboratorium rujukan riset halal Indonesia, saya nyatakan diresmikan.